Hi, Pablo.
Hi, Tom.
Hi, Pablo.
How are you, man?
Hi, Tom.
I can listen now. Did you stay most of the time on the server or not?
Me?
Yeah.
No, and actually, I think that the meeting was killed just like 5 minutes ago or 10 minutes ago. I mean, it was 24 hours again after like the previous case, and this time it seems that it ended completely.
Uh-huh.
So I started it again, and now the YouTube link is a new one, and I think we should update it on the web pages and maybe on Twitter.
Okay.
So I mean, I will send it to everyone via mail.
I can update it myself.
Okay, good. So I mean, I will just. Where is the email address? It's TUG2020 at TUG.org. Compose. New YouTube link.
I'm gonna go upstairs to grab a cup, one coffee, and bring it down here so I can drink coffee while we finish this.
Sure.
Back in here, man. Let me update those links. Right.
Okay, I send you an email with the link, and you should have it from the TUG2020 list.
Funny, you can't leave it on, huh? 24 hours.
Sorry?
You can't leave it on for more than 24 hours.
Yeah, I'm not sure what exactly happened, because I think that yesterday by this time it didn't stop the meeting. It just sort of like restarted itself, but the YouTube stream kept the same.
Uh-huh.
And this time it killed the YouTube stream. I mean, it was like just like, completely blank. So I think that we are back.
Did you you do have YouTube with permission to stream?
Yep, and that's exactly what I did. So now the stream is up. I mean, you can just check it. I think it works.
Cool.
I can definitely see myself, so and even hear myself if I unmute, but I don't want to unmute because then we get into a loop.
Yeah.
And also, I think I will make you a host because I will be leaving like in 3.5 hours. So better if I'm not the host, I think, at the moment.
Did you send an email with a link?
I hope so. To the conference list?
Yeah. Oh, okay. So the conference list. Let me get to that.
I hope I made the address correct. It's TUG2020@TUG.org.
Yes, got it. Got it. Tom, the whole workforce of Overleaf is all distributed. Got each person working in its own country, own city.
Yeah, well, not everyone. It's like I think about a quarter of the people are in London area, and the rest is like all around the world. I mean, basically the only office is in London. And it's like 1/4 of the company is there, and all the rest is like all around the world. Yeah, that's the case. So I mean, I'm in Prague. Eric, that will be speaking today, is in I think Montreal, in Canada. You know, Paul Gessler is in Milwaukee, which is I think in Wisconsin. And so on, you know. Lianse, you know her probably, maybe. She's from Malaysia.
Malaysia, my goodness.
Yes, it's like our Asian expert in some sense. And so on. I mean, it's like a very, very diverse group of people, and I mean, it's I consider it quite nice. So yeah. Also, it's like, you know, when everyone is working from home, you are sort of used to it. So when this whole COVID thing started, we were really like feeling
You're
almost
ready. You're ready.
Yeah, basically. I mean, only the London people were like, I need to get one specific laptop from the, you know, someone needed a laptop which was sitting in the office and the office was closed. It was like the biggest issue that the company had in some sense, you know. So that was quite nice. And also like all the technology with Zoom and Meet, we are quite used to it. So, you know, for me, making anything in Zoom wasn't new. So yeah, I mean, it works.
That's nice. Well, all the links have been updated. So
okay, let me check just in case, because it's always good to double check, I think, these things.
Oh, Norbert's talk is still on. So let's see, turn that off.
Yeah, that's good. So yeah, seems to work well. Stream via YouTube. Yes, so it seems that it's really updated. Good, thanks.
Thank you.
Yeah, I mean, I just followed the instructions by Will, you know. He said when this meeting has to be started, do this. So I just did that and it worked.
Cool.
Sounds like I'm not needed.
I will.
It's you, Will. Hi.
Will. He seemed to be there for a second.
Yeah, well, he is here, but he's muted now,
Yeah.
I think.
It has been so far a very nice meeting, very nice talks.
Yeah. I mean, quite unique in some sense, I think, but you know, and it's funny to see that. I mean, like some people use the opportunity of having the talk pre-recorded pretty well.
Yeah.
I mean, Paulo Sereda and LaTeX Ninja with pre-recorded talks, and they're like put together quite well and nicely.
Right.
I really enjoy these, and it's
Right.
it's in some sense I think more diverse because I don't think that Sarah would ever like come to the US for the conference. It's quite far away and stuff.
Mhm.
So I mean, it's quite nice.
Yeah, no, we're receiving messages from people from all over saying that they have never been able to see to visit one of the TUG meetings. And they were very glad that this meeting was online.
Yeah. So maybe that could be a plan. Like having every other meeting.
Yeah, no, we definitely should have an online presence no matter what. Even if the meeting is local.
Hi, Eric. Long time no see.
Hi. Hi, Tom. How are you?
I'm doing great.
Yes.
Just it's like almost 3 p.m. here, so I will be leaving
Ah,
at all because I have to go somewhere still this evening.
okay. Well, it's a great conference. I really enjoyed it.
Yeah, so far so good, really.
Mm. So yeah, I have a recording for my talk. So I guess I'll just
Sit down and relax.
perfect. Yeah, I'll be there for questions after.
We are what? We are 15 minutes away.
Hello, everyone. My name is Eric McSween. Hello, everyone. My name is Eric McSween. I'm a software.
Eric, are you going to say anything before we start, or should we go right into it?
No, I guess you can go right into it. We'll talk during the questions. It's very short anyway. It's like 15 minutes.
Thank you. Hi, everyone. Welcome back for the third large segment of TUG 2020 online. We starting the day with the first talk by Eric McSween from Overleaf, giving us an overview of how Tech Live releases make their way into Overleaf.
Hello everyone, my name is Hello everyone, my name is Eric McSween. I'm a software developer at Overleaf, coming to you from Montreal in Canada. Hello everyone, my name is Eric McSween. I'm a software developer at Overleaf, coming to you from Montreal in Canada. I've been taking care of the 2018 and 2019 Tech Live releases, and I'm currently working on the 2020 release. Today, I'll talk about what we go through to make the Tech Live releases available and how we try not to disrupt anyone's work in the process. So, all right, let's start. Overleaf is a collaborative online editor for LaTeX. It has plenty
Pablo, you cannot mute yourself. We cannot hear it now.
multiple files, and you may have supporting materials such as images, bib files, fonts, maybe some additional LaTeX libraries. We'll call this set of files a project. So let's dive a little bit into what happens when you hit the compile button. When you hit the compile button, a request to compile your document is sent to an Overleaf server through the internet. When the server receives a request, it first fetches your project's files from a database. Then it runs LaTeX make inside a Docker container. You can think of a container as an isolated environment for running programs. Programs running in a container are unaware of anything running outside of the container, be it directly on the server or inside other containers. They also have their own file system, which means that programs inside the container can't see or write to files that are accessible outside the container. And vice versa, programs running outside the container can't see or write to the files that are accessible from inside the container. So LaTeX make runs inside this isolated environment and eventually finishes producing a PDF file. This PDF file is then sent back to your computer to be displayed on the right side of your screen. So this is a sketch of what happens. There are many actual HTTP requests and responses to coordinate all of this, but that gives us an idea. Now let's go back to that container running LaTeX make. As we've just seen, this container has its own isolated file system, just like if it had its own disk. When the container starts running LaTeX make, it doesn't start with an empty file system. The initial file system already contains a bunch of files that you would usually find on a workstation running LaTeX. There's the Ubuntu operating system, there's TechLive itself, there's R, which is a software for statistics and producing graphs that can be used along with LaTeX. We also add some additional fonts and some configuration. And finally, of course, there's the project files that need to be compiled. All these files, except for the project files, are always the same, so they can be prepared in advance. At the time a compilation is requested, these files are available and ready to use in what's called an image. So the only thing we need to do is create a file system from that image and add the project files. Both of these are quick operations. So this brings us to the first thing we need to do when preparing a new Tech Live release for Overleaf, which is building that image. We start with the latest Ubuntu long-term support release. These are released every 2 years, but are supported for 5 years. So we're more likely to be able to easily update a buggy package if necessary. The latest is Ubuntu 2004, which was released in 2020, and will come with our Tech Live 2020 image. Our Tech Live 2018 and 2019 images came with Ubuntu 18.04, released in 2018. After that, we install Tech Live using the installer available on TUG2020. We install the full scheme, which also installs all available tech packages. Because these packages come from CTAN, the Comprehensive Tech Archive Network, and are updated throughout the year, we don't get a predictable version of these packages, but the version that happens to be available when we build the image. I'll come back to that later. After that, we install R, which again is a statistics and graphics software used along with LaTeX by many of our users. We also install a wide selection of R packages from CRAN. This one is the Comprehensive R Archive Network. So just like for tech packages, the versions of R packages that get installed are the versions that happen to be available at the time we build the image. We also install most of the TrueType and OpenType fonts available on Ubuntu that are not also distributed with TechLive. TechLive comes with many fonts, but there are others that are available on Ubuntu, and we install them as a convenience for our users. Finally, we add some configuration. For example, we add some LaTeX make configuration to support knitr, a program that compiles R and LaTeX code together to generate the document. There are also configurations to support other utilities, and in general, just to make things work. Now, as I said at the beginning of this presentation, we want to avoid causing problems for our users as much as possible. One thing we can do is test the image and try to catch problems and bugs before we make it available. Sometimes we make mistakes when preparing the image, but there are also many differences between two TechLive releases that are not necessarily backwards compatible. Some differences change how the resulting document looks, for example, changing where elements are positioned or how much spacing there is between things. Some other differences will result in compile errors in a document that compiled fine without errors before. So we need a diversified set of documents that we can try compiling and see if they work with the new image. Well, luckily for us, Overleaf just happens to have just that. There's a gallery of templates that users can use as a starting point for a new project. Here's an example. Most templates are contributed by users. Universities, for example, will publish their thesis templates on Overleaf for students to start with. We also have created templates for common types of documents or to show off some features of LaTeX. The gallery currently contains around 6,000 templates, and since they're used as a starting point for other documents, we review the templates before adding them to the gallery, and we expect them to compile without errors. That's what makes them good benchmarks for our new image. So testing the image amounts to running the compiler the same way it's run for real projects, but on every template available on Overleaf. Let's say we're testing the image for TechLive 2019. For each template, we create a container with the image for TechLive 2019, and we run LaTeX make just like we would do on Overleaf. At the end, we record whether or not the compilation succeeded without errors and how long it took. We also do the same thing with the previous year's image. In this case, it's TechLive 2018, so that we have an idea of what changed. Fortunately, this process is automated. Currently, it runs on my laptop and usually takes around 1 day to complete. If we wanted to do that more quickly, we could run as many tests as we want in parallel, but for now, running them one at a time is fine. After all templates have been tested, we split them into 4 categories that we can see in this table. Most templates usually compile without errors with both images, and we'll call them successful. Some templates ran successfully the previous year, but have errors with the new image, and we'll call them newly broken. Other templates were already broken the previous year and still have errors with the new image. We'll call them already broken. And finally, some rare templates were broken the previous year and now compile without errors. We'll call them fixed. Now, all these results are compiled in a spreadsheet, and it's time for our tech experts, Yancey, Tom, Paul, and Dan, to have a look at the problematic templates to figure out what's going on. Of course, they are mostly interested in the newly broken templates. The problems they find are sometimes bugs in tech packages that we can report or for which we can find workarounds. Sometimes they are due to backwards incompatible changes in a package. In that case, the template needs to be updated to work with the new TechLive release. If it's a template that we have published, we can update it, but if it's a user contributed template, we must wait for the original author to update their template. That's not as big a problem as it sounds like. We'll see why later. We're also interested in successful templates that have become significantly slower to compile from one release to the next. Figuring out why the template is so much slower to compile can sometimes point to some interesting changes that occurred in TechLive or in specific packages. It can also suggest some optimizations we can apply to the image that will speed up compilations. For the same reasons, it's even interesting to look at templates that are significantly faster to compile. You could find some surprising things in there. We also plot compile times on graphs to get a sense of the distribution of changes from one year to the next. This is useful to get an idea whether our new image is generally slower than the previous one and to identify weird outliers. We're satisfied that the image is ready to go. We upload it to our compile servers. From this moment on, new projects will be compiled with the new TechLive version. However, existing projects are still compiled with the previous version or whatever version they were compiled with before. This is because if we change the version used to compile a project, there's a chance the project will render differently or will just not compile because of incompatibilities between TechLive versions. For that reason, as you can see in that screenshot of the project settings, every project in Overleaf remembers the version it's compiled with, and this version only changes if the user deliberately asks for it. So if I started a project now, it would compile with TechLive 2019 because we haven't released the 2020 version yet. And even after TechLive 2020 is released, my project would still compile with TechLive 2019. However, any new project I create after that would compile with TechLive 2020. The same is true for templates. Templates remember which version they compile with, and new projects created from these templates will use the same version. So when we release a new version, we also upgrade the templates to use the new version, but only templates that compiled successfully. The templates that failed with the new version keep running with the previous version. That's why I said before that broken templates are not too big of a deal. So that's nice. We have released our new image. Hopefully no one has noticed and users will start using the new features in the new TechLive release without even realizing that something changed in Overleaf. But it's good to celebrate a little, so we publish a blog post. It's also an occasion to write release notes detailing everything we've learned about the new release during our tests. This includes new features, known bugs, and workarounds. After that, there's not much to do. We've seen how careful we are not to automatically upgrade projects to the latest TechLive version, but packages on CTAN change all the time, and any change in a package could break some projects. So how do we deal with this? It's actually quite simple. We just don't update CTAN packages. We actually don't update anything in the image, not tech packages, not Ubuntu packages, not R packages. After it's released, we freeze the compiler image so that we can guarantee as much as possible that your article or thesis or even book that was compiling yesterday still compiles today and produces the exact same result. There are exceptions and some updates are sometimes applied, but only when they fix a bug for our users. When that happens, we apply the smallest possible update that fixes the bug. This all means that the TechLive 2019 environment in Overleaf today is a snapshot of the Ubuntu packages, CTAN packages, and R packages that were available at the time the 2019 image was built. You won't get new features with this image, but you can rely on its stability. It will always compile your project the same way. If you want new features, you can wait for the 2020 release and upgrade your project. Or if there's a specific package version you're interested in, you can upload it directly to your project. If it's put in the right place, LaTeX will use your version instead of the version provided by Overleaf. So this is how TechLive releases are made available on Overleaf. We plan to do that process every summer because it's a bit after the actual TechLive release and there's a bit less activity on Overleaf. This process, even if it's quite simple, already works quite well. We're able to catch most problems before the release. Still, every year we try to improve it a little. One thing we could do is find other documents outside the template gallery to run in our benchmarks. It would also be interesting to see if we could run our benchmarks during the Tech Live pre-tests to help finding bugs. And finally, we noticed that compilation seems to get slightly slower every year. It would be interesting to figure out more precisely where the time is spent. So that's all I have. I'll be happy to answer any questions now.
All right, so that's it. Thank you very much. Yeah, I can answer any questions. There are no questions, I think, now in the chat or in the Q&A.
I have some questions. If I
Yes.
Since I'm allowed to talk, I just ask you directly instead of typing. Thanks a lot for this very interesting talk. Norbert Breining from the Tech Live team here. So I really like the testing you are doing for the stuff. I'm working since long on something like a continuous integration testing that is really based only on plain compilability. So I have two questions. First, do you actually only check that you compile a template, or do you also check on some congruence between the previous and the new versions PDF output?
Yeah, so we only check if the two projects compile. So we have tried that, looking at like visual differences, and tried to do it in an automated way, but so I've done it in 2018, but it turns up a lot of different results, because some packages will just like change the spacing slightly between things, and
yeah,
it's gonna like in a document with a lot of pages, it's gonna like throw away the so just like comparing the images is yeah, it's not super effective.
Yeah.
So at the moment we only look at, basically I'm running the same thing that runs in production, and look at if there are errors or not on both sides.
Yeah.
Yeah.
And the second question, since there is no question in the chat or in the QA, I ask, so I'm very interested in the suggestion you mentioned at the end, because I thought about this before even you mentioned it, running your tests during the pre-test phase. So I think we should catch up on this, I mean, afterwards via email or something, because that would be very interesting for us too, to get some, I mean, I'm happy to, I mean, do whatever is necessary to support you in this. We can run it also on my own computer, whatever. I would like to get more testing during the pre-test phase, since we had over the years many times released a new version and had to update stuff very shortly afterwards. And so I hope that we can get into contact afterwards about this still pre-test testing. That would be something that I would be interested to hear.
Yeah, that would be interesting. I added it in my slide because it's something we thought about this year, but like with things coming in, we didn't have time to figure it out. But yeah, that would be very interesting indeed.
Eric, we have you have a couple of entries in the Q&A.
Yes. So why not? So Jeremy asks, why not offering? Oh, it disappeared.
I scroll up and down. That window adds from the bottom and scrolls.
Okay. I have a.
So the question is, why not offering a still in development image like in Debian that would follow the daily upgrades of Tech Live? The users would be in charge of most of the testing work. It could be frozen at the end of the year and when the next release appears.
Yeah, that's an interesting. So yeah, that's an interesting thing to think about. There are some technical, maybe, yeah, I don't know if there are so many technical difficulties with that. But yeah, so yeah, it's something. Let's say I'll take a note of it. It's an idea I think we didn't pursue so much because like stability is easier. It's just easier on everyone. Maybe having it as a opt-in thing would be an interesting service. But yeah, I'll take a note of that. So if I understand correctly, that would be having a kind of moving image that just tracks.
Yes.
Yeah.
I understand is also that you have an image that is like updated once a day, or I don't know, once a week or whatever, with the latest update, like a rolling release more or less. So that I agree with Jeremy that this is an interesting point.
Yeah, I think technically it's not a. I think it's not a big deal. It's more into like maintenance support.
Yeah.
That's more
Yeah,
difficult.
well, I mean, I can add a point maybe to this thing. I mean, I'm for the overleaf support, and I already see how many issues we get with, and every new image, like every year, it's 2 or 3 months with increased number of questions about, hey, this doesn't work, and if I make a copy of my project, it doesn't work because the original project is 2019 or even 2016 sometimes. The new project is 2020, and so anything that sort of makes the site less stable is much more work for us, and it's much more confusing for our users in general. And the experience is that many people who do need completely new packages know what they do, and they have a local copy of TechLive anyway. So sort of the type of users that would benefit from this a lot are the users that can do it other way. So basically, that's maybe the point.
Yeah.
Okay, there was another question. I don't really see it from David Carlisle.
Oh, I see. I can see it. Oh.
Okay.
Yeah, so similar to TL pretest, it may be interesting to test with the LaTeX dev releases. Yep, interesting. Yeah, totally. Yeah, so this is something we'll yeah, I'd like to look at for sure. Alan Wetmore asks, if I have a long-running project, is there a way for me to request an update to the current version of TechLive so it won't be trapped in legacy forever? My project could then use new capabilities. So yes, so this is something that this is a feature we added this last year, and you can now in the project settings you can select the TechLive version. So it's so yeah, that's so now you can manually upgrade. We just won't upgrade it for you so that you don't get any surprises. Paulo asks, how many servers does the company have? Good question. So I think the compile server, so just for compiling, I think the number is around 50-ish. I don't remember the exact count, but that's the, and of course, like all these servers compile a lot of projects at the same time. Yeah, there's a lot of compiling going on. Yes, I think that's it. Did I answer everything? And was it clear?
One more question.
Yeah.
Are there any statistics about which TechLive version is used by how many projects, and how this is distributed?
Oh yeah, right. I didn't think to get that already. So well for now. So I really don't know. I would my guess is that people don't upgrade manually, so it would be just it's probably a it's probably like the number of projects that have been created when the TechLive version was the default. We've been on 2017 for a while, so I would suppose that a lot of projects run TechLive 2017, but I guess that actively developed projects are probably running 2019 now.
Thanks.
Thanks a lot, Eric. We have a short intermission now, and we're going to be back at 6:45 with Johan Tournade. And you're welcome to continue the discussion on the chat, on the Q&A. And Eric, please stick around.
Sure. And thanks a lot for the conference. It's my first TUG, and I really appreciate it. I learned a lot of things, and yeah, it's a great conference.
You are what makes TUG great.
Jonathan? You're producing background noises, I think feedback.
And Paulo, if you're around, can you let Chris in as a panelist? He is now in the attendees list and he would like to get into the panelist list.
I think he stepped out.
Yeah, but he's the only host now, so not
Yeah,
sure.
he's the only host, so it's.
Let me try something.
I have already upgraded him.
Okay, so it was mainly to check whether his mic is actually working, so not to have the same as before. So Chris, you're on speaker.
Can you hear me? Can you hear me?
Yeah, but you have an echo. Say again something. No, it's not good. Not good at all.
Yeah, that probably is explainable. I'll go off again.
Paulo, maybe can you make Frank a co-host just in case? Because
Okay.
you're the only host and maybe that's not a good idea.
Yeah.
I mean, I will be leaving, so it doesn't make much sense to make me a co-host, but Frank is probably staying for a little bit longer than me, so.
Yeah, I will be here also at least for another 2 hours or something.
Okay.
For you, it should be late already, shouldn't it?
Of course, it's late. What do you think?
Yeah. I don't know. It depends on where you currently are. If you're in Kanazawa, then yes.
There is no way to leave the country for me. Okay, well.
Oh, right. At the moment, that is a problem.
Well, I can leave the country, but I cannot return.
Yeah. Okay. Yeah, I see that. I see the point. That's not much better over here. You can't really go anywhere.
Really?
Well, I mean, you can, but you don't want to. You end up being suddenly getting like now. I mean, the UK has just shut down everything.
Yeah, but
for people
example,
coming.
friends of mine went to Italy from Austria also to the garden.
Yeah, of course you can, but then the government suddenly decides that everybody coming from Italy or from Spain has 2 weeks of
quarantine.
Yeah. Right.
Okay.
Anyway, it's a bit of a gamble, let's say it this way. It may not be as bad as at your end.
Well, actually, the situation is much safer here. But, you know, the Japanese government knows exactly that the coronavirus checks the passport. So it allows Japanese to go out and in at will. But foreigners living here are not allowed to come in. Because obviously the coronavirus only attacks people without the Japanese passport, right?
So you know what you have to do. You have to get one.
No, never.
Okay.
Oh.
I will now give you a guided tour of my computer work area.
Hi, Ivan.
Hi, Paulo.
You should probably have about a minute. Hi, everyone. Our next speaker is Johan Tournade. He's going to be talking about LaTeX on HTTP, LaTeX as a cloud document edition service for web app developers. Please have the podium.
Okay, let's go. I'll share my screen. So, hello everyone. I'm a developer from France, and we talk about how to make LaTeX more accessible for modern web app developers. So, how can the developers that develop all our web application or IT systems can rely more frequently on LaTeX for the PDF edition needs. So first, a consultation or a question is maybe why is the PDF generated by all the IT systems, like maybe your billing invoice or your insurance contract, generally not really well typeset? And the answer, of course, is that the developers that automated this PDF creation didn't use LaTeX in their application. But when we have said that, we have still a question, and this is why this developer do not use LaTeX and for producing high quality documents, and that will manage all the typesetting parts of it and will give good results most of the time. And I think there are three reasons and three categories of reason. One, I think, is a bit of custom in the developing world. All the majority maybe of web app developers know LaTeX. They know it as a also as a academia thing. So in their heads, LaTeX is this great thing for making scientific papers, maybe editing their resume, but they don't think LaTeX as a solution for their web development needs. So when they will come to needing a solution to edit PDFs in their application, that won't thought directly of LaTeX. The second reason is more obvious, and this is all the technical barriers to using LaTeX in a web application or on an IT system. The LaTeX runtime requirements are, and the main one is that LaTeX runtime requirements are rather heavy and maybe complex to use. For illustrating this point, I have these images where you see maybe tools that could allow to install LaTeX on the server. That could be TextLive, but it takes many gigabytes for a complete distribution, or using Docker images, but also it is kind of heavy images. Then the developer will have to hire, in most companies, on most setups, we have to hire with the people that run the infrastructure for the applications, so the DevOps or the administrator systems, to add these dependencies to the application and then to maintain them and manage them. And so the DevOps may answer we really need several gigabytes of runtime for just editing a PDF. So when the need for typesetting is there for making PDF is there, but it's not heavy. It doesn't require really high quality. This is not a main requirement. Most developers won't go this route and won't choose LaTeX, maybe because of that. And the third group of reason maybe is the documentation and the sharing of knowledge. I think in this part, it is half very good and half very bad in the point of view of developers. Are very good because if the developers need to find templates for editing invoices, insurance contracts, reports, letters, you will find plenty of them on the web. There will be many choices and it will be able to construct from that on. But the bad part is then you have your templates, you need to compile it, or I do it in my in my application. Maybe I'm a web application in the client side and I don't want to have a big dependency because maybe some people use old mobile devices or I don't know. Or maybe in a cloud environment where I don't have a full control over what runtimes can go there. So, well, how I do it? There I think maybe it means some hello world on getting started kind of knowledge and documentation, like you can see for the solution. So before presenting my tentative solution for that issue, first a little panel of what application developer use most of the time currently for editing their PDF. Someone has his mic open, I think. Yeah. So there are three categories, and the two main ones. The first is HTML, CSS, PDF converters. There are many libraries, some of rather good quality. So we take HTML, CSS of web pages kind of code and create a PDF from that. They are good for developers because they use language that developers already use. They can share some code and they will work rather rapidly to a solution. The second group of solutions are all the instruction-based PDF generators, so that are libraries that have been created in the language of the many languages, in the language used by the developer, Python, Node, PHP, and that will allow to create the PDF from a set of instructions like please add some text there, add an image, this part of the PDF, and all that. So this solution, and there's a third group of solution, and this is using Office software or browser in an headless mode to convert Office documents or web pages to PDF. So these solutions are working for the developer. They're creating PDF, but when it comes to the typesetting quality, this is really not at the level that could be attained with LaTeX codes. So what we can do? Maybe what we can do is try to have a ways that the good part is there. LaTeX templates, developer can find them. So we don't have to address that for now, but to address the second part, or to compile the documents in application, in modern application. And for that, and my own needs, I started to develop LaTeX on HTTP. And this is a solution that try to put LaTeX behind an HTTP API. So an HTTP API is a web service that modern developers are using daily to creating their application. Some are very known web services and commercial web services are the AWS Amazon Web Services, and there are many solutions for sending an email, for taking payments. So users know how to use an HTTP API. This is very familiar for them, and so the game will be to take a LaTeX complete job and put it behind the HTTP API in a way that is easy to understand for a developer. And so, in a sense, we will go in a demo to show how it can be used and how it works. But in a sense, this is a bit like Overleaf, but not for the person that needs a LaTeX editor with LaTeX code and then the LaTeX PDF, but Overleaf for the developers, so they will take LaTeX input, resources, files, and they will run their PDF. So they don't need the editor, but they still want to make their compilation with the web interface. And so for the demo, we'll take a little scenario. We'll say we're of course a web developer. We have a client or boss that asks us to add PDF in its freelancing platform to create beautiful invoices and proposal. And this is important for the platform, for it to work well and to have clients that sign the proposal. And let's say the boss wants it in 2 days because everyone in a hurry. Okay, I change just the screen up for the demo part. Let me go on board. Okay, tell me if you don't see the code every time. So let's say I found LaTeX on HTTP solution, and I will try it to see if it can fit my need to edit my PDF, my invoice or proposal. And I've seen the LaTeX on HTTP documentation. It tells me that I can compile LaTeX with an web request. So I need something to do web request, and we will use something that is very frequently used in Python for doing web request. And we will do a web request to the LaTeX on HTTP services and to an endpoint created for compiling a document. So we put the addresses, and then we'll tell what to compile. And for that, we will pass a set of resources or files to be compiled, like a main LaTeX text file. So first, we'll just pass an hello world file.
Johan, one interrupt, sorry. If it's easy possible, you could increase the font size a bit. It's hard to read on the...
Yeah.
Sorry.
It is better or more, still more?
So for me, it's better now. Thanks.
Yeah, I still would go. This is better.
Okay.
Much better.
Right.
Thanks a lot.
So we'll give just one hello world, and we'll pass it directly as a string directly in the request. And so let's do. I will do just the typing for this first part. So my hello world And this seems to be hard to begin with. So we will make this request. We need to get a hand on the response. And when we have the response, we can try to write it on a file. So this is how you do it in Python, if I'm not going wrong. And so we will take the content of the request and writing in a file. So let's try that. If I not my side, it may work. And so we have run it. So just run Python demo, and it has written a file or hello world LaTeX documents here. So this is really this document that is being compiled. We can try again. So that is a good first part. But now we want to do a proposal, and so we need something more than just an hello world. So we try to add a document, and so add a LaTeX template. And maybe to get started, I've pre-selected template. Let's take a simple template. This is a letter template that I've just copy paste from the web. So now we need to first read this document and pass it to be compiled. So I will take so we open our template and we will pass it up. The file that we have read. So this is still a string, and we try to compile that. So here we go. We have a more complex template that have been compiled, that we have written from a file, and we have our letter. So now we really want to go for the real thing, and we try to we go on the web and we try to find a template for an invoice or proposal. So it is a proposal. And so I've just changed the template code. And so, well, this is template that I've taken from Mr. Zul invoice boilerplate and quick template. And I've just updated it to add a bit of content to make it look like a proposal. So we compile, and there seems to be something wrong. So actually, there is an error during this compilation, and we don't look at the result to see if there was an error during the compilation. And so first, before going forward, I will look how we can fetch the error and check the status of the compilation. So when we send the file to compile to LaTeX on HTTP, this is an HTTP request, and it has a status code that tells us how it goes. And if it is not a 200 like status code, there is an error. So if there is an error, LaTeX on HTTP will return us the logs of the compilation, so we can have a sense of what's going on. And here, if you look at the logs printed on the console, you say something, maybe I don't use the right engine. And so let me introduce to the way to choose LaTeX engine to compile on LaTeX on HTTP. By default, it uses PDF LaTeX, but you can choose another engine, and from the following part, we will use the LaTeX. So we try again with the LaTeX. We run again. And we have, seems like another error, and it tells us, because there is an image in this template, there is no image during the compilation, logo.png. LaTeX HTTP doesn't have this image, so it can't compile the file. So we will need to add another resource with the image. And for that, there are many things. First, we have to tell that this resource is the main document. So LaTeX HTTP will try first to compile that file, and then we can pass as resources as we want for other things. And we miss an image that must be logo.png, and so we can specify for the other resources which path will be used, and we can then pass not only a string, but we could pass also an URL, and the services will, during the compilation, fetch the URL, and if it exists, put it on this path to create the hierarchy on the server side to do the compilation. So it seems that we should be good this time. We try. It's taking a bit more time, but it seems to have worked. And yes, so we have a proposal, the images that we have passed as an URL, and the template of the proposal. So I'm the web developer. I need to edit this PDF for a proposal. So no, of course, my content is dynamic. I must change the content of my templates from the data that I have on my database, on a persistent or storage service, whatever, and wherever it came from. And so for that part, we will use directly in Python a templating language that developers are familiar with Jinja. We could maybe do templating directly with LaTeX engines, but then web developers don't know that, or most of them. So they would use a tool that they know, and in their code, they will do the templating. So let's go. I will copy paste all this code because it's beginning to be a bit of typing, but I will show you around. So with this templating engine, TUG2020, and first we must configure it a bit because it uses the same special characters that LaTeX could use, and so we change the character used for templating, so we don't have too much conflict. But the interesting part is we will load still from the local file that we will change right now, the file, and we will do templating on this file. So pass data on this file, and we just pass an author name and a list of services prestation to be included in the template. And so let me grab the updated templates and we will look at it. Okay, so here we have our templates, and now we're able to, with the Jinja templating language, to insert variables that we will inject in our Python code. So here we'll inject the author name, and in the list, in the table of PlayStation, we'll do a loop. We will go for each PlayStation, and we will add a line. So a line with the title and the price. And let's try that. So here our system works in two parts. First, in our code, it will replace the Jinja template variables by the content we give it, and then send it to LaTeX on HTTP to compile it. So let's see how it looks. So it has replaced the name. And if we go for the PlayStation, the content has changed. So of course, then we will have to make the templating for all of the documents. But our developers know at this moment, he knows that he can do it. And maybe finally, to show maybe one thing, let's say we have we want to change this logo by an image that is local or that comes from a database, and we will be able to do that. We will work rather rapidly on this part by opening our input file, our logo file, and then instead of passing an URL for this file, we'll pass the file as binary, and so as it is passed in JSON, a serialization format, we put it in base 64 for that to work. So this is just to show that we can pass files as a string with an URL, as we have seen before, but also as binary. So we can send font files or images for the compilation process. And so here we go with our new logo that's been compiled with the new logo. And the last part was maybe to show, but it's not really important, that then the developer can also generate part of the content, of the LaTeX content, directly in his code if it feels more comfortable with it. It may be not the optimal workflow, but if it works for the developers, then it will be fine. And so let's see. So here we generate some content, we put it in a string, and let's say this is a partial part of our document. And to show maybe one last thing is we can, of course, have other tech documents send it to be compiled. So we pass this generated part, and we say the path will be partial.txt, and then in our templates we could do an impute or an include of this path, and it will be known when it will be compiled on the LaTeX HTTP service. So go back to slides. I don't know how much time I have, but I think I'm near finished.
You still have some time because we have about 15 minutes left.
Okay, good, perfect. So maybe so 2 minutes before maybe taking question. So during this scenario, we have shown that maybe we have succeeded to remove the big barrier for modern web app IT system developers to use LaTeX for PDF edition in their system. And that is removing the need to have real-time requirements in their infrastructure and to manage these real-time requirements. And they can be started only with an HTTP request and HTTP clients. They already have them, so they actually don't add any real-time requirements and dependency is their application. So that make it pretty trivial to get started, and then our developer will need to work and to learn a bit of LaTeX to find good templates for it to really work and to be accessible for them. For this project to have a future, because this is still a project in development, I first created it myself for my own need of typesetting automation for my invoices and proposal, and for allowing all of my team or group to compile this document without having to install LaTeX or to know about ctine packages or any of that. But not to make it accessible to others, we must create high-level documentation with code that can be copy-paste, with a sample in different scenarios, like we have seen today in the demo. Must create some promotion material, a website to explain how it can be used, and also for making still easier to use, to add language wrappers. So for example, Python libraries, Node libraries, PHP libraries. So it is still easier to call and to use, and to include facilities, for example, for including the resulting PDF directly in a web page and with very easily. And also, of course, we still have some developments addressing scalability, security, maybe the packages or fonts or many other things that are available for the compilation. And to conclude this talk, I want to thank Jonathan Fine that has found and used my project for learnlatex.org, and that invited me to talk about it. And of course, this was not also the first system to put LaTeX behind an HTTP API. There was other inspiration, like Andrei Lunikov LaTeX Online, which is also good, but I think less oriented for developers, like I intend to do. And of course, the backend for Chair LaTeX or Overleaf, with the project CLSI. And if you want, you can read more Git feedbacks, contributes on the GitHub repo, ITOTech LaTeX on HTTP. There is a live interactive demo where we can play with templates and variable interpolation, and just give it a try. And you will see the requests that are generated. And so it's a good way to have a feeling of how it can be used and how it works. And finally, you can mail me for any feedbacks or anything. So I will look at the questions.
Yeah, so first of all, thanks for your talk. Very interesting. There are some, I see one question in the QA session. Maybe you can answer that.
Yes, from Jamie Just, that has already contacted me, and thank him for his first feedbacks on LaTeX on HTTP. So the question is, I'm afraid the typical web developer will not feel safe in front of backslashes and curly brackets, even if you already did most of them. It will be interesting to integrate speed data that we saw yesterday to your systems so you can take XML as inputs. So the great insight, integrate speed data. I don't know if I think it is a commercial solution. So we have to see how it could work. Web developers love XML, but modern web developers now love still more JSON as a serialization format that is ubiquitous now. Maybe for addressing this issue, this is where the library wrappers for the different language will be useful. You could have a library wrapper, for example, in Python that take care of escaping or managing all the backlashes and all the special characters of LaTeX, or making sure that the content that you inject in your documents will not conflict with the LaTeX codes. Maybe also another way to make it still easier for the developers and at the first time is to reduce the need to have to look at the LaTeX code, and Pandoc could be used for that, as it could allow to transform Markdown or HTML, CSS to LaTeX and so work from them. Another question from Edgara. So what about time delays for very huge file with a lot of graphics? So this is a great question, and a part where there is still a lot of work on the project to do. For now, I don't think I have set a delay, so we do an interesting thing. I think the HTTP request will finally delay timeouts, but this is a good question. Is it possible to add custom packages and resources? So from now, maybe just let me
share it again.
Right, share my screen like to scan. Is it possible to add custom packages and resources like fonts? For now, I try to add some anticipation features to the system. So there is an on-prem packages where you can look at all the packages that are currently installed on the instance. And this is a full shell instance of TextLive. And there is also another endpoint where you can list the fonts that are also available during the compilation. But if you don't have what you need there, we will need to find a way, of course, to customize that. And I think that will work out maybe to have a version that took a registration and maybe a bit of commercial version with a bit of commercial support to allow more customization on the instance to add your own packages and fonts and so on.
Yeah, I have a question too. It's about security, especially with shell escape enabled and interference of different runs.
Yes, yes, good question. This is not properly addressed for the current version. For the current version, run in a Docker container, so in a sense isolated from its environment. But we need to make a bit like Overleaf has done, and to run it to run each compilation in its own container, so there won't be pollution between the runs. This is of course really important for it to be used extensively. Of course, LC will rapidly crash.
Yeah, because I mean, if you open up the API for arbitrary requests, then you want to be sure that there is, I mean, even if there is rubbish sent, it doesn't interfere, right?
Yes, yes. Docker isolation for that, we will have to look at the cost to create a new environment, Docker environment for each run, and contrary to Overleaf, where an environment I think is created for each project. So then you can use the same environment for each of the compilation project. We will want to have a new environment really isolated for each compilation job, and that it's done from clean slate each time. So we sure we doesn't go bad.
Thanks.
There's a question about the price over on the chat.
So this is an open source project that you can find on GitHub. There was a link. I will put them again in the chat. And you can run it yourself on your server, on your infrastructure, thanks to the Docker images. But then maybe we have to, like all the good cloud services, we have maybe to make a commercial version, or at least a managed or well-hosted version, and that could offer support or maybe assure compilation speed or some other issue for a professional user. From now, there is an instance I run on one of my server on latech.itotech.com, and you can use it freely. But of course, the current version, there is no assurance that if a lot of people will use it right now, that will take the load. It's the question about making scale, and that's where maybe creating a venture to allow us to fund some infrastructure will ensure that we have maybe a public version that will work well for everyone, maybe with some reclimating, but that will work, and that with hosting funded.
Thanks very, very much, Jon. Very nice project, and I'm certainly going to be looking at it.
Hello.
Jonathan, are you there?
I am now. I had to do something before my talk started.
Okay. Join us in video?
Sorry?
You're going to join us in video?
Yeah, sorry, I'm here, you can see me. I've got scratched ears.
Well, we have still 2 minutes to go.
Okay. You've got the video, haven't you?
Oh, sure.
Good. Seems to be all working well now, which I'm pleased with after the difficulties last time, part of which is due to me, because never try new technology without giving some time for problems. And it's harder than I thought, combining video files.
Yes. Video editing is in its infancy.
I wasn't even editing, I was just combining them.
Well, I disagree that it's in its infancy. There are a lot of very good and easy to use programs, but I mean, it needs some usage and some experience to do it properly. This is not about infancy.
Thank you, Norbert, for your expert information.
it does feel a lot like using ebcdic on a file.
Okay, so sorry, everybody can hear me. Good. What's going to happen, if it's all right, Paolo, is that I didn't get to record an introduction for the talk, and that's going to be quite helpful because it will give an overview. So I'd like to spend a couple of minutes giving an introduction to the talk, perhaps a little bit longer. Then we'll play the video. The video is 23 minutes, and after about 15 minutes, I think, there's a good place to stop and have questions. And then, depending on how things go, we can have the rest of the talk, because otherwise we'll have lots and lots of topics and lots of questions, and they'll come in a jumbled rush.
So I would suggest we start it. It's time now.
Yeah. So should we play the video completely and then go back to you?
No. During the video, I'll say, Paolo, is you're playing the video, Paolo?
Yes, I'm playing.
When I ask you to stop playing the video, could you do that? And then we'll have a question session.
Okay, cool. So let me introduce you to Jonathan Fine. He's going to be giving the second talk of his on this conference. We're glad to have you with us. And without much ado, please take the stand.
Okay, the first thing I want to say is that I've learned a lot at this conference, and it has inspired me to change somewhat the material I'm presenting, and I've got a different title, which is Tech, LaTeX, the User Experience. So there's a big focus on the user experience. A lot of the credit for this goes for Sarah Lang and the ideas that she's been promoting. So I'm going to focus on two sorts of users, authors and readers. The other talks have focused a lot on developers, but I think authors and readers, particularly readers, we need to pay attention to, and there's more to readers than typography. Now, I'm going to give an object lesson as to why user experience is important. We owe a very, very important advance in tech to the dissatisfaction of an author. Does anybody here know who that author is? Well, I'll tell you. In 1976, Donald Knuth was unhappy with the quality of the photo typesetting of his book. For those that don't know it, photo typesetting is a technology halfway between hot metal typesetting and computer typesetting. It's an analog technology like hot metal, but it's using electronics to control the composition. So in 76, he was unhappy with the way in which his life's work was going to be published, and the time was right, and he decided he would solve the problem by writing a typesetting system. And in 1982, we had Tech 82, and in 1984, we had the Tech book. So this is one of the things, this is my example of why user experience matters. And to pick up randomly on something I heard during the conference, somebody said, we want to improve the website. Well, you think, well, that's a good thing, but let's think about it. We want to improve the user experience. And depending on what the problem is, improving the website might or might not be the right thing. It might be better to say, if you have problems, phone this number. You'll get more sales that way. So focus on the user experience doesn't mean we don't improve the website. It means we ask the right question. What is the user experience? So I'm going to run through what this talk is about. It's 10 small talks, all very small. The first one is about large monitors. The second is about reading on large monitors. The third is LaTeX syntax check. The fourth is standard LaTeX mathematics. The fifth is accessible formulas. All of these focused on user experience. And at the end of those 5 topics, we'll have a break for questions. So if you've got a question, pop it into the Q&A as it comes in. And when we get to the break, I'll try and answer what I can. And then, depending on how things go, we'll either have the rest of the talk or we'll continue with the question and answer. So can we go over to Paolo? And can you start the video? And fingers crossed I've done everything right this time.
I will now give you a guided tour of my computer. I will now give you a guided tour of my computer work area. Here it is. It's somewhat unusual. It has two desktops. The keyboard is on the horizontal desktop. The black rectangle you see is a computer monitor. That is the vertical desktop. It is in fact a 40-inch 4K television. Between the two desktops, there are two checks from Don Knuth, neither for problems in tech, I'm afraid. To the right of Einstein is a Raspberry Pi 4, which does 4K at 60 frames per second. The two desktops, vertical and horizontal, are about the same size and about the same importance. By a large monitor, I mean one that's 4K resolution and size 40 inches or more. Most TVs sold today will, I think, work also as a large monitor. Now, a standard desktop monitor has a 16 by 19 grid, where each grid box has 120 by 120 pixels, whereas a large monitor has a 32 by 18 grid, with each grid rectangle still holding 120 by 120 pixels. Now, with care, on a standard monitor, you'll be able to show and read two PDF pages side by side. A large monitor will be able to show 8 PDF pages at the same time at the same resolution. This is because there's 2 times 2 as many grid boxes. Now, taking advantage of this enormous space is hard. I found by experience that there's a software gap for window managers that work well with large monitors. For example, a button that expands the current window to fill the whole monitor is of no use at all. It's just enormous. I think that our community's design skills, working with typography and grids and arrangement and organization of complex information, might help the people that write window managers and design window managers to make a better job and to solve this problem. There'll be more of this in the next topic. Next, reading on large monitors. What's it like to read a PDF on a standard desktop monitor, not a large one? What's your experience? Well, I find that the PDF is taller than the monitor, and that's a problem. But with a large monitor, it's the other way around. The monitor is taller than the PDF. On a large monitor, 3 pages side by side is comfortable, and they're at larger than life size. But we can do better than this. When reading a book, we want to have a look at table of contents, index, current page, figures, and perhaps bookmarks. Now, isn't it odd? We can bookmark a page in a book. We can bookmark a web page. We can even bookmark a section heading in a web page. But we can't bookmark a page or a component of a page in a PDF. Well, the developers that use HTML5 have experience in solving these problems. They have experience in making complex information easier to navigate. So here's a remedy. Use tech to produce, for each paragraph in your article, a rich SVG. and then ask the HTML5 developer and a user experience expert to solve the problem. We supply the information, they provide the solution to the usability problem. There may be some to and fro to get things right, but that's the basic way in which I think we can greatly improve the reading experience for typeset output on large monitors. And over time, this will develop. When you do typography, the first thing you ask is, what is the size of the page? When we do typography for a monitor, we ask, what is the size of the monitor? We have a large one, or at least I do. Next, LaTeX syntax check. We want to help users avoid the pit of despair that is complicated tech error messages. In fact, I might find it useful sometimes myself. Having this checking will really help us retain and advance new users. Sarah Lang's talk yesterday encouraged me to talk about this. I hope she thinks it's a good idea. So what's the user experience we want to have? We want syntax errors to be detected before tech is run, and perhaps even as the author types, to provide feedback as to where the author is. The checker should report errors and suggest remedies. In particular, it should be able to fix the document left to itself if that's what the author wants. And we want users to report syntax errors that haven't been caught to developers. Every time a user gets a syntax error that we haven't caught, there's an opportunity for us to improve the software. And finally, in something like MathJax, when you type \frac, when we get to the C, we have a defined control sequence that takes 2 arguments, but they haven't been supplied. So in the display, why not produce a fraction with question mark over question mark? In other words, we fix the error before it gets to the MathJax processing. Now, some words about the implementation, because I don't think it's that hard once you approach it in a sensible way. As we build the parse tree, we keep a record of how to get out. That's it. Every time the parse tree is changed, we keep a record of how we're going to get out of the problem that the user has created. It's all a bit like using a length of string trailing behind you as you go into the maze so you can find the way out again. Or if you prefer, leaving a trail of breadcrumbs behind you, as in the tale of Hansel and Gretel in their wandering in the forest. Next, standard LaTeX mathematics. This affects users who work both on web content and on PDF. This is a continuation of the previous topic, the syntax checker. MathJax and traditional LaTeX mathematics are not always exactly the same, and this can cause problems. For example, copy and paste might not work or give a surprising result. And it's also more to remember because the differences have to be remembered by the people who work in both areas. And it also means more documentation exists that duplicates itself. It's more documentation to read and to write and to search for. So the remedy is a checker, as before. Wouldn't it be great if the LaTeX team and the people that develop MathJax could agree on a standard for LaTeX mathematics? The stuff that meets the standard will work identically in both areas. Now, this will be harder to implement than the LaTeX syntax checker. It's a deeper matter. And even if we don't do it completely, making progress will help. And I think this is a problem worth tackling. I think its results will be worthwhile, will have a long-term benefit for our community and for our users. Next, accessible formulas. Here, the user is a student with a disability. Sometimes a whole document is accessible or can be made accessible, except for a few islands of mathematics. For example, suppose a biology course on population growth might rely on some key equations. Not many equations, but they're really important and they're what we want the student to understand as part of the course. Now, the whole document very often can be made completely accessible via standard automated methods, except the mathematics, which is unfortunately absolutely crucial for understanding the material. So this will delay publication of the accessible version of the documents until a human being has resolved the problem with the mathematics. So what's the user experience? The user is a student with disability and their experience is nothing. Or rather, they get the stuff much later, significantly later, than the able students. So their experience is frustration, and regarding accessibility provisions, perhaps they've been let down. So what's the remedy? Well, this won't fit every case, but for use on web pages, produce the mathematical formulas as accessible SVG and make sure that the framework that provides accessibility on web pages also provides accessibility for the SVG, which is not a dumb graphic, it's part of the web page. Now, this is often much easier than making the whole document an accessible PDF. Sometimes accessible PDFs are the right solution. Sometimes going with what people are already using, and if it's web pages is the best thing to do. I should say that my opinions on this are based on my work and experience at the Open University in the United Kingdom, which is the UK's largest provider of distance learning with a large number of disabled students. I've worked at the Open University as a LaTeX and math content expert, and this included providing technical advice regarding accessibility decisions and problems. Next.
You back live?
Back live. So, opportunities to ask questions.
On the Q&A, we don't. And neither on the chat. So we should announce for people that you're taking questions right now. So if you have any questions, we're taking a brief intermission, and Jonathan will play the rest of the talk after this brief intermission. So you have the stand.
Maybe not really a question, but more of a comment, but I was a bit surprised about your statement regarding viewing PDF files and web pages on big screens, because I have basically the opposite experience. I have also a 40-inch monitor and experience mostly for table of contents and bookmarks that they are much easier to see on in a PDF page, because you actually, most PDF viewers actually allow you to show them wherever you want, while most web pages have a pretty fixed layout, which is often specific to some layout which doesn't really encompass the idea of splitting the page vertically.
That's a very good question. One of the problems with the big monitor is it's so big. I think, as I said, making something full screen on a big monitor is generally a mistake unless you're sitting at the back of the room and using the thing like a television. So if I want to watch YouTube, for example, and I'm sitting at my desk with a big monitor, I don't want to make it full screen. I want to make it, I want to have a window in the middle, which is full screen as far as YouTube is concerned. And similarly, if I'm looking at a PDF page in the sort of traditional way, I wouldn't want it full screen. Now, when I'm talked about bookmarks, I was being slightly dishonest or lying slightly, which was in the context of a web page, bookmarks exist for the web page, but not for the PDF. In the context of a PDF viewer that's dedicated to that purpose, yes, you can bookmark it, but it doesn't give you a URL. So I was using the bookmark secretly to mean something that's got a URL that you can share with people, so you can send them a URL for page 57. And I don't think any of us really is set up to open a bookmark to page 57 of the PDF file. So that's why I was talking about what I said. I'd be interested to share with you the experience of working with the 40-inch monitor, but I don't think that is of general interest except as it relates to the talk. I think some questions are coming in on the chat. I'll have a look at those now.
Yes.
Okay. James Carson asks, does MathJax offer some accessibility options at this time? Yes, it does. I haven't looked into them closely, but they do offer them. And because it's JavaScript and an open source framework, they're certainly customizable so that they can give you the accessibility options that are appropriate for the institution and possibly the user. It also means that you might be able to use it for purposes such as clone this formula. You want to sort of click on a formula and say, well, this is nearly the formula I want, and very quickly open up something that will allow you to create the formula you want using the previous formula as a starting point. So there's that. Now, Martin Ruckert has said, syntax checking in LaTeX is, I think, only possible if you define a proper subset of LaTeX. LaTeX for dummies. Will that meet your idea? Well, actually, I'm not the one who's promoting at this conference a proper subset of LaTeX, or rather, I'm not the only one. Frank Misselbach is promoting that for reasons of accessibility. In order to have the document do more, you have to take away freedom. We take away the freedom to do various things in order to promote public safety, in order that we live longer. We're not free to drive on the wrong side of the road, and in certain circumstances, we should not be free to do other things in a LaTeX document that might otherwise be permitted. And if we want to be able to produce accessible outputs, we might have to say, you're not permitted to do such and such. So I hope that answers Martin's question. James Carson, regarding syntax checking, that is what mini LaTeX is, subset, and offers some on-the-fly syntax checking with now with improvements planned. I have to say that the word wrapping in the comments page is terrible because they don't wrap words, they just chop them off at the end. If only they could put typesetting into the comments page, and then we could put mathematics in there too. Now, Jim, thank you very much for that comment, and thank you very much for encouraging me to look at mini LaTeX, because that was one of the inspirations for what I was talking about. And I dare say anything sensible I said in my talk about syntax checking was because I was following your sensible example. So you should have had a credit too, as well as Sarah. Now, looking at the time, we can take some more questions if we want them, or we can get the rest. Perhaps we could take a couple of deep breaths. Yes, Martin says, don't use make at other. Yes, don't use the master key. In fact, if you can, take it away. Yes, if we're to convert, there are things you can't do in an XML document There are things you can't do in a JSON document. And it's because you're not allowed to do those things, the systems operating them can make assumptions and behave reliably. If you try and make something that behaves reliably with every input, you have an enormous task. And that was the situation that existed with HTML before HTML5 came along. With HTML5, they said, we're going to iron out all the differences. And a large part of the HTML5 specification was to say, in every edge case, this is what happens, and every HTML5 browser does exactly the same thing. And if there are edge cases between standard LaTeX mathematics and MathJax LaTeX mathematics, if we can iron out the differences so we always get the same behavior, henceforth, lots of things will be easier, and we can reliably cut and paste from one to the other as long as we know it's standard LaTeX mathematics. So with freedom comes responsibility. And to obtain ability, we have to restrict ourselves sometimes. I think I should stop and ask Paolo to play the last of the talks, but before I do that, they're mostly short, and much more technical. TEC as a callable function, value-added typesetting, LaTeX to XML, read and write the docs, and a summary.
Okay, so we go back.
Next, TEC as a callable function. The problem we're dealing with is slow interactivity. So MathJax reacts quickly because it's stateless. So it's just waiting there ready for the next keystroke. Whereas LaTeX has got a lot of state and it has to reinitialize itself every time. And that makes it slow. Now, you can set up TEC to be a callable function. So it runs the same way as MathJax with the same performance as MathJax. And it's not a theoretical possibility, provided a web service doing it. And in the modern time, it's actually more important than that again, because you can put JavaScript, use JavaScript to implement TEC in the browser. So actual genuine TEC runs inside the browser. Now that's going to be really slow. But if you set it up so that the browser-based TEC is actually running TEC as a callable function, it becomes a lot quicker and you regain what you lost. And this gives you an independence from a network service. You don't have to maintain or run a network service. You don't need a network connection. All works a lot nicer, and it's an alternative worth having. So it is possible, and it's fairly easy to set things up so that TEC runs as a callable function. When I say easy, I don't mean there's no work involved. I mean the ideas are fairly simple, but you have to implement them, and that requires a certain amount of grunt work. If you want to know more about this, you'll find them in my article, TEC as a callable function, which is in the proceedings of the 2001 Eurotech conference, where I gave a talk about this and a live demonstration, as I recall. Also related to this, a project I did called MathTran, which is where I actually implemented it as a web service. In 2001, it was just a concept. I got external funding from JISC for the MathTran project, which is something I'm really grateful for. I also got some internal funding from the university. So TEC as a callable function, proceedings of 2001 Eurotech, and also search for MathTran, which is unfortunately no longer live as a service, but maybe one day I'll reinvigorate it. Next, value-added typesetting. When we typeset, there's a source document and an output document. Value-added typesetting is when the output document contains all the information that is in the source document and some more information. You can perhaps think of it as the source document annotated with where the line breaks are and where the page breaks are. So value-added typesetting is where we can get the source document back out of the original document. Now, what LaTeX 3 project are wanting to do regarding accessible PDF is an example of this. You have a source document, and the information that is presently lost when you go through the typesetting process, they want it to be preserved and transformed so that are then placed into the resulting PDF so it's accessible. So what they're doing is actually value-added typesetting. Well, actually, this can be done quite easily today, but not by LaTeX. It requires a different way of thinking. The way of thinking is that you start with value-added typesetting as the first, and you achieve the goal. And then you add whatever formatting and other material that you want to do, such as giving fonts and other things, as you go along. In other words, you don't retrofit it. You start it from the very beginning as being value-added typesetting, and then you add the typography stuff that you really want. Now, I've written about this already, and this is the place to go. It's my article in Tugboat from 1996, which is a long time ago, but it's still relevant, called Editing DVI Files or Visual Tech. You may not know, DVI stands for Device Independent, and they're a form of file that was TeX output when Don Knuth wrote TeX, because he knew that there were many, many, many sorts of output devices, including some that weren't yet invented. And he wanted TeX to be able to work with them all. So not invented at the time of TeX, when Don Knuth wrote TeX, PostScript wasn't invented, PDF wasn't invented, SVG wasn't invented. But DVI will work with all of these by providing a suitable backend that does the translation. So my approach to accessible PDF is first to create accessible DVI, which is largely a typesetting problem and also a manipulation problem and a data flow problem. And then from the accessible DVI, produce an accessible PDF or an accessible SVG, whatever accessible or other outputs that you want. So I think that's enough for that for now. If you want to learn more, go to search for editing DVI files, and you'll get my 1996 Tugboat article. Thank you. Next, LaTeX to XML. This will really help bring LaTeX into the mainstream. Lots of software understand XML. Lots of systems use XML. There are many, many tools for working with XML. At present, LaTeX itself is pretty much the only thing that understands LaTeX, the markup language. And that's a problem. We want to get back into the mainstream, which has moved on a lot since the 1990s. Now, the syntax checker that I spoke about earlier, and having a standard for LaTeX math, these two together can form a gatekeeper for the transformation process. So if the transformation process, if the input meets the gatekeeper, we'd expect there to be good output. And we'll have to develop it, it will work, and then it will work better. Now, I'm a reader of the Blind Math mailing list, and based on what I see there, I'd say that a LaTeX to XML system that doesn't work for all documents, but works for a fairly useful set of documents that got restrictions, particularly on typography, would be of great benefit to the blind mathematics students and their support staff who are regularly contributing to the Blind Math mailing list. So to summarize, syntax checker and standard LaTeX math are starting blocks, starting points for LaTeX to XML. To begin with, we'll make a small amount of progress and we'll get just a few users. But once it's shown to work, more people will want to use it, and perhaps it will develop into something useful. Next, read the docs and write the docs. Read the Docs is a website, it's a publishing platform for documentation. You write your documentation in a standard format, and every time you update your GitHub repository, Read the Docs will rebuild the documentation and republish them, or you can do it on demand. Write the Docs is an organization, it's also a website, that holds conferences, and their concern is technical documentation. They know a lot about this stuff. They have a lot of really interesting people doing that, and the conferences have interesting talks. So I suggest that you go and visit the Read the Docs website, and you go and visit the Write the Docs website and have a look at what's going on there. I did that before this conference and found that there had been a talk about LaTeX at the Write the Docs conference. I was so pleased about that I got in touch with the person that spoke and asked them if they'd be willing to give a talk here. And they said, well, yes, might be willing, but I can't commit because I'm traveling at that time, I think. However, that's enough. I'll stop now and we'll move on to the next topic. Next, and finally, the user experience. We've just seen how important user experience is for guiding and motivating software development. This is the 2020 Tech Users Group Conference, and for the first time, it's being held online. Please remember, this is important, that the U in TUG is you and everyone else who uses tech, whether or not they're a member of TUG. TUG is for all tech users. Our experience is important, and it's even better when it's shared. I hope you've been having a good conference. I know I have. And I hope next year, many of us will again share and meet, online or in person as appropriate. I hope that we can have a dual conference with an online component and an in-person component for those who can attend, and provided it is safe. So all the best. Thank you for listening to the talk. And I don't have to wish you a safe journey home because you're already at home. Goodbye.
Hi, Jonathan, you're back on.
Well, I just ruined my punchline, didn't I? Here I am back again. Do I have just a few minutes left? Is that right?
That's correct. You have about 10 minutes.
Oh, 10 minutes. Okay. So,
Less than 10, sorry, 8.
8. I will speak carefully. Whilst the questions are coming in, I'll answer a question from the previous talk, which is, very briefly mentioned Mathtran. Mathtran started in 2000, was live in 2008, and at that time it was serving 48,000 images a day. And each image was typeset with TeX, and it returned both the image, and inside the image it returned the log file, and it returned the source of the TeX. It's a smart image. You could actually untechify the image. And every user shared the same instance of TeX. So I had to protect not just the system from poisoning, but TeX itself from poisoning. And the way I did that was I wrote a special format in which every single control sequence that was internal, and only internal, had a name that began with a special character. The special character was the character 0, which is quite difficult to type to begin with. And so by filtering the output and saying, well, if you put a character 0 into your input, if your input, I'm not going to let you do anything with that formula. I gave some measure of safety. That didn't stop you killing the thing, but it stopped you, for example, defining your own macros, because you couldn't get hold of the def command because it had been moved to / null character def, and you couldn't get a null character in. So there is some prior art in this, and that prior art is quite important for TeX as a web service. So I'll stop now and hope that some questions come in. Otherwise I might have to tell you a joke. So I haven't. Martin asked me what the joke was, and I don't have one. All right, here's a joke. There's been I heard a joke. No, I can't tell it. I can't make it up. Does anybody else want to contribute a joke or something nice? Here we are. Oh, I've got something. Hold on. Okay, so this appeared, sorry for the reflection, I think we've got rid of it now. This appeared in the junction between the vertical desk and the horizontal desk at the beginning of the talk. Now I'll read it out to you. Air and air and air again, but less and less and less. Can't read it. This is the road to wisdom. It's plain and simple to express. So this is a group by P.S. Hine, which was made for Don Knuth, and I had the privilege with the Tech Users Group of visiting the Stonemasons workshop, Davis Kindersley, that made this, and they were selling postcards of it, so I bought quite a few, and I think I've run out of them now. But this is always on my desk. Air and air and air again, but less and less and less. P.S. Hine didn't say anything about giving reward checks when you get fined out. So why don't we stop now if nobody raises their hand to ask a question, because it's been a long conference and I can imagine that everybody's all a bit tired and looking forward to getting home and having hot baths. And those people who will be going to every talk are obviously very keen to go to bed soon. I do like the idea of a syntax checker. I think that idea, experts don't need it, of course, but I think that idea will really help with the usability, and it's a bit like training wheels on a bicycle, which I never had, training wheels on a bicycle, which is it'll make it a lot easier because you run the syntax checker and you say, oh, there is a syntax error, I'll fix it, thank you. Or you can say, well, it passes the syntax checker, so perhaps I'll have to ask an expert, because I can't figure it out. And the smart people that made the syntax checker haven't caught it, so it must be a difficult and awkward thing, and I don't have to feel bad about not knowing how to solve it, because even the experts haven't automated it yet. So I think I'm going to stop now. Are you going to say goodbye to me, Paolo, and give us a break before the next talk?
Well, not without answering a very quick question. I mean, I want to just go back to.
Sorry?
Not without answering a very quick question. I just piggyback on that old idea. I mean, LaTeX to XML, we have a very good path, to obtain documents in that particular workflow. We just abandon LaTeX and go into context. Why is that not a good option?
No, I think it is an option. The thing I don't like about it is it's a further fragmentation of the community. And there's a lot of resistance to that. And in a sense, that's why my ideas in the past haven't had much traction, because they wanted to stick with LaTeX. My view is that, now I will get some responses to this, that the accessibility project that the LaTeX 3 team are doing will go in a similar way to the new typesetting system project, which was very expensive and produced nothing, and there was a diversion from things that were important that could have been done. So my view is that, well, I won't speak too definitely. I say I haven't seen any evidence that it will work, and I've seen evidence that they're not properly considering the architectural options, and so they'll go down a difficult route. So I think the I think there will be a successor to LaTeX, and I hope it's a successor that is based on tech. But if we can't solve the accessibility and all the other problems, then LaTeX will have a successor. And there might even be a proprietary successor because there's a gap in the market. So I think our responsibility and our loyalty must be to LaTeX because it's been so good to us in all this time and it's made a tremendous amount of progress for us. But underneath LaTeX, there is tech, which is giving us the magnificent typography. And my loyalty is to tech first and LaTeX second. We may have to try and find a path out of LaTeX. And in a sense, that's what Frank is doing with the LaTeX 3 project accessibility. He's trying to find a project path out of LaTeX, abandoning large parts of LaTeX or heavily modifying them without losing any users. And it may be a question of, can we do it incrementally, or do we have to have some sort of switchover? I'm in the Python community, and they did not try to incrementally go from Python 2 to Python 3. They said there are major incompatibilities, and we will create Python 3, and we will provide a migration path for projects. And it's taken a long time for that migration to take place. If they tried to migrate piecemeal, we'd still be trying to migrate. So I think that's the end of my speech, and I hope that gives you some insight into, if not answering your question, how I might answer your question, because I'm opening up to say how I see things, Paolo. That's a supplementary if you want.
I mean, we'll have a sequel to that.
Is that an SQL sequel?
Yeah, I think we don't have time. I mean, the next speaker is already waiting in line.
Thank you very much, Jonathan.
Thank you for inviting me.
Thank you. Our next speaker is James Carlson, and he will be talking about interactive compilation stack for web browsers. Take the stand, James.
Let's see if I can figure out how to do that here. Let's see. Okay.
You want me to play the
yes. Could you play the video and then we'll talk afterwards?
Thank you.
Hello, good morning, everyone. It's a real pleasure to be participating in the Tech User Group Conference. My talk today is about interactive compilation of LaTeX for web browsers. I can be reached at jxxcarlson@gmail.com. If you have any questions or comments, there's information about the subject of this talk at minilatex.io. So what I would like to talk about today is a technology which I called minilatex. The reason for the name is that it is you can use it on any device, from a desktop computer to a smartphone. You can use it for things like course notes. Later on, I will show you some course notes that I wrote using a minilatex app. You can use it for quite a variety of things. That's one good use of it. So I think the best way to show you what minilatex is to do a little demo. So we're going to go to demo.minilatex.app. Here we are. On the left, you see a little window with source text in it, with LaTeX. On the right, you see the rendered version. And you may not have noticed it, but what happened is when this browser opened the app, it essentially instantaneously parsed and rendered the source text to display it on the right. And what we see on the right here is our text document. If I click on an entry in the table of contents, let's try that again. We go to the corresponding place in rendered text. There you see some images. One is a PNG image, something I saved to my desktop and then uploaded to a server someplace. Another is an SVG image. Let's see how these are constructed in the source text. I'll scroll down here on the left. And under section images, we have this little macro here, \image. That's what's used to create the little waveform, the 2 frequency beats. It's a macro that takes 3 arguments. There is, the first argument is a URL for the image. The second argument is the caption. And the third argument is some placement data, the width, how it should be put on the screen, whether floating on the left, aligned in the center, and so forth. Below that, you see something a little bit different. This is an SVG environment. And what you can put inside the SVG environment, inside the begin and pair, is raw source code for SVG image. I constructed this image using an SVG editor. You could write the SVG code by hand, produce it algorithmically, whatever. Let's scroll up a little bit to see what else we have here of conventional mathematical stuff. Let's scroll up on the left to see the source text. And what you see is, first of all, let's look at this one here. We have an equation environment. Inside that, we have a label for cross-referencing equation 2.1, and then we have the actual formula itself right here. Let's see what happens when we edit this thing. I'm going to change the 1 to a 2. So look carefully on the right-hand part of the screen. There it is, it's changed. Let me edit this so we have a correct formula. I will edit the numerator of the fraction. It will be 2 to the power n plus 1. There we go, and that's rendered again. So you see this is live editing of text, of LaTeX text, and it renders essentially immediately. So later on, I'll talk a little bit about what the technology involved in making that happen is. So let's, we should see what happens when you make mistakes, because we all do that. Let's go to try it out here, section try it out, and I will eliminate the right brace. And if you look in the rendered text, you see that you have an error message. Error messages appear inline. They give you some idea of what it is that you did wrong. So in this case, it's pretty accurate. It says expecting right brace. So one of the projects I'm working on is to improve the error reporting. I would like to make the error messages as helpful as possible. If I put the right brace back, then I get my text back, but we notice the number before try it out is gone. It should be 2, try it out, section number 2. The reason for this is that Mini LaTeX is a logical paragraph oriented application. What does that mean? A logical paragraph is either an ordinary paragraph or it's an outer begin end block with space above and below. And these are the basic units of compilation in Mini LaTeX. So if you edit something or you make a mistake, it will be, all the changes are relevant to that particular logical paragraph. This means 2 things. It means that errors don't propagate. It also means that rendering can be very fast because the program keeps track of what's changed and it only re-renders what has been changed. So anyway, things have gotten out of sync now. And to rectify that, we go down to this other button here, full render. I press that, and now everything is back where it should be. Except, of course, I've changed my formula. Now, by the way, this little app is one that you can use at your heart's content because there's no data to destroy here. Let's press the restore button, and now it brings the text back to its original state. So this is purely for demonstration purposes. Let's go up and see one more thing here. At the top, you see, on the left here, you see begin math macro. So the math macro environment is something peculiar to Mini LaTeX. There's also begin text macro, which you see down here. And these are environments within which you can define your own math mode and text mode macros. So let me give you an example of that. I'm going to define a new macro for you. I'm going to say new command curly brace, backslash WW, whoops, WW, and then even if it's a macro or a new command at 0 arguments, I have to specifically say this. In a future release, I'll probably get rid of that, but for now we have to do that. And then I'm going to say we're going to interpret that as math BB of capital W. Okay, so I hope I haven't made any mistakes, but I've made a new math mode macro. And down here, I'm going to try to use it. I'm going to say double $sign. I have my stake over there. You see the error message, double $sign. Right here, I'll put backslash WW. Notice that it hasn't recognized my macro yet, but I'll keep typing anyway. Type some ridiculous formula here. Maybe this. Okay, so I have a formula, except of course my macro has not been applied. And to rectify that, I say full render again. And there, by golly, you see it, okay, right there. Okay, so that's a brief introduction to what mini-LaTeX can do. Notice, by the way, there's been no setup for the document. There's no preamble here. Maybe I should give you an even quicker intro to that. I can clear this window, and then I can just use it to experiment. Like I can say, Pythagoras said that a squared plus what was the $sign? Okay, so I've written some text in there. And as I say, you can use this to experiment with various mini-LaTeX constructs. Another thing you can do, let's restore the original text. Here we go. Notice this final button that we have not used, export. So if I press export, then it downloads a text document to my computer. Let me go to my downloads folder. What it's done is it has translated the mini-LaTeX document to a regular LaTeX document, and that I can typeset with any text program that you might want to use. I'm using TechShop. Should do this twice. And there we have a text version of my mini-LaTeX document, complete with images. I'll have to say something about them in a second. Notice, by the way, that here it says, cannot yet render SVG images, convert to some other format, e.g. PNG. So bear that in mind. Now, how did it take care of the images? Because the image macro refers to images that are on the web someplace. Well, if you noticed, when we exported the document, a little column with images appeared on the right. And if I do right click or control click on a Mac, then I can say save image as. And what I do is I save it inside this image folder, which is where TechShop or whatever tech program you use will look for the images. So in that way, any images that you might have used in your document will also be accessible when you export the document. So I think that is all that I wanted to say about that demo. Let me just quickly look here. Well, I believe that's it. There are a couple of other things. Let me go back here and clear this once again. And let me show you what happens when I make this kind of error. I will say string theory. So notice what's happened. The string macro doesn't exist. So it's rendered that in red. That's the best it can do. I was really thinking of strong theory. So if I type that, if I get it right, then it will render that in bold. So that's a good thing to know. Here's another one. I can say this, begin joke. end joke. And it renders it like this. So if you use an environment that Mini-LaTeX does not understand, it tries to handle that as gracefully as it can. That can actually be useful. I mean, maybe I want to write a manual about humor, and this gives me a ready-made joke environment. If I were a lawyer, I could have objection environments and so forth and so on. And of course, if you export the document, you can define your own joke or objection environment to handle it in a different way, if you wish. So I think that's everything that I wanted to say about this demo app. So slight pause here. I want to do one more demo, and then I want to talk about the technical aspects of writing a LaTeX to HTML compiler. So welcome back to part 2 of this 3-part series on Mini-LaTeX. What I'd like to show you now is an app called minilatex.landera.app. It's a full-fledged document management app, and it can be used in a number of ways. The first way is to simply click on a link. The link has the form the app name /G for guest / a number for the document number of some document. So let's try that. That goes immediately to the document, and now you can click on the table of contents. This is a good way of distributing class notes, for example. The second way of using minilatex.landera.app is to log in as guest. The instructions for that are given here in this little welcome message, along with lots of other useful information like features. But we do it like this. You put in guest as the username, you put in Mini-LaTeX as the password, and you sign in, and there you are. You know, we've seen much of this before, so let's look at something different. Let's search for LaTeX. That narrows the list of available things down. Let's click on Mini-LaTeX TUG Talk. That's the written version of what I'm trying to say now. Of course, the two versions diverge. But anyway, you can mess around with this. One thing that I plan to do is to add a lot to the search feature, because right now there are very few documents, but hopefully there will be many more in the future. And we need ways of finding documents pertaining to a particular class, a particular author, certain subjects or tags, etc. So I think that is probably everything that I want to say about guest mode. We've seen most of it before. For example, you can look at the source, which is always a useful thing to do. So let's sign out, and we'll look at the third and last way of using it, which is to sign in as a real user. I'll sign in as myself. There I am. And there are only a few different things that you need to know. One is that, of course, you now have access to this button, which allows you to create new documents. Let's make one, let's call it test, something not very interesting. And we'll have just a simple little message there. Notice, of course, that it was rendered immediately. I have to press the title button in order to set that. And if I wish to publish this document, then I just go over here and I press, I can change back and forth, okay? I haven't implemented search on tags yet, but I can set tags as well, if I wish. More importantly, down here below, you see a button called Collaborators. If I want to, well, I guess I'm already collaborating with Fred, but maybe I also want to collaborate with Mary. So I say set collaborators, and now Fred and Mary can also edit this document. And something that's rather nice is that if we're all editing at the same time, then we will be able to see each other's edits in real time. If I go off to lunch and log out, come back, then I'll see their edits after I log back in. To facilitate collaboration, there is also a chat feature. There's not much in the chat right now because this is still sort of a test run for the app, but it's there, and I plan to make additions to that also. So, for example, there will be channels for particular documents. right now everybody's in the same channel, which is not so great. So I believe that that is all that I wanted to say about this app, because we've covered all the other features and other things. So let me now go to the third and last phase of this talk, which is to talk about how we actually implement a compiler that will transform LaTeX to HTML, and also do it in essentially real time, because that's what we want. Well, the first thing that you need is the right tool. And for me, the right tool is a language called Elm. It's a language that takes Elm source code and it compiles it to JavaScript. And most web developers use scripting languages that do not use a compiler. And I kind of gotten used to that, even though in the old days I did use compilers, like a Fortran compiler. Let me tell you that it's great to be using a compiler again, because you don't have runtime errors anymore. It's just wonderful. Elm is also a strictly typed language like Haskell or ML. In fact, syntactically, it has many similarities to those languages. And in fact, the Elm compiler is written in Haskell. It's a functional language. Now, this can mean many things. It may mean only that functions are first-class objects in the language. But Elm is what's called a pure functional language, which means that functions are like in mathematics. The output depends only on the input. There are no side effects. So let me talk a little bit about the amount of code that is necessary to implement the apps that I have showed you. The demo.minilatex.io app is only 320 lines of code. Okay. It also doesn't do that much, but it does render LaTeX. And the reason it can do that is that it calls upon the mini-LaTeX compiler, which is a little over 6,000 lines of code. Now, the heart of that compiler is the parser. That was actually the hardest thing for me to write, and that's just under 500 lines of code. On the other hand, this document management app, minilatex.lamdera.app, is longer. It's a little over 5,000 lines of code. So that gives you a rough idea of how big things are. So let's talk a little bit about how we can transform source text to HTML. The key is this triangle here. We don't want to take source text to HTML directly. That would be way too hard. What we first do is we parse it. We transform it into something called an abstract syntax tree. It's a tree structure, a graph of sorts, that expresses a kind of grammatical understanding of the source text. Once you have that, it's actually rather simple to render it to HTML. So let me give you an example of an AST in a different language, not Python, but pseudo-Python. There's a little bit of code, and there's the corresponding AST. It's a tree, okay? And if you look at the nodes, you see that certain nodes like while and branch and assign correspond to certain linguistic categories in that pseudo language. Now, what about mini-LaTeX? There's a little piece of LaTeX code, and there is the corresponding syntax tree. And if you look at that, you see things like macro, which has its children strong, and then a list, and then a LaTeX list, and et cetera, et cetera, et cetera. I really don't have time to go into this more, although of course it's fascinating. But the main point is that in order to get this off the ground, you have to think about the type of the abstract syntax tree. So remember, I said that Elm is a strictly typed language, and this is the key for doing this. So here it is. It's actually fits on a page. The type is something I call LaTeX expression, and it contains things that will be familiar to you. A piece of LaTeX text might be just ordinary text, and we have to identify it as such. So that's an LX string. A string might also be a comment. We have to identify that as such. It might be we have items in itemized lists, so we have to identify those. The int part corresponds to the level of the list. We have math elements, inline and display math elements, and we have to separate those out and identify them. And we saw that, by the way, when we looked at our little example, the Pythagorean theorem was, or the Pythagorean formula rather, was the body of the inline element in that tree. So let's go back and look at that. There we go. See, they're inline math, quote, a to the power 2, etc. Okay, so back to the LaTeX expression. So you just enumerate all the things that you know you need to do in LaTeX. You have to have macros. A macro has a name, it has a list of optional arguments, and it has a list of arguments, and those arguments themselves may be LaTeX expressions. So this type is a recursive type. Same with environments. They have a name, that's the string. They have possibly arguments, and then there's the body, which I just parse as a string, unprocessed. And finally, something I added later in the project was the ability to define text mode and math mode macros inside of a mini LaTeX document. So you have to have a component of the type for that. A new command has a name, it has an integer number of arguments, and then it has a LaTeX expression, which is the body of the macro definition. And then finally, you have LX error to do with errors, because of course those happen too. So that's really the fundamental element. And when I started working on this, I didn't have a grammar to work with, which is what you usually want when you want to make a parser. But you know, I'd used LaTeX most of my life, and I sort of had a feeling of how to build the definition of the type of the AST. Well, let me show you a little bit about the parser. Again, this is a big subject, even though it's only 500 lines of code. But here's the idea. The top level parser, the top level parser function looks like this. It's called LaTeX expression. And it is a parser that selects among a number of alternatives. So it's built using what are called parser combinators. So one of is a parser that takes a list of parsers as argument, and it will try to apply those parsers in turn, returning the result of the first one that succeeds, and if they all fail, it will return an error. So it first of all tries to see, well, do I have a tech comment? No, I don't. Do I have a displayed math element? No, I don't, and so on. Well, eventually it will either succeed or it fails, and then it goes on to the next thing. Let's look at one of these. Let's look at the macro parser. So this is a different kind of parser. Instead of selecting among alternatives, what we have here is a parser pipeline, and it sequences parsers. So what it does is it first of all tries to identify the macro name. That's the macro name parser. Then it tries to identify the list of arguments. That's the item list optional arg parser. So optional arg is a little parser, and item list is a combinator that combines those optional arguments parsers to parse a list of arguments, and so forth and so on. Okay, we have not only optional arguments but actual arguments, so we have to parse those, and then we eat up whatever white space is left. And the reason we do that is that this kind of parsing technology does not separate the operations of lexical analysis and parsing. So everything is all in one big system, or one little system, as the case may be. A few words about the renderer. So this is a much larger piece of code, but it's also a much easier piece of code to write. And basically what you have to do is to write a rendering function for every component of the type of the AST. I also use a divide and conquer strategy, which is what made this project possible. The idea is the following. There are two kinds of things in LaTeX. There's text mode. I use Elm to analyze and deal with that. And there's math mode. And I figure out what the math mode stuff is, and I pass that on in the rendering phase to either MathJax or Katek. So this is what made the project possible, actually, is Elm on the one hand and these other tools on the other, which take care of the math mode stuff. So finally, here is the top-level rendering function, and you see what it does. It makes a case analysis on the kind of LaTeX expression you have. If it finds that you have a macro, then it renders that using a certain function, which of course calls other functions and so forth and so forth and so forth. Inline math, that's pretty direct, and so on. So, you know, to really understand this, you have to go down the rabbit hole of function calls. But believe me, it is relatively straightforward. So in closing, a few words about the future. One thing is, this project is very new. I mean, I've been working on mini-LaTeX for about 3 years, but mini-LaTeX.lambdera.app is only about 2 weeks old. So I need alpha testers, people who would like to use it, beat on it, find the errors, find the bugs, let me know about them. Let me know about things that you think are missing, and I'll do my best to take care of it. So please go to mini-LaTeX.lambdera.app, sign up, and let me know about things. Another thing that I need input on is what subset of LaTeX do I really need to have in there? You know, this is a somewhat ill-defined thing because there's no grammar for LaTeX, at least not that I'm aware of. So I've put in what I needed, but you know, maybe that's not everything that other people need. So please do let me know about that. Another thing I want to work on is making better error messages. They're not bad now, but they can be improved. I am working on producing an IDE for the system, which will help authors, you know, do obvious things like search and replace, but also do syntax highlighting, do various other things, you know, completing a begin-end block so that you keep your code in a valid state to the greatest extent possible. And finally, I'm also working on a desktop app so that you can use this technology on a desktop. You have your files on your computer, and you also have a way of uploading them to a server for sharing with other people. So in closing, I would like to thank the Simons Foundation. They've given me a bit of summer support for this project, and I'm very thankful for that support. So thank you very much, and I hope to be able to answer your questions.
Hi, James. Passing the control over to you.
Okay, let me see if I can do this. Can you hear me? Can you see me, Paolo?
Yes. Yes.
Okay. So let me take a look at the questions here. Let's see here. Elm is an interesting choice for this task. Can you name any disadvantages of it? Well, not too much. You know, it took me a while to understand things because I had never worked with a typed pure functional language before. To give you a little background, my first computer experience was in about 1965 when I learned Fortran for a summer job, doing some numerical analysis. And the way you learned it is you wrote your code out and punched cards and then submitted your deck, which I had to do between midnight and 6 a.m. And you worked through the night and tried to get things working. This was on an IBM 1620 with 64K of main memory. Really great machine at that time. Anyway, Elm turns out to be a wonderful language for this because it is a language designed for making web apps, which this is. And it also has a very fine parser combinator library. It's very much like Parsec in Haskell. So I had some initial difficulties really understanding what a type system can do, but that's the real strength of the language. There are also certain hoops that you have to jump through because it's a pure language. So this involves using ports to access certain things that have to be done in JavaScript, like MathJax or Kotek. So, but on the whole, I would say it's a wonderful language to work with. So let me look. Next question, has mini-LaTeX already been integrated to any wiki engine? Not to my knowledge, no. This is a one developer project by a retired boomer, so I'm doing the best I can. Let's see here. Let me look on the chats. Maybe there's more there.
Chat as well.
Let's see here. let's see, where does Mini LaTeX do the line breaking? In the renderer and hyphenation? You mean the line breaking in the rendered text? I assume that's what's meant. In the source text, you know, I'm using a text element in a library called Elm UI, and it's set up to do that. To tell you the truth, I haven't paid much attention to the line breaking on the LaTeX side. Something I guess I should look at. Let's see here. Let's see if there are other questions. And let me look back at the Q&A here. Let's see, regarding a LaTeX FAQ, I mean, one thing, let me just show you one thing that I just did this morning, in fact. Let me see if I can, yeah. Let's see, no, I need to share my screen. Let's see if I can do, am I already sharing my screen?
No.
Okay,
No.
let me try that then. Let's see if this will work. This may be problematic. Let's see, I have to
Share
very,
screen.
let's see, I guess it, you know, I think I'm not going to do this. I'll just, I think I'm afraid I might mess things up. But let me just say that if you do go to minilatex.lamdera.app and you type in the search box LaTeX, then it will bring up documents relative to LaTeX, and there is a mini LaTeX manual, and that describes some of the features and also some of the limitations of mini LaTeX. In particular, it talks about what macros and environments are implemented in the system, and that goes back to my last comment, namely that I need advice on what subset of LaTeX would be reasonable to support. I can't support everything. I wouldn't know where to begin. My test so far has been, if it's good enough for me to write my class notes, it's good enough. But you know, that's a pretty limited view. So okay, there's another question here. Is it possible to export the HTML without the mini LaTeX dependencies? Not yet, but I will make a note of that. That is possible to do, yes. Let me note that, HTML export. Yeah, let's see if there, let's see, Paolo, do you see other questions that I haven't answered? I'm kind of new to the system.
The one from Jeremy, just has mini LaTeX already been integrated in any wiki engine?
Oh, I believe I answered that, not to my knowledge. Certainly nobody's contacted me about it. I should say, by the way, that, okay, so all of this is open source. If you go to my GitHub and you search for Mini LaTeX, M-E-E-N-Y LaTeX, that's where the GitHub repo is. The reason why I've used this rather odd name is that I want to fairly soon publish a new version with a better API, and I want that to be under the Mini LaTeX, M-I-N-I LaTeX name. But yeah, it's all open source. There are examples in the repo that show you how to use things. It's fairly easy just to, in fact, it's very easy just to take a string and render it into LaTeX. You have to do a lot more to get live editing, so that the API for that is more complicated. The reason is that you want something that's extremely responsive, and one of the things that I do to make it responsive is this business about logical paragraphs. So if you change something in the source text, the default mode of operation is to only reparse and re-render that part which is changed. That makes it extremely fast. As you saw, certain things can get out of sync, but there's a way of dealing with that too. You just press the full render button. Also, if somebody else opens up your document, then that's not a problem. Let's see, I don't see too many more. Let me just re-emphasize that you know, I really do need feedback. As anybody who's done software development knows, you're often blind to your own mistakes. So you can create a free account at Mini LaTeX lamdera.app. And if you find things that you think are wrong, either post an issue at that GitHub repository or just email me, jxxcarlson@gmail.com.
Let me just ask Martin if his question has been fully answered, because he may not.
Sure.
Martin, are you there?
Yeah, hi.
I guess
wasn't
for the second part of it. so you have the opportunity to chat with him now.
Yeah, okay. Now, I think when you have a long paragraph with hundreds of words, and
Yes.
then you produce something on the HTML side, somehow you have to break that paragraph into lines, and I wasn't sure where you do that.
Well, actually, I don't break them into lines. It's, you know, at the moment anyway, it's a purely paragraph-centric operation. And so far, I haven't found speed problems with that, but I'm working on a more capable editor that is line-oriented, so I may address that problem when that.
So you generate an HTML paragraph then?
Correct, correct.
And HTML does the line breaking then?
Exactly, exactly.
Okay. But that when you export it then to a real LaTeX file, the line breaking will be different.
Yes, that is true, because LaTeX will use its own line breaking. That's correct.
Yeah, and it also uses hyphenation, and usually HTML doesn't do hyphenation.
That is correct, yes,
yeah,
yes.
Well, there will be some differences.
There will be differences, yes.
Okay.
And I probably have neither the expertise nor the energy to address that problem. It would be nice to address it, but you know
Yeah,
how
it's
these
a lot
things
of
go.
work, I know.
Right. I've got enough on my plate as it is, yeah.
Yeah. Thank you.
Thank you.
Well, thank you for the wonderful talk, James. And,
Thank you, Paolo, and I want to thank the conference organizers. Thank you, thank Jonathan. Thank you both for the invitation, and I've really learned a lot. It's been an eye-opener for me. I want to say especially that Johan's talk was just fantastic. I plan to use his technology.
to get the group of all of you together on this Sunday here would be really,
it would be nice, wouldn't it? Share a glass of beer.
Yes, yes, yes. We're going to go into a brief intermission and come back for Martin Ruckert for Hint. Hint is not tech, and it's the first file format which I find really new after DVI, PostScript, and PDF. A little intermission and we'll come back for that. Thank you.
Paulo?
Yes?
Just a question. I would like to stream the video from here.
Oh, cool.
Can we test it during the intermission?
Yes, yes. Right now if you want.
Yeah, we can do that. I can just...
I got a new monitor just to display your video because the
okay.
problem is that I have a 4K monitor. So I put these videos on a 4K monitor, they interpolate.
Yeah.
PLC interpolates, and then Zoom makes a mess out of it.
Yeah.
So
I can try to share my screen and then let's see what happens. So this is my share and I optimize for video. And then I should start that. And maybe go somewhere. Some of my students, however, used the standard function of the TECH backend, which renders any page at any size and any resolution to implement zooming.
Very nice.
Did that work?
Yes.
That came through loud and clear.
Okay, good.
Very good.
But I have to say that the video quality wasn't that good. I'm not sure if this is the original video quality or just a transmission, but it was quite pixelated.
Do you want me to try from here to see if it would be any better? I have a monitor just for you. Do you want me to try or not?
Try.
Martin?
Yeah, please.
So let me go. One is that pixelation. One is that point in your video. Is it too far down the video?
I just picked anything in the middle.
Yeah.
I have a lot of texts in my videos and it moves, so it might be pixely. Yeah.
Maybe it was just because you picked something in the middle and was basically still sort of sorting itself out.
Yeah, that could be indeed, yeah.
Here in Munich,
It's very short.
we'll
look for a place. Okay.
In the following, I will present to you the current status of the HINT project, and I conclude with some open questions. Device, heavy, welche fonts? Galaxy S, where's the...
Much better. And you see, it was just the same right now.
From the menu,
it took a second.
The same one.
Okay.
This is the point.
To page forward.
Is that the point,
I think,
Frank?
And you swipe to the right to page backward.
Okay, looks good.
I want to see that part where he enlarged it.
100%.
Okay. Both seems to work okay.
Select
right here.
The zoom
okay.
100% option, and it immediately shows you the text as it would be in a printed book. Next,
the rest comes in the top.
We present a few slides on the current status.
Paulo, stop it.
Demonstration videos.
So, what do you think, Martin?
I can't. Well, I could see yours, and it looked good. I couldn't see mine because I just see mine is of course clear because I run it locally.
Yeah,
so Frank should tell which one.
Well, just from the two short parts, the one from Paulo was better. But as I said, I'm not sure if you go a little bit longer, whether it was just sort of the initial phase. I don't know.
Well, I can try to share some more on my screen.
Yeah, give us about the same length, and then we can definitely say.
Share. Specification of hint files also includes TrueType fonts, OpenType fonts, and PostScript Type 1 fonts. TrueType fonts and OpenType fonts are also supported currently. I generate the...
I think it was a problem. Whenever you jump, it starts off badly, but the moment it got there, it looks okay. It's fine.
Yeah,
I think after it displays the first.
Main file format is available as a short format, which is used by the viewer, and it can be converted into the long format using the stretch file format. I have left it. User interface, including fonts and images.
Yeah, I think it's fine from your end.
It's good. It's good.
You have a good line, obviously.
Yeah, it's just when the first frame comes over, it comes a little bit pixelated, and then it smooths out immediately.
Okay, maybe that's the problem when you it's a full HD high definition video.
Yeah, and when you're doing the resizing, it pixelates immediately, but then it comes up very quickly.
Okay, good. Then I can play it from here.
Yes.
Okay. Good. Then we see us in a quarter of an hour. Is that right? 6:45.
3/4.
3/4. Yes.
Yeah, something like that. A little bit less.
Yes. 42 minutes from now.
Okay, good. And a little bit earlier than that.
Okay.
I'll be back then.
All right. Thank you. Martin.
Okay. Bye-bye.
Bye. Bill, I just wanted to ask you something. Are you talking live? You are, huh?
Are you talking to me?
Yes.
Yeah, I'm going to talk live.
Cool. So we have all set for this second part. Cool. So see you all in about 40 minutes.
Hi, Paolo. May I introduce my colleague, Gudrun?
Hi, everybody.
Hi, Gordon. You guys work together?
Yes, we're both at Munich University of Applied Sciences, and it's a lot of fun to have Martin's work implemented by my students and then see this all go on the mobile phone.
This is absolutely marvelous. It's one of the most beautiful things I've seen in the last 20 years. Martin already knows how much of a fan I am.
Yeah, and the students liked it to work on some real examples where you don't produce something during the semester and then you get a grade on it and you put it on the shelf and nobody uses it anymore. And they had good ideas and yeah.
No, it's absolutely great.
I did research certain things. How do you do this? How you can do that? What would work on a smartphone and so on. It was nice.
Go ahead.
And Gudrun is our specialist on computer graphics and mobile devices. And that's something I don't know about much. Or at least maybe 2 years ago, I would know almost nothing about it. And now I started with a course taking, so to speak, the student role in Gudrun's class. And then we developed over several semesters this application, this Android application, and it's programming Android applications is completely different to what I learned in programming, where you write programs for a big machine or at least something like a PC.
Yeah.
And writing programs nowadays for mobile phones is totally different.
And what is the largest difference?
The mobile phone has more memory than the PC I first bought.
That's a good point.
Yes, and when you program, traditionally a program, you have a main program and you tell the computer what to do in what order. And on a mobile phone, interrupt me, Gudrun, if I say something that is not correct, but the computer tells you what it wants to be done, and you have to write some code to do whatever the computer needs at the moment. For instance,
well, yeah, it's true, but I mean, yeah, it's multi-threaded, and the UI thread can never stop. So therefore, you have to kind of balance what goes in the foreground and what goes in the background. But it's fun. You always have something in your hand. You can always see something. Yeah. You can watch it.
Paying attention to events in programming of mobile is mind-boggling. You have to put yourself in another frame of work, and to attend to events, and something that had never done before. 30 years before programming, and never seen anything like that.
The machine model is very different from a traditional computer.
Interaction.
Well, we should go live and keep a lot of questions and discussions for the end. I'm pretty sure people will be interested. So we're coming back for the second piece of the last day of the conference, TUG 2020, and with you, Martin Ruckert, that's going to talk to us about Hint.
Hello, everybody. I'm here with my colleague Gudrun, and we will start with a video that is pre-recorded and contains some demo parts where I do the demonstrations. And then we have, that's about 25 minutes. And then I'm available for questions together with Gudrun. So now I try to get the screen sharing going. So let's see if that's allowed to share. It's the video. Now let's get started. Okay, this is the hint project, and you see the logo of our university. Hello, I'm Martin Ruckert. I teach here in Munich at the University of Applied Sciences. In the following, I will present to you the current status of the hint project, and I conclude with some open questions. Now, let's have a look at it. Here comes one of my favorite books. Well, I should apologize for the look, but the book is heavily used. I use the preface as a reference text for testing my hint viewer, and here comes the first mobile device. It's my smartphone, a Motorola Moto G 4th generation. You might observe that the title font is a bit heavy, whereas the body font looks a little light. This depends on the metafont mode that you use to generate the fonts. But of course, a smartphone is not the best device to read a book. Here comes another device. It's a Samsung Galaxy S4 with the same text. That looks better. Again, the title font is still a little heavy, whereas the body text looks better now. It's a different metafont mode used to generate that font. By the way, most of the features of the Android viewer's user interface were developed by our students under the guidance of my colleague Gudrun Socher in her course on mobile applications. Here are a few more examples. The hint viewer has a night mode. When you select from the menu the night mode, characters will show in white on a black background. You can revert to the normal mode the same way. Two simple gestures allow you to page through the hint file. You swipe to the left to page forward, and you swipe to the right to page backward. There is a zoom to 100% feature. You open the menu bar, you select from the menu the zoom to 100% option, and it immediately shows you the text as it would be in a printed book. Next, I will present a few slides on the current status, mixed with some more demonstration videos. The hint project strives to provide an alternative to the DVI or PDF output formats for TeX. It was specifically designed for on-screen reading of documents. So it needs to be powerful and flexible enough to capture text output, and it needs to be performant enough to display well on mobile devices with often very limited capabilities. Hint files are designed to be self-contained, including all resources necessary to display them, including fonts and images. Still, hint files should not be larger than a comparable PDF file. To be able to handle even very large documents was another requirement. Indeed, the hint file format is independent of TeX. There is no reason why, for instance, OpenOffice should not be able to output documents using the hint file format and thereby inheriting some of the best algorithms of TeX for formatting paragraphs and producing pages. For a detailed description of the hint file format, you could look at TUG2020 Volume 40, Number 2 from 2019, where I published a short paper on the design of the hint file format. The complete specification is published as a book. Let's look at the current state. Version 1.0 was released in March 2020. It contains the definition of the file format, an implementation of high-TeX and high-LaTeX to produce hint files from TeX sources, and 2 viewers, one for Windows and one for Android. The Windows viewer has a keyboard and mouse-oriented user interface, and it uses the older Win32 API. The Android viewer has a touch and gesture-oriented user interface and uses the more modern and more performant OpenEGL API to render graphics. Specification and programs are available at hint.userweb.mwn.de. Zooming is implemented using a 2-finger pinch gesture. Usually you scale the bitmap and re-render the page when you release the fingers. Some of my students, however, used the standard function of the TeX backend, which renders any page at any size and any resolution, to implement zooming. It's an impressive demonstration of the performance of the TeX backend, which reacts to the fingers without any delay. For the hint viewer, positions in a hint file are persistent. When I read a document, change sizes, and finally decide to terminate the hint viewer, and later reopen it, the text will show up at exactly the same size and position where I have left it. Version 1.1 is expected to come out in October this year. Unfortunately, the new format is not compatible with the version 1.0 format, because I added 2 new tags, one to identify languages and one for character encodings. None of them is really necessary for displaying a hint file, but they are useful, for example, for text-to-speech conversion and automatic translation of texts. Further, the format of page templates has changed. Page templates were not yet implemented in version 1.0. The new implementation of high-TeX and high-LaTeX contain most of the extensions of Epsilon TeX, which are required to run LaTeX. Further, they use the kpath search library for opening files for a better integration with TeXLive. And the implementation is able to generate required fonts on the fly using Metafont. The Windows viewer now supports the printing of hint files. Using this feature, you can get a paper printout of your hint document that should match a printout obtained by running, for example, PDF TeX and then printing the PDF file. Here is an example opening a LaTeX file. I select from the menu the Open Document item. I pick the file I want to open. Here I use a sample file by Leslie Lamport. It immediately shows on the screen, and I can adjust the size that I need for reading. Maybe that's a bit small. I can page forward by swiping to the left. I adjust sizes as I go, and when I adjust sizes, the top of the page will stay fixed. When it comes to fonts, both versions, the 1.0 and the 1.1 version, support PK fonts. PK fonts are supported by the TeX engine as well as by the viewers. The specification of hint files also includes TrueType fonts, OpenType fonts, and PostScript Type 1 fonts. TrueType fonts and OpenType fonts are also supported currently in the Android viewer, but not yet in the Windows viewer and the TeX engine. For more on the specific problems of fonts for on-screen reading, you could read my paper on computer modern Roman fonts for ebooks, which appeared in the Tugboat Volume 27, number 3 in 2016. When you run HiTeX to generate a hint file, the fonts that are embedded depend on the metafont mode. The metafont modes are defined in the modes file, and I have added one for mobile and one for laptop devices, which are a little bit blacker than the normal fonts. The typical standard font is a LaserJet 4 font, which is used here as a default installation. When you run HiTeX without options, you get the default installation font. Here it's the LaserJet 4 font, and we have seen it on the Moto G device. When you run HiTeX, you can supply options, -M to specify a metafont mode, and -R to specify a resolution. I'll now I generate the mode mobile. The hint file format is available as a short format, which is used by the viewer, and it can be converted into the long format using the stretch program. So to have a look at the file, we stretch the short format hint file and generate the long format hint file. Let's have a look at it. It starts with a directory, and you can see that it uses the fonts from the mobile subdirectory of the PK fonts. While we are at it, we can have a look at the definition section, which follows next. It starts out with the fonts, then come integers, definitions, dimensions, glues, hyphens, and other things. And at the end of the definition section, you find the content section. Here you see the definition of the title. When you use HiTeX to generate a hint file, you can use the -M option to specify a metafont mode and a -R option to specify the resolution. If necessary, HiTeX will then generate the necessary fonts. For generation of fonts, it relies on a regular TeX and metafont installation. In this example, it's the TeX Live distribution 2019. Here you see the difference between blacker equal to 0 and blacker equal to 1.6. That is the setting that I have used for the Galaxy tablet. Now to images. The hint file format actually doesn't care about the format of images. It just embeds any file you give it. The TeX engine, however, needs to extract some basic information like sizes from images. And it currently supports bitmaps, PNG and JPEG files. The viewers also support these three image file formats. However, I think there is no real advantage of bitmap files over PNG files. So bitmaps are deprecated and support for them will most likely disappear in the next version. Currently, two image formats are supported, JPEG and PNG. Here I show you an example, first with a PNG image. The capital A is a PNG image embedded here in the text. The next example will show you pretty much the same text, this time using a JPEG image that is similar. Now comes the final part of my talk. I explain to you some of the open questions. Language information is not necessary to display hint files, but it is useful for text-to-speech conversion or automatic translation of texts. The Internet Engineering Task Force has set a de facto standard by publishing BCP 47, a list of tags for identifying languages. When it comes to TeX, the Babel package is the de facto standard. However, it seems that there is no standard for embedding language tags in TeX sources and TeX format files. Maybe just a standardized extension of the What's It language node that now represents language information in TeX could do the job. A similar question arises when it comes to character encodings. They are not relevant for displaying a hint file, but necessary for understanding the content. The Internet Engineering Task Force has set here a standard as well. But is there a TeX standard? I have already talked about supported image formats. I think that a few formats that are supported in every implementation of high-TeX and every hint viewer is better than a long list of formats that are not supported in all implementations. So my choice was to use JPEG for photographic images and PNG for synthetic images. There are good conversion programs available to produce these formats if necessary. But what is the format that should be used for scaled vector graphics? The formats that are popular in the TeX community, like encapsulated PostScript or PDF, require complicated interpreters to render them, burdening the viewer. Even SVG tiny is not as tiny as one would hope and would increase the renderer for hint files considerably. So I asked myself, isn't there a simple way to convert scaled vector graphics to a glyph, for example PostScript type 1? Since any viewer will need the corresponding interpreter for fonts anyway. Links are indispensable for navigating large documents on screen. When navigating a physical book, you use an index, a table of content, or a table of illustration, which give page numbers. With a physical book, you do not need to search sequentially for a given page number. With just a scroll bar, finding a page is less convenient. For on-screen reading, you want to have links that you can tap or click to get to the corresponding place in the document. Embedding links in the TeX output is already common practice when using PDF TeX. But I don't see a common standard of TeX primitives, independent of PDF TeX, to embed links in TeX sources. When the hint viewer displays a page, the viewer's backend maintains a data structure that is simply TeX representation of the page as a nested list of nodes. Now, the viewer needs to extract information from that representation, or it wants to manipulate it. The user wants to click on a picture to enlarge it, or click on a link to navigate to the corresponding location. So the front end is given a position on the page and needs to know what picture or link is at that position. All these things need interactions between the user interface and the TeX data structure that is kept in the background. My question is, what should the API for such interactions with the document be? This might be of interest to all programs that interactively manipulate TeX documents. This is a somewhat special question. The implementation of HiTeX is written as a literate program in CWeb. Now, change files relative to Donald Knuth's implementation of TeX make up a large part of that implementation. And it is unclear, at least to me, how to present change files in a readable and understandable way as literate programs. Here is an example of my current approach. It is readable and the best I could think of so far. But suggestions are certainly welcome. The last question concerns the future of the HINT project. How can I make the HINT project a long-term success? I'm just a researcher and there is only a limited amount of time that I can devote to software production. And this is not a long-term solution. So I am looking for partners in industry that would like to turn the HINT project from an academic project into an industrial project. And this concludes my list of open questions for today. This concludes my talk. I hope it motivated you to try out HiTeX and the HINT viewer yourself. And of course, I would value your comments, your questions, your answers to my questions. Thank you. Well,
thank you, Martin. Can I start with the questions?
Sure.
I guess the first one, yeah,
there is one on the question and answers that asked, does Hint work with Hyperref? Hint at the moment doesn't support links, not external, not internal, and it doesn't support colors. So you can use the Hyperref package, and whatever would end up from a Hyperref in a DVI file would probably also end up in a Hint file. And so you could see the link as it would be on a printed piece of paper, but you cannot click on it because the clicking is not, the link feature is not implemented. That's not part of the high-tech engine. That's part of the Hint viewer. And well, in the long term, of course, it should support references to other books, to resources on the internet and so on, but in the moment not. It's still open. A plan for a viewer for e-ink readers. Yes, that's what I started with. I started the whole project when I published the mix supplement to the Art of Computer program together with Don. He helped me a lot. And then the publisher asked for an ebook version. And I thought, well, I gave them a good PDF anyway, so they should make it into some format that can be displayed on an e-reader. But the result was horrible. And it took me about half a year to get out the biggest flaws of the ebook version. And I was so dissatisfied with how the book looked on an ebook reader, on a Kindle actually, that I decided I should do something about it. And that's when I started the Hint project. Both viewers that we have in the moment, that on Windows and that viewer on Android, both rest on the same backend. There is a backend in C that basically reads the Hint file and produces a representation, renders a page as a data structure. And then there is an API for the viewer where you can say, okay, now page forward, or I want to have a page with 215 dots per inch and 3 inches wide and 2 inches high. And then you get that data structure and you can render it basically like a DVI viewer also does it. You traverse that structure and the front end gets told where to place which character at what position. Well, that's the front end. There are interactions between front end and back end, for instance, paging or zooming. And if you start with links, you have further interactions. But it's an ongoing project and it's not yet finished. And writing a viewer for an e-ink reader is probably possible. If it's possible to use Android and Windows with the same backend, then an e-reader should not be really a further problem. Not a problem that can't be solved. That's my...
Most of them are Android based anyway.
Yeah. There is some Unix under the hood.
Can I contribute something related to an industrial partner?
Once again, please.
Can I contribute something relating to finding an industrial partner?
Oh, you're welcome.
Thank you. I'm afraid it's not good news. Publishers generally don't have technical skills and they look for suppliers to provide the stuff. But suppliers, how do I put it? They've got a different business. So publishers might be interested in innovation, but they're working with suppliers. And this is true even with one company. I used to work for an academic publisher that had a print house and a publishing house. And they had conflicting interests. And the phrase they used was our best customer for the people across the road. So that was some time ago, but the nature of the economic relations and social relations in the industry might make it hard to get an industrial partner in a conventional sort of way, because you're not selling a database, you're selling something that's got a front end. And perhaps if you could establish some sort of market with perhaps authors or publishers, that might enable you to provide a market for the software developer. That's the problem, is you want a market for the software developer without there being the software, the software developer wants a market to exist. I think that's the problem I think I'm coming up with. I've stopped now, I've explained my experience.
Thank you.
A usual question. Since you now have very maturely released, are there plans to put at least some of it, for example, the processing part or part of the viewer on C10 and eventually to distribution like TechLive, MikTech, MacTech, and so on? It would really help people to play with your system and contribute.
I have the yet unpublished goal of having some version of Hint in TechLive 21.
Fantastic.
But it will still have limitations by then. But probably enough to do experiments and get something out of it. Yeah. But TechLive is basically the only business model that we have, because there are lots of people that use TechLive to produce documents. And the idea is, if it is just as easy as running PDF Tech or CTech or, well, High Tech on the same document, and you get two different output formats, then it's not really an overhead for the document producer. And it's easy for them to produce a PDF, send it to a printer, or publish it on the web, and have a Hint document without any extra effort. And then you have a Hint viewer, and you can read it on your tablet without extra effort for the author. And that might be, one way of getting the Hint viewer to be used on a broader base, not just a few eccentrics that use such a strange format. So that's definitely the aim.
Martin.
Yeah.
I see that you use PK fonts for the demonstration for scaling.
Yeah.
And I would hope, and I expect that you're playing with the blackness as the scaling is probably happening. How does it work under OpenType? How does it?
The blackness in the the Hint format embeds font files, and when you render a Hint file, so in the renderer, you need the front end gets the information that you need a certain character at a certain position on your screen in a certain size. And at that point, you get back to the font resource that is somewhere in the file. And depending on how that font resource looks like, whether it's a TrueType font or a PK font, you generate a bitmap, and then you render that bitmap on the screen. Now with a PK font, you have to fix the resolution when you generate a PK font. That's different from outline fonts. PK fonts are the only thing that are in the moment supported with a tech backend. One reason is that I'm doing research, and being able to render PK fonts is okay as a proof of concept, and rendering a true type font means that I have to use the free type library and bind it to the renderer, and then the renderer can do that. So it's not really a research project, it's a software engineering project. And when it's not a research project, but a software engineering project, I think, okay, we postpone that for later. We get it going and show what can be done, but we don't do it yet. And so, for instance, you can, I had made sample files with true type fonts. I did that by running TeX, producing a file that had an embedded PK font. Then I converted that short format into a long format, so you have basically a text, and then I replaced the name of that file, which was a PK font, with another name of a file that was a true type font, and made the short format again. And then I started the viewer with that file, and it would have the true type font embedded. And then the viewer gets the same information. Please display a uppercase A at position this and that in this size. And then the viewer says, okay, where is the font? Here is the font. What kind of font is it? It's a true type font. I know how to render a true type A at that position, and does it. So the kind of font and the resolution of the font that is embedded is only a problem for the viewer, basically, because TeX needs only the TeX font metrics. And then you embed, you have that information at the very end, what kind of fonts are used in that document, and then you generate them and embed some font file that is able to produce the bitmaps in the viewer. But it's only a question of using, let's say, free type library and rendering characters.
Interesting.
There is a question, might it be possible to export some of this so that the resulting document can be viewed in a web browser? Well, the hint project took TeX and split it basically in the middle. There is one part, and that's basically the front end, where everything runs in high-tech, and in the back end are still some parts of TeX. For instance, there is the processing of a paragraph. Splitting a paragraph into lines is one of the important algorithms in TeX, and that's done in the viewer. So the hint viewer will produce exactly the same paragraph layout as TeX would produce, because it's the same algorithm, it's just running a little bit later. When the viewer is active, you know how big your page is, what is H size and what is V size and so on. And then you can break lines, paragraphs into lines. So you have to postpone that. And that's an algorithm that is originally from TeX and that is now running in the viewer, but it's not running in a web browser. I mean, the processing of a paragraph also does a hyphenation. TeX has a 3-pass algorithm on paragraphs, running 3 times over the paragraph, and only in the second pass it attempts hyphenation. Now high-tech runs hyphenation on every word and it inserts in every word any possible hyphenation point, because you want to do a hyphenation early in the high-tech part and not in the viewer. In the viewer, you have all these discretionary hyphens in the words, everything. And then you can break the paragraphs, but the viewer still does 3 passes as TeX does. So it tries in a first pass to render the paragraph without hyphenation, even if all the hyphenation points are there. And in a second pass, it tries to use the hyphenation. Because only through that 2-pass algorithm, you get exactly the same line breaks as TeX would do. Well, the aim was producing a TeX document with PDF TeX and producing a TeX document with hint should give exactly the same line layout. So the hyphenations are at exactly the same place and the lines have exactly the same length. So you need that algorithm to display a hint file. And that algorithm is not present in a web browser. And that is also one of the problems with HTML, that usually the hyphenation algorithms are not very good. For instance, if you have formulas inside your text, then the line breaking of formulas is not just at any possible glue as it is in regular text, but you need to insert penalties in your formula that allow line breaking, and the penalties specify the cost of breaking at exact that position. And the line breaking algorithm optimizes the whole paragraph, minimizing the penalties. And that's the way how you get good line breaks in mathematical formulas. And that's a complicated algorithm, and it's not available in a web browser. So
what we could consider actually in using is WebGL. Because I mean, for the Android version, we are now using OpenGL, and we could maybe as like a future student project look into working with WebGL. So it's
but then good idea. But then you would need to take the TeX algorithms and rewrite them in JavaScript, for instance.
Can I come?
Everything, but well, I guess.
Can I come in on this? There's something called WebAssembly, which is 50% of the speed of C code. It's sort of written in JavaScript but compiled down to native code. And using that, people have taken the WebC sources, the web sources of TeX, translated them using mscriptum, and you can run TeX in the browser through WebAssembly, and the performance is horrible, but it works. So you wouldn't have to write your own implementation necessarily. And related to this is a question that I wanted to ask, which relates to the architecture or the role. My understanding of hint is that if you take a hint file, you can produce from it a TeX source file that is very, very low level. It really basically only uses primitive commands. And then when you feed that file into TeX, and it produces output through the output routine and the paragraph breaking and everything, you'll get the same output from TeX as you get from hint, because from hint you get the same output as you do from TeX. So instead of having hint follow TeX, you could have TeX follow hint. And in that case, you could use an existing implementation of TeX in the browser using mscriptum, and you're only using one tiny bit of it, which is the output routine and the paragraph breaking. And you could get a proof of concept without having to do that much programming. And then you can see whether it's worth doing in terms of improving the performance. So there's two things. The one is you can use mscriptum and put the thing into the browser, put TeX into the browser. And the other thing is you can, so to speak, reverse the flow from TeX to hint and take it from hint to TeX and round trip. A lot of the time that makes TeX in the browser slow is loading things up and doing the paths, loading files, finding files, all that sort of stuff, loading the format. Whereas if all you're doing is running the paragraph breaking and output routine, it's a considerably smaller and I think quicker piece of work. So it might be an interesting experiment, and at least it gives you a more encouraging answer to the people that want to put hint into a web browser. I'm happy to provide technical advice about this insofar as I can. I'm going to stop now.
Seems like an interesting project, but it's not my project. I'm busy enough with getting, for instance, links into the existing system, or making the integration with TeX Live. That's the project that I have for the next half year or next year. So, and I alwasee have to think what is distracting for me and what is the things that I have really to do.
You have one more question from Frank. If you could take that, and we delay Marcel just like a couple minutes.
Yes,
it's fine. I have time.
Frank asks, does it mean you keep track of the value of pre-tolerance and move it into the hint format? Yes, of course. You can specify and change pre-tolerance and tolerance and emergency stretch and all that, and it's in the hint file. And these
so you keep track of you keep track of all these parameters and pass them through to be able to get the same output. My question on this point was, is it really necessary to have 100% conversion when the main goal of the hint is that you are able to reflow, basically? In some sense, most of the time, the document will not be 100% the same anyway. If you want to have a printed version, you can start from the file that you started generating the hint to. Would be my idea of keeping things simple, because otherwise you have to have these things like pre-tolerance whatsoever being passed all the time exactly into the hint format.
Yeah, I do that. And it's not a performance problem. I mean, the performance is excellent, and it's even simpler.
Yeah, it was visible.
No. These algorithms are taken from TeX with a change file, and the change file gets shorter if I don't change too much. So if I leave the pre-tolerance in, I don't have to change the algorithm, and that's the easiest and simplest thing, to leave the paragraph breaking algorithm basically as it is. So I change as little as possible.
I would have one more question if I'm allowed to, Paulo. Otherwise,
I don't want to. Sure, go ahead.
What you said, you added language, and you asked yourself about the question on how to make links work and whether they are supported on the low level. In some sense, it sounds to me a little bit as if it would be maybe helpful if you think of the hint format as having two trees, similar to the way, say, PDF adds tagged information in the PDF. And then you can extend it in some sense by having on the second tree all these kind of additional information that link between your data structure that is for the textual part and your structural information that gets all this kind of information into linked from this second tree into the other one. If that would be there, then something like well, anything around, for example, accessibility, use of it in other aspects would be more or less automatically come with your hint format as well. And the transition, say, from something like, if LaTeX is able to produce structural PDF, it could, by the same backend, just with a change of the backend way to write, produce the hint file information in the form that hint would expect it. Just a thought. I mean,
yeah, no, it's a good idea. I try to collect the information for the hint file as late as possible from the TeX process. So whatever TeX does to its input doesn't play a role for the hint file. All that is, when the information flows into the contribution list, that's the point where I pick it up. So the whole pre-processing that makes basically the difference between TeX and LaTeX, it has disappeared, except that there are primitives that LaTeX is using that are not specified in Don's TeX. These primitives must exist. But these primitives usually don't generate new nodes. They just generate the usual data structures that are stored somewhere in mem. Some of these data structures, however, are PDF specific. So these PDF specials or PostScript specials where you embed some piece of PostScript code to rotate a word. That's basically PostScript code that is embedded in your TeX sources. And I don't like to have to parse PDF specials to find out what they
Absolutely
mean.
not. Absolutely not. And I mean, this is the reason why, at least from the LaTeX side, we are providing, if you like, a wrapper to this. I mean, if you in LaTeX say something like include graphics, and on the LaTeX side, it doesn't tell you whether it has to put in some PostScript special in or some PDF special or some other final device mechanism. So that is all handled by the backend. So if you have an expectation of some, basically everything for hint could be done by defining a set of specials that sits in the contribution list, and all that is needed from LaTeX side would be to provide that instead of the PostScript specials if you run hint. If you see that would be a single point of getting either to PDF or to PostScript or to something else to hint.
I will get back to you in fall when I start getting the graphics with the X package to run under hint.
We can meet on the next birthday of Don or something, or maybe earlier.
That's in January. When the next semester start, I will do the graphics package.
Okay,
That's one
cool.
of my plans, and then I will ask lots of questions to you.
Well, we live in the same country, right?
Yeah.
Okay.
Same time zone.
Well, thanks very, very much for a beautiful talk, Martin. And thanks, Gudrun, as well. We'll hope to see you soon in better forms, better formats.
What do you mean? The formats are not nice? It's a nice picture of Martin with the background of Don's book, so I can see 4 at least.
Yeah, no, hint is a beautiful format, and be able to handle it is amazingly good, like Gudrun said.
Okay, I think we are over our time allocated, and Marcel is already waiting.
Yes, so Marcel, take the stand.
In case you're talking, Marcel, you have to unmute yourself.
Can you hear me now?
Yes.
Oh, yes.
I should be unmuted now.
Starting now.
Can you? Okay, I
so
just have to find out how to share the screen again.
So here's Marcel with a talk on delimiters, variable delimiters.
Right, I have the very nice and compact title, Metapost-based dynamic extensible delimiters for Lua LaTeX. I heard that academic talks always have to have at least 2 lines of title, so this is my attempt. But basically the idea is pretty simple. We all know delimiters in TeX. So basically I'm talking about the things which we can use with left and right. And we want them to be extensible in many cases, and I want to make them look better when we extend them. So let's look at the current way of using delimiters. We have, to some degree, just multiple sizes available for most of them. We have the normal ones, we have a big one, a bigger one, and then the version with 2 Gs, where I don't really know how to pronounce any of these names. And we can see some examples here. In this case, we also see that the normal ones and the big ones come from different fonts, which looks a bit odd, but that is just a font choice. And sometimes we also have something bigger inside of our braces, and then we can make them extensible using left and right. And here we have an example where I configured tech to always use the next bigger available one. And we can see that they just extend to arbitrary sizes. Of course, this isn't how you would actually want to write brackets around X, but this is just a demonstration. And here in the third line, we also see how this mechanism sometimes fails. Sorry. Here we have these which don't fit on a page, but also stop growing at some point, mostly because the mechanism for making them extensible simply doesn't work. Also on the other side over the A, we see accents in math mode. In this talk, I'm mostly talking about LuaTeX, which mostly uses open type-based math algorithms, where accents in math mode are mostly handled in the same way as extensor delimiters. So I will talk about accents too, just in case that you're confused what they have to do with delimiters. That works a bit differently in classical tech, but we are working with LuaTeX. So how do extensor delimiters actually work, and why are there problems for some, and why do they look a bit odd when they grow? They're implemented just by repeating some elements while stacking them. So this is the example for ground parentheses, where we have the top element here. Oh, that doesn't look good. Which comes at the top. We have a bottom element, and we have a repeatable element, which comes in between of them. And we can actually see this here. If we look at this character, sorry. Here we see that this is the top element, we have the bottom element, and then we repeat multiple times just a straight line. And I think that this, of course, this leads to parentheses which actually look like they are big, but they don't really look the way I would expect them to look, because they are called round for a reason, and when I try to write them by hand, they look weird because I have a weird handwriting, but also they are always round and they don't start being straight lines at some point. So I thought, how can we actually fix this? And first, let's see what we actually want to achieve. We want to replace these traditional ones with really round ones, which basically have the same size and also can have basically any size we want. At the same point, we also want to allow to fix another issue we have with the original ones, if I go back, which is that we only have these discrete step sizes. We see here that we always go to a next available level, and there's no real reason why no level in between should be available. So there are multiple approaches on how to actually make these truly arbitrary sizes for delimiters. And maybe the most obvious one is, let's use MetaFont. It allows us to use fully parameterized fonts so that we can actually use as a parameter the size of the delimiter we actually want to use at a certain point. Also, we have the advantage that for most tech math fonts, especially for the computer modern family, we already have MetaFont code available. But there are also some disadvantages, which are mostly that the parameters in our parameterized fonts always have to apply to the whole font, and we can't say we want to have this one character which we want to output with different parameters. And this, of course, can be fixed by defining lots of parameters, but then in the end, we have to rebuild the entire font just to get a single new character, which would just be slow. And the other thing is that MetaFont always outputs bitmap fonts, and we don't really want bitmap fonts in most PDF documents, because in many cases, we don't know the size in which they will actually be printed and showed on screen, and people zoom in and zoom out, so it's hard to use bitmap fonts reliably. Also, they don't allow any hinting, and I think that's less of a problem in the current days because hinting is mostly ignored anyway in practice. For example, my PDF viewers are all configured by default with settings which just ignore any kind of hinting. So this is not really a big problem, especially because of our high resolution screens, which make this a bit less relevant. So an alternative for most of these is to use MetaPost instead of MetaFont. Of course, I think I skipped a slide, but no matter. We can still use them to generate fonts, even if the MetaPost is mostly used for graphics these days. And it's also mostly MetaFont compatible, so we can still use our pre-existing font files mostly in MetaPost. Also, it's integrated in LuaTeX, so we don't have to call some external program just to regenerate our fonts on demand. The problem is that we no longer generate bitmaps, but we still generate pretty much arbitrary vector fonts, which can have lots of complicated instructions, which don't really fit the traditional idea of a font in PDF. And we can still output them as fonts, either by using virtual fonts in LuaTeX or by using type 3 fonts directly in the PDF. But in both cases, PDF viewers generally render them very different from traditional font formats like type 1 or open type fonts, even if they contain the same instructions, because they use a completely distinct anti-aliasing system which doesn't work that reliably and focuses on other things. It tries to avoid skipping any kind of drawing, even if that makes them look a bit weird. Also, we still don't have any hinting because, well, the formats there don't really support hinting. And oh yeah, of course, parameters still always apply to a whole font. And maybe the next step would be to do the thing which has been done for Latin modern and similar fonts by the Gast font group. Sorry. So we use MetaType 1, their system for generating type 1 fonts directly from MetaPost. We need to use slightly different drawing instructions, which are not really compatible with MetaFont fonts, but they are still mostly the same. So we can still convert most MetaFont fonts in practice. Also, we don't really have built-in support for MetaFont's pens, which are used in many fonts, but they are not used that much. And also we can emulate them to some degree. That doesn't create a perfect conversion, but in most cases, you don't even see the difference. So that's not a big problem, but the biggest problem with the conversion of MetaFont fonts is that there's a lot of manual work required because we no longer can have any overlap in the font, and the general handling of multiple curves is very different from traditional MetaFont and even MetaPost modes. So we need to overview the entire process and have to convert lots of fonts manually. But especially if you only need some glyphs, that's not a problem. And the advantage is that we now get type 1 fonts as output, which is a great format and commonly used in the tech world for vector fonts. And we even get hinting if we really want it, and if we are prepared to invest our time to actually hint the fonts. Of course, we still have the issue that parameters apply for a whole font, and we also have a pretty complicated use. MetaType 1 is typically distributed as a collection of mostly Windows batch scripts with some AWK scripts, and some other weird techniques, which is a bit hacky and which only really works on Linux. And mostly, it's just complicated to actually build a font using this technique. There is a newer algo type version which relies mostly on Python and then calls FontForge for most of the heavy lifting, but it doesn't really make it easier to run the whole thing from LuaTeX. It would still be simpler to call MetaPost directly from LuaTeX, and especially not to require FontForge anyway. So let's make a plan for an system based on meta type 1, which would actually be usable from LuaTeX directly. To avoid the problem that we always have to build a whole font, we can actually avoid finalizing our font anyway and only do the initial setup of a font, and then basically have a lot of MetaPost functions, and I call them functions, macros basically, which can generate fonts, individual glyphs from fonts on demand. This is very supported by the MetaPost library integrated in LuaTeX, which can give us the output corresponding to an individual glyph, even without finalizing the whole font. Then we need interfaces on the MetaPost level to actually generate, to make it easy to actually register these functions, that can then be used for extended versions of our glyphs. Then we can convert this MetaPost output to type 1 fully using Lua code. In our case, we actually want to generate type 2 char strings, which is a more compressed version in type 1, and where you can avoid issues like encrypting the char string just to decrypt it again at the render level. The type 1 format is a bit weird. But type 2 formats, also known as CFF, which are also used in OpenType fonts, are much easier to generate, easier to use in the backend, and they support in PDF fonts, so we can generate them using Lua code. And then we want to dynamically generate these char strings, and in the end build a font, which again is supported by the LuaTeX backend. There are basically two issues which I encountered when I tried to implement them, which is mostly that it uses a lot of components in ways which they are not really well tested with. In the end, I still ended up with 2 bugs I triggered, or I don't really know if we can call them bugs, because the development team is not fully convinced yet that they are not the intended behavior, but I would mostly consider them bugs, where one is that I actually want to use MetaPost in a format which doesn't use the traditional scaled integers which are common in MetaFont-based fonts, but I want to have an extended system which uses decimal arithmetics to get much bigger integers supported, especially because we want to use Unicode-based code points, which just use numbers which are bigger than support in MetaPost. The one issue we trigger is that instructions, which are quite common in many meta fonts like this, to draw a line between a point x1e to x2e, are read in a weird way, because MetaPost actually interprets them as 1e minus, which it interprets as a short form for 1e minus 0, which is notation for 1 times 10 raised to 0. So it's basically just 1. So in any case where a digit followed by e minus appears, the e minus just disappears, and we basically get the output I've showed next to this. Of course, if this randomly happens in the middle of your font definitions, things break a lot and you get really weird error messages, which will be hard to identify sources. So this means that we can't actually reuse much code, especially not from the Computer Modern project, but always have to rewrite at least some part of this. But that is necessary anyway because of this slightly different drawing instruction, so it's not a big problem. Also, the MetaPost library is not really intended to be used with multiple instances which are active at the same time, or at least not with the case that they use different callbacks. So there you get some weird issues which we can work around, but which I would prefer to see fixed upstream. So then we can actually write a library, and this tries to show how this library can then actually be used in a LaTeX file, which has the big advantage that it works completely like loading any other font. What we basically have is that at one point we just have to load our library. Then we can just use normal LaTeX instructions to load the font family and use normal LaTeX instructions to register it as a symbol font, which can then be used for our actual characters. Let me show you this in an actual example of such a font. Okay. So for example, if we only want to, I just need some feedback. Can you read the text? Or should I change the
It could be
size?
larger, but it is readable to me at least.
I will try to. Okay, I don't see the difference right now. Oh. Sorry, can you? Yeah, okay.
That looks good.
Is this better?
Much better, yeah.
Okay. Okay, maybe let's separate the important parts. We just have to, at some point, load our two libraries. Fix and plib is a workaround for one of the, in my opinion, bugs. And then we can just declare our family. And then we can use this my parent family in a completely regular way to just declare del codes and to implement square root. The square root code here looks a bit more complicated because I use lowercase u root to get, well, to handle the optional argument. And also we can then use similar things for accents, which should work with this, for example, here in the white hat example. And then they behave completely the same as our normal characters. So for example, if we now want to create a weird matrix, we can use the pre-existing P matrix environment, which uses normal parentheses without needing any changes there. Or we can use square root, which now also uses our extended version, without needing any change to the actual document. So let's see what this actually generates. No. Of course, we always have to compile with Lua LaTeX because basically none of these features even have a chance of working with any other engine. And we already see that there is some logging for searching for weird character names. Okay, I thought that it opens now. And now we get the output we basically expected. We see that our parentheses are no longer straight in the middle, but they're actually round in a full scale, and they actually grow with our matrix. We also see that it almost looks like they're a bit shorter than the matrix, but that's actually because of the configuration of text delimiter shortfall and delimiter factor, which become much more visible if it's not hidden by text normal restrictions with discrete sizes of delimiters. Also, we see that our square root now grows correctly and also doesn't become straight, as it sometimes happens otherwise. If we do this with really big matrices, we also see that the current implementation has some issues, mostly that the parameters don't really work for big sizes, and currently it generates weirdly bold braces. in parentheses, but that can be fixed by changing the actual font instructions. And my attempts to do so failed because I don't really have a hand for font design. But otherwise, they work correctly. And we also see this was supposed to compare both versions, but we see for the, okay, I lost my tools. We see here our new accent, which now fully covers the text, and in comparison to a text traditional one, which basically just stops at a certain size and no longer can handle this. And this is basically what we wanted. So in addition, let me show you how this actually works from in the MetaPost code and how much changes are actually necessary to our existing characters from computer modern. The font which was used here is our parent MetaPost font, which mostly looks like normal computer modern fonts. And at the top, we note fontbase.mp, which is the primary MetaPost code corresponding to meta type 1. And afterwards, we just define basically the same font dimensions we define at the beginning of CMEX10. Then in addition, we need some PostScript parameters, which are later been into the open type font, which is actually embedded into our LuaTeX document. So for example, we can specify which name we want to use or which version number. Also some underline parameter, which are mostly ignored anyway. And then we just have normal metafont code. Currently, I still have to define these two functions here. These basically are magic and you can ignore them. And then we begin our actual font. Here's, for example, let's skip down, the definition for our left parentheses. And it's actually pretty simple. We just say we want to have we want to be flexible in a vertical direction. And we want the glyph, which is normally known under the standard name parent left. Then we can specify a default size, which is used if we don't specify left or right in front of this parameter, in front of the delimiter. We can also specify some to Unicode mapping, which is used for copy and paste in the PDF font later. And then we can specify how the width of the individual glyph is computed. For example, for parentheses, I try to extrapolate the rules in the original CMEX font, which failed to some degree, and uses this formula up here. And we can specify the height of the actual glyph. This is by convention always rule thickness for extensible fonts. This is mostly necessary because of the square root sign. And this looks pretty similar to the original source code from CMEX. Let me open that here. Oh, that's the wrong file, sorry. Here we have basically the same code, except that we have to rename some little names, and that Donald Knuth didn't really like the concept of line breaks when he wrote this code, I think. But we see the same components. We have a begin char, which just identifies the character, gives us here the 7U width of the character, the height, and the depth. The depth isn't specified in our example because it's automatically derived from the actual size we want to generate. Then the function they call, which for computer modern is called adjustFit, is translated into our fixed exact HSBV. And then we just call the left parent functions in both code bases. So that's look on how much actually has to change in the parent, because that's the function which does the actual work. It's actually specified somewhere else. So here we see our metafont version of left parent. Sorry, wrong window. And this is our MetaPost version, which we want to use instead, and the highlighter. And again, we see that they basically do the same thing. We use a slightly different instructions for picking up the nib, because we actually just emulate this instead of using basically primitives. So instead of pickup, we use pick nib. But otherwise, the only real difference in the next 4 lines is that we don't round as much as the computer modern code, because we basically generate vector fonts anyway, where we don't have to round to full pixel values. And then in the end, we can't use filter, because the filter instructions actually uses a pen, and we have to generate a path and then use pen stroke. But basically, they are not really all that different, and this can be done with very little work if you just go through these individual functions. So we have to only change very little stuff to actually get fully dynamic characters, which can use all of MetaPost's functionality, at least the functionality which is available in MetaType 1. So what are the next steps intended for this project? I'm here. Currently, the code this company is private and only exists on my hard drive, but I will publish it in the next days. And also my current parent font, which isn't really ideal, but demonstrates the existing concepts. Also, I plan to refactor the code base so that it actually becomes readable and not the current mess, which I wrote about a year ago. And then the actually biggest part is that we actually need a complete temporary font which uses these systems and actually adapts to arbitrary heights and widths as necessary in our documents, and doesn't create these weird monster parentheses you've just seen in my demo. And of course, there's also the important step, which is basically my life mission, to convince everyone to switch to Lua LaTeX for all of their documents so that they can use these awesome features. Are there any questions? I have to stop share. I see there's at least one. No?
I have a question, Marcel. Marcel?
I will shortly start with the things in the chat.
Yeah, start with the thing in the chat and then we move over to questions online.
Okay. Ulrich Wies asks, as of TUG 2019 last year, it was announced that a rework of MetaType 1 is planned or in the works, where most of the post-processing would be rewritten in Python. Not sure about the current status. I can tell you that if you ask the team very nicely and have a lot of time, they will send you the code. But it's, well, yeah, basically it still uses the same MetaPost layer and then uses the output differently, which is not really all that relevant for this project because we basically have a completely different output handling anyway. Also, I especially did not want to use Python or FontForge, which is used in their project, because I want to fully integrate the whole thing into a Lua Tech run without any external libraries and dependencies. As on an earlier Bacotech, Mark Rico presented a system where big delimiters or radicals could be rendered on the fly at the required size. That sounds very interesting. I haven't seen it, so I will have to look into this. Mark Person Sundquist wrote, zooming in, it is clearly readable. That was probably about the sizes. And Luigi Scarso wrote that the MPLib bug should be fixed, and if I can send him an email, I can send it again, but I actually already wrote about both things multiple times. I will write you again. I see some and Boris Weitzman means he sees some problems with item 4 on the next step slide. Yeah, that's a long-term project, but I'm confident that at some point we will succeed. There were other questions?
Yes, Marcel. When you say design a font, which is, a font with delimiters, that would be a sort of a companion font for one particular font. Is that correct or not?
Sorry, what do you mean? Can you repeat the question? I didn't understand.
I don't think that you can design a set of delimiters that will fit Minion Pro and fit Computer Modern at the same time. Most designers would agree that delimiters on Times Roman are completely different delimiters on a sans serif font. So,
actually, we've already
say.
Yeah, actually, I think the idea is that we first need one font for some commonly used base font. So basically, a Computer Modern version. And this could then be used as an inspiration for other fonts to add additional fonts. But basically, the idea is that for every font, you need a corresponding version of this delimiter font. Actually, if your font is meta type 1 based, or if your font is to some degree Metapos based, you can actually integrate this into the main font. So then we won't even need separate fonts. But yes, right. To actually use this with multiple fonts, you of course need multiple delimiter fonts to make this actually look right. Actually, the original inspiration for this was that I didn't like how curly braces look in Computer Modern because they are so straight, and I would like them to be curvy, especially in big sizes. But that doesn't even fit into the Computer Modern system. So that wasn't used as an example. Yes.
There is a pointer by Ulrich Viet on the chat pointing you to the work by Marek Rico, and he says that unfortunately there's no slides, no demo. But if you want to check that, I would suggest you looking at the Bahotech people, because the talks at Bahotech are in general all recorded by one particular guy that makes them available on his own YouTube channel. And I can try to dig that up for you.
Oh, he died, unfortunately.
Oh.
I don't know when that was. It might be that he still has them somewhere, or they are still recorded, but he's no longer with Bahotech for I don't know, 2-3 years.
Oh, sad to hear that. Another question coming up on the chat.
Yeah, I see it. Would there be a way to extrapolate from the normal delimiters that are already included in any font to get a matching set of big delimiters? The problem is that if you only But basically, if you start with a font which doesn't have any extensible delimiters at all, so then basically the easiest way to do this is to just scale them. And that is possible, but it leads to very ugly results, in my opinion, especially because they get, as if we've already seen this issue in the one slide where this very thick parentheses appears, and that actually happens much earlier if we just scale them instead of using some more complicated formula in the backend. And also, please send chat messages to attendees so that they know the messages. Okay, any more questions? That doesn't seem to be the case. Then I hand off to, I don't know right now to whom. I will hand back to Paolo.
Thank you very much.
Thank you for listening.
Thank you very much for your talk. I hope to see more of it in the future. Thank you. Next talk is Brandon Rhodes, and it's about typesetting with Python. And Brandon would love to have been with us, but he had some family affairs. Oh, there is Brandon.
I will not be obviously presenting the talk. You're about to show the recording of the talk last year, but I hope to be able to show back up at the end for any questions.
Thank you very much for your presence, Brandon. So we'll get started, and this talk was recorded first at PyLondinium in 2019, and you see a live audience. It was recorded a bit before COVID-19 pandemic.
I want to thank the organizers. I want to thank the organizers very much for inviting me. It's been at least half a decade. No, yeah, half a decade. It's been 5 years or more since I first got to visit London, and I've really enjoyed my visit, and I've really enjoyed the energy of the conference, and especially how, compared to other conferences I've been to in Britain, how many different places you are all from. I've enjoyed meeting you. And I'm here to talk about typesetting with Python. When I was growing up, there was a book on my father's bookshelf. He was an electrical engineer. It attracted me because of the interesting design of its cover, which showed an ancient way of trying to design the letter S. It was by someone I'd never heard of named Donald E. Knuth, and it was called TEC and Metafont. Not text and Metafont, no. He named the typesetting system that he wrote after the Greek word techne. They had the same word in Greek for both a craft and an art. And so he named his typesetting system not with the letter X, but with the Greek letter chi as its third letter, tech. It introduced me, as I read through the book and he explained its workings, introduced me to the idea of a markup language. I'd never heard of such a thing. Instead of being in a WYSIWYG editor, you just wrote plain text that you were completely in control of. And then tech read the plain text and turned it into a document. You had to learn some conventions, some commands that started with backslashes and the proper use of curly braces, but you got to write plain text without thinking much about how it would be laid out on the page, and the text system swung into action and made it look like a professionally typeset paragraph from a book. The book's lessons on how to type these .tech input files were themselves a small course in typography. You learned where to put non-breaking spaces, because it turns out it is a minor typographic disaster if a title like Dr. or Mr. or Mrs. ends one line of a paragraph separated from the name on the next line. So I learned about non-breaking spaces. I learned that these 4 pieces of punctuation are completely different, and it is entirely wrong to use any of them.
Paolo, I think you muted yourself.
Thinking much about how it would be laid out on the page, and the text system swung into action and made it look like a professionally typeset paragraph from a book. The book's lessons on how to type these .tech input files were themselves a small course in typography. You learned where to put non-breaking spaces, because it turns out it is a minor typographic disaster if a title like Dr. or Mr. or Mrs. ends one line of a paragraph separated from the name on the next line. So I learned about non-breaking spaces. I learned that these 4 pieces of punctuation are completely different, and it is entirely wrong to use any of them for the other's purpose. The hyphen, the n dash, the m dash, and the minus sign look different in the case of the minus sign, are at a different height on the line and have completely different purposes. You will be frequently annoyed for the rest of your life. If you learn the difference. And again, it's markup language. Even though all you had was ASCII keys back in the 70s, there was a way to separately type each of those symbols into your input file. Its specialty was math typesetting. Donald Knuth was a mathematician, and that was the real reason for inventing tech. When math journals stopped paying for professionals to expensively set type by hand, math papers looked so ugly that Knuth could no longer publish. To survive as a mathematician, he had to remedy the situation so that he could stand seeing his equations in print. And so he took an entire year off, I believe it was 78, might have been 77, to invent tech. And so its specialty is inside of dollar signs, you have a little language that kicks in, underscore is subscript, caret is superscript, where you can just say, well, take the sum from k equals 0 to infinity, and out comes beautifully typeset math that looked to me like something from an expensive professional math book. It was a beautiful system. He did not ignore non-math problems like breaking paragraphs into lines. Tech represents the words of a paragraph as fixed width boxes separated by stretchy glue, because to lay out a paragraph, you try to make the lines the same length by stretching or shrinking those spaces. This internal representation of the problem of breaking a paragraph into lines has a combinatorial problem. A paragraph with indecisions in which text could be split into lines can be laid out 2 to the n different ways, depending on whether you take each break or not. How could we ever find the optimum layout? I'll bet you thought dynamic programming existed only to be a whiteboard problem in interviews. Donald Knuth actually found dynamic programming could solve that problem and provide the optimal solution for breaking each paragraph into lines in an n squared worst case, actually usually only on the order of the number of possible breaks. So you put in plain text, it turned it into boxes and glue. and it managed to beautifully line up that right-hand side of each paragraph just like in a book. The output of tech was beautiful, but as I then someday, I eventually had a computer powerful enough to run it, I found it was difficult to control. Once you set up the parameters, layout proceeded largely outside of your control. It reminded me of a problem that I've seen recently, which is the tractor and trailer problem. Tractor has a motor and can move forward and back, and the trailers are simply passive. If you've ever tried backing up a single trailer, it can be difficult. They often today consider, for factory floors and things like that, 2, 3, 4 trailers. If you've ever tried to back up a small toy train, you might have an idea of the difficulty here. Backing up a tractor and trailers is today an open problem in AI. You can find recent papers that talk about, could we back up 3 trailers with an appropriate AI? Trailers are difficult to back up because the input, the motion of the tractor, has an increasingly distant relationship to the motion of the nth trailer. And that problem, trying to control tech, sometimes felt similar. And in general, I would say that frameworks in programming, and I use that term in its fully pejorative sense, frameworks often have the same problem, that you feel like there's this little opinion you've been asked for, and it can be very hard to get the form that the forms library outputs to respond to the settings that you're trying to change. Controlling tech felt similar. So I had an idea. What if instead of typesetting systems that we merely configure and then run off and do their thing, what if there were a typesetting library left the programmer in control for difficult situations that you might want to customize? Recently, I realized that typesetting and printing a book from Python was coming within technical reach. There's now an industry called print on demand. All you need to give them is a PDF, and they can send you back a custom hardcover book that is all yours. A real hardcover, case bound, and Smith sewn, not something just put together with glue. We now have technologies that largely replace all the things Donald Knuth had to invent on his own. We now have TrueType and OpenType. We don't have to invent the idea of vector fonts. Instead of a macro language, there are many ways to represent paragraphs and headings in plain text. I didn't even need to implement paragraph layout. Andrew Kuchling translated that boxes and glue algorithm into Python long ago and called it TechLib. And we don't need to use text custom DVI output format. PDFs are now the industry standard. But I needed something to print. This is the problem with little projects that you dream about. And then I stumbled across a backup of my grandfather's essays, which after he died in the 90s, I'd backed up off of his computer. I could write the typesetting myself in Python and have a gift to give to family members, a hardback of his thoughts and memories and history. So, all right, we're going to be re-implementing tech. What would I do differently? If I'm going to try to do layout over again, what's the thing I want to focus on? I chose a specific first goal to see if I could not just re-implement it, but do something interestingly different. What about different width columns? As you're laying out the document, that's not supported in tech. It wants each column to be the same width. As tech breaks a paragraph into lines, it doesn't even know what page the paragraph will land on, because first it splits the paragraph into lines at some width. That's a separate step from then figuring out how many lines of the paragraph fit on each page. So you can't support graphic designs that have one width on the first page of your newspaper and maybe a different column width on the inside. You can't support graphic designers that on the front page of the article have a single wide column to accommodate an image, but then on the inside have a double column. My idea was that the paragraph should ask for more space as it needs it, so it learns about any width change when it asks for more space and has to cross to a new column. I wanted to see if I could get that working, because that would be a real advance over what tech had been able to do. So my plan was to find a library for rendering PDF from Python and then invent a new page layout engine. I decided to tackle them in that order. I had already used to make I think a program, a printed program for a conference. I'd used Report Lab. It's a PDF library in Python. And so I hooked it up to Andrew Kuchling's TechLib, and I printed out the first paragraph of my grandfather's first essay about his great-grandfather in 1800s Alabama. And the result, as you can see, was a disaster. On what? Yes. We're just going to have to stop right here. This is the best that we can do. And interestingly enough, when I used this font on the web, I double-checked it, the word war looked fine. Report Lab specifically as a library doesn't understand that TrueType and OpenType fonts come with a table, a kerning table, that tells you that some letters need to be pushed closer together or they'll leave a gap. It didn't know about kerning, so the word war is an unmitigated disaster here. Fortunately, it turns out there was an alternative. I'd always thought that the Qt library was kind of a useless way to write big bloated desktop applications, but it turns out that desktop applications need a print button. And so Qt has an entire PDF rendering engine inside of it that, thank goodness, reads the metrics of a font before putting it on the page. All right, so I have my PDF library. I was moving again. The input is going to be, from however my text is stored, a list of typesetting actions, titles, headings, and paragraphs. And now I simply need to design the routine that will run through them, putting them on the page. What API should the layout engine use to call each of these actions, like heading and paragraph? Well, let's start by asking, what information does an action need if we're going to set it loose, laying out content on page? Well, I thought it would need to know the width of the text it's expected to lay out. We'll need to probably know the height of the column, so I wrap that up into a little object. And then it probably needs to know how much of the column's been used already. It needs to know the Y coordinate that it should start at as it adds more content. Each time the paragraph needs another line, it can look at the amount of leading it needs. It used to be a little sheet of lead that you put in between each line of type. Today, it's just a little blank space to give a nice line height and not crowd the text too much vertically. And the font's height. And if the current Y coordinate plus the leading it needs to add, plus the size of the font it needs to add is going to be more than the column's height, we're out of room. We ask for another column. How do we ask for another column? I had several possibilities I could try here. Maybe the column itself has a method called next. Maybe we pass a layout object that can give you new columns as you ask for them. Or I could just pass a next column callable. Number of different options. I decided to pass a plain callable. And I knew it was the right decision when I did it, and that wouldn't have been true when I was a younger programmer. I knew that if all the paragraph needs is a verb, the next column that spits out new columns, that's all that I should pass it. Why? To avoid, I decided I needed a name for it, premature object orientation. There is an old saying in computer science, premature optimization is the root of all evil. Who said that? Donald Knuth. I didn't know that until I looked it up. Premature object orientation, which is my phrase, is attaching a verb gratuitously to a noun when you don't actually need to yet. The symptom is when you see code passing an object on which a function will only ever call a single method. This is the symptom. You're given an object. Why? All you ever do is call that single method. Why not just pass the verb instead? Premature object orientation couples code that needs only a verb to all the implementation details of the noun, because you receive the whole thing. And so, because of some restraint that I've learned over my career, I simply passed the callable next column that generates new space in the document. I now had a rough plan for an action's inputs. What now will an action return? Can, for example, a paragraph simply go ahead and draw on the output device? No, it it turns out it cannot, because there are a number of problems which I can illustrate by talking about headings. Heading is supposed to sit atop the content of which it's the head. I guess that's why it's called a heading. It looks sort of like this. This is a paragraph laid out by my, Andrew Kuchling's TechLib library, called by mine. And paragraph ends, and we have just enough room on this page for the heading and a line of text. What if there's no room beneath the heading? What if the column were a little smaller? Well, then you get a typographic disaster. If the column weren't high enough for that line, the heading would stand by itself, not heading anything. The heading, in that case, is going to need to move itself to the next column. Far better to have a little blank space at the bottom of a column than to have a heading that doesn't have any content beneath it. Now, you might think that that's going to be easy to avoid. Can the heading simply check whether there is room for an extra line beneath it? But checking for a free line won't, alas, always work. Why? Because a paragraph might not choose to use the final line of a column because of something paragraphs do on their own. They're tricky beasts called widow and orphan detection. A single line paragraph might deign to remain at the bottom of the page, and then our heading has something to head before the text moves to the next column. But a multi-line paragraph will refuse to leave its opening line alone, will refuse to leave it an orphan. It will look and say, I can't leave that line by itself. That's considered a sin in typography. So even if there's the space for a line, a multi-line paragraph will pull it up to the top of the next page to look better, leaving the heading stranded, even though it looked like there was enough room for more content. Well, okay, if paragraphs are going to do tricky interior things, decisions about where they land, how can the heading predict whether it will be stranded alone? Well, it can either know everything about paragraphs and have inside of it all of the details about how paragraphs lay out. That doesn't sound wise or sustainable. Or I could invent a way for a heading to ask the next action to lay itself out speculatively. And just kind of ask, well, if I stay here at the bottom of the page, what paragraph will you do next? But this is going to require undo. The ability, if layout goes wrong, if I wind up stranded, to back up, because the heading is going to have to add itself to the document and the following paragraph. And if it worked, if having done that, there's some lines of text beneath the heading, we're done. The heading finds that it wound up stranded and alone, you're going to have to undo the paragraph, undo the heading, start over again on the next page. That means these routines cannot be writing to the PDF manually. Layout is going to need to return an intermediate data structure that the caller can inspect instead of just starting to write type all over our document. Consequence number 2 is that the intermediate data needs to be easy to discard. I went through several pencil and paper. I don't even try writing code at the stage of design. I tried to figure out what relationship would let me add stuff to a document plan that I could then just take away. And I was startled to discover that a very elegant data structure for it was one I had never used in Python. In Python, I used a linked list. I defined a line as not only belonging to a column, having a Y coordinate, and then having some graphics that if you decide to keep the line, you draw on the page, but I gave it a previous attribute, which as I go down the page, I set each line's .previous to the line above it, thus creating a linked list of lines that when I need to stop and make a decision, I can run a paragraph's layout one way, look at those lines, run it another way, and the two possible futures for my document automatically share this as storage all the previous document without my having to store it twice because they both share a reference to it. A linked list lets us extend the document with any number of speculative layouts, which Python automatically disposes of as we discard them. Actions, okay, are now going to need a new argument. Because if the job of an action is now to append new lines, they need as an argument the most recently laid out line before the action goes to work. Ooh, but look. Remember how a paragraph needs to know the column it's drawing in and the Y position so far? Those are two attributes of the line itself. I didn't know I'd be passing lines in as an argument, but now that I know that this gets passed in, I no longer need to separately pass in the column and the Y coordinate. The paragraph learns everything about the current context merely by looking at this line object that I didn't even pass in for its own amusement. I passed it in because it needs to append more lines, but it wound up carrying almost all the information the paragraph needs. In other words, designing our return value wound up eliminating two of our input arguments. Always look for chances to simplify as you proceed with a design. It's often pleasant how things simplify as you go along. Another nice thing is the symmetry that this concept of a line provides. The line becomes a common currency that's both our argument, we get one line passed in, and our return value as we return a new terminal line back out. All right, but how will the heading action invoke the action that follows? I haven't talked yet about how the heading talks to the paragraph. And how will it tell the engine that the following actions already laid out? If the heading needs to lay out the paragraph, it needs to tell the engine, hey, I've already laid out the paragraph, don't do it over again, now that I hand back control and return a value. Once again, pencil and paper, I looked at special callable and exception. Should these two things be coroutines that talk to each other? I took a deep breath. All right, and I looked at the reality of however I arrange the conversation between the heading and the paragraph, the real reality is that I just have a list of tuples of things that I need to put on the page. And so I thought of something kind of radical. What if I just pass the list into the heading and the current? I know that sounds crazy. You'd think I would hide it behind something. But what if in this case, I just tell the heading the truth? Hey, there's a list of actions. You're at position A. Go to town. And when you return the concluding line from all the work you've done, tell me how far to advance my counter before continuing. Incrementing and returning the A index lets an action invoke as many subsequent actions as it needs to compare different outcomes. Stepping back, I wrote several routines to that spec. I looked askance at the amount of repetition in my code that this created. Heading took actions in A. Section took actions in A, both used them. But a paragraph which doesn't care about the subsequent action also takes actions in A, as did other simple routines. They just kept returning A+1 because I laid myself out, continue. And that seemed a bit verbose. For opinionated actions, like headings that care about what follows, it's necessary to pass actions in A so that they can get to the next thing. But simple actions that just lay themselves out and don't care about what comes next, ignore them. And so the simple actions at the bottom are receiving parameters they don't really need. How can I eliminate actions in A from simple actions that don't need them? This is a principle in programming called DRY. Don't repeat yourself. And when I thought of those words, I suddenly heard the call of distant decades. The 1990s called and said, from the practices back in the 90s, that in Python I can introspect functions to learn if they take actions arguments or not. So given a list of functions, I can just leave actions off of these argument lists and use Python's introspection abilities to know whether to pass those arguments or not. The 90s, crazy times. Oh, but then the early 2000s called. I could have a special registry because functions are objects and can be enrolled in data structures. I could have a registry for functions that don't need actions in A, so I know to call them differently. The late 2000s called. I could have a decorator for functions that don't need actions in A that takes those two parameters, but doesn't pass them to the function being wrapped. All I would then need to do is put that decorator in front of each of my simpler routines, and I wouldn't have those extra parameters. Don't repeat yourself. So I looked at the different possibilities that Python makes possible, and what did I decide? I decided to repeat myself. I decided after several minutes, after probably about a half hour of deliberation, trying different things out, maybe a bourbon, I made the radical and countercultural decision to simply pass actions in A to every single routine. Why? Because of symmetry. Everything looks the same if I pass actions and A. When I return to code months and years later, I relearn my code by rereading it. Given a stack of functions that do exactly the same thing, if half of them use one convention and half of them use another, then I now have twice the number of conventions to relearn later and only half the number of examples of each to relearn from. So I would not have done this when I was younger. I just chose verbose symmetry over asymmetric brevity, which would always have been my choice earlier in my career. As a reader, I need routines that behave the same to look the same if I have a chance of being able to maintain my own software. And so symmetry, it remained. I simply had all the routines follow the same API. All right, we're ready for a final design step. I talked earlier about widows and orphans, avoiding stranding the first or last paragraph of a line alone as a human with intelligence laying out type done for hundreds of years in Europe. How does that look in code? Well, my paragraph routine was a bit complicated because of widows and orphans. A paragraph had to lay itself out. If it stranded an orphan at the page bottom, it had to go back and try all over again, lay itself out. If it then stranded a widow at the top of the next page, had to try again. Inside of this if-else widow-orphan logic, paragraph had a hidden, simpler inner routine called repeatedly that did the actual paragraph layout, but you couldn't get to it. It was down at the bottom of all these ifs and elses. So what if you had wanted to just call it a simple paragraph layout routine? Well, I had to start adding Boolean options to the paragraph callable in order to turn on and off that outer level of if statements. But Boolean switches are often a hint that we have coupled what could actually be two different routines. Instead of stranding code inside of other code with a switch to turn it on and off, can you pull it out separately? Composition, when it's possible, is always to be preferred over coupling. And so, if a heading, it occurred to me, can control things about the paragraph that follows it, could I write an avoid widows and orphans routine that had no content of its own to offer to the page, but that simply controlled the next item, whatever it was, to help it avoid the problem of stranding lines? I thought through it. Avoiding an orphan, easy. Here on the left, a paragraph has stranded an orphan, its first line, at the bottom of a page. All we need to do, if a paragraph does that, is have this previous action go ahead and use up with white space the bottom of the first page, then let the paragraph lay out. It's very, very easy to bump an orphan to the next page and fix it. Before calling the paragraph, simply move to the next column. What about avoiding a widow? I tried to sketch out a solution and found it is nearly impossible. Why? Well, because a widow is created when the very last line of the paragraph falls onto a separate page. This means I have to lay out the paragraph all over again, and it's next to the last line, even though there's room for it in the column, needs to decide to move to the next page. How am I going in the middle of the paragraph making decisions to just convince it to not use the page like it's supposed to and move to the next column? How would we ever convince a paragraph to move to the next column early? I went and looked at the inside of the paragraph, and each time the paragraph needs another line, leading, the height, adds them together, compares them to the column height, and it's that trigger. I need so much space and it's not available, that convinces it to ask for another column. How could we influence this choice? Well, I could lie about the value of y. I could create a line object that I pass it that has a y that's a little bigger than it should be, so that the paragraph will run out of room early. But then I'll have to go and fix all the line objects it returns to be back up where they belong on the page. I could make a fake column object instead of the real column object that's a little shorter than normal, and thus force the routine to move to the next page early. We are looking desperately for parameters to tweak. Why? Because we're standing outside of the code that makes the decision. So all of the ideas I was thinking of were really bad ones. It was that feeling of using a framework you're not quite in control of. You're thinking of what parameter can I possibly set here that will make the paragraph behave like I want it. We're on the outside. Is that really where we want to be during our code's crucial decision? No. When code is making a crucial decision, you want to be in the room where it happens. The room where it happens. The room where it happens. I want to be in the room where it happens. Right now, the paragraph only consults us when it needs a whole new column, right? If it needs another page, another column, it calls the callback that we've provided. Well, what if I get this concept, which actually was repeated all through my code, of needing another line, comparing and seeing if I have enough room, and either returning a line in the same column, or if we run out of room, a line in the next column. What if I wrap that up as a callable? And so what if the paragraph calls back not only when it thinks it needs a next column? What if instead of only calling me back when it thinks it's ready for the next column, the paragraph calls back every time it needs a next line? What if I get that crucial if statement I need to control that's down in the paragraph's own code and bump it up into a callable that I pass in? Then the widow-orphan logic can subvert the paragraph's normal decision simply by passing a custom next line function. Right inside of avoid widows and orphans, I can just make a little wrapper and pass the wrapped version of next line to paragraph, and I'm in complete control of exactly the point at which it decides to go ask for the next column and moves to the top of that page. This design was a complete success and completely let me break out widow and orphan avoidance from paragraphs and turn it into a general routine, which can apply to bulleted lists, to tables, to all kinds of information that I might want to apply the same logic to. But did you catch why this approach is a success? Why was I able to do this sleight of hand? The fancy next line wrapper is so simple because we avoided premature object orientation. What if instead of just passing next line, we were passed a whole layout object and next line was merely a method? How would you make an already existing object's next line method return a different value because you wanted it to? Would you monkey patch it? Would you wrap it in an adapter class? Would you implement the entire gang of 4 decorator pattern? In object orientation, customizing a verb, one little verb, can require trundling out an entire design pattern to wrap the object. But if you pass callables, if you treat your verbs as first-class citizens, which is one of the strengths of Python, simple inline wrapper can put you in the room where it happens. I've learned over the years in my designs to start verbose, and don't be afraid of that, and to simplify and collapse things down later. I have come, despite myself, to value symmetry over special cases, to avoid premature object orientation, and to let verbs be first-class citizens. Attach them to nouns only if there's a compelling reason, like dynamic dispatch. I plan, if you want to look at some of this code, parts of it work, on releasing my typesetting Python library later this summer, but you can already watch my progress on GitHub. Among other things, it laid out this entire presentation, which is a PDF. And so to conclude, what was that book that I showed you a picture of earlier? That is my grandfather's memoirs. The story, the family history going back to the 1820s, his opinions on religion and politics and death, all bound together in a hardback book. Sure Print and Design in Toronto, Canada, will print runs of as little as 2 books. I wanted to hold it in my hand and proofread it and have a copy to give my father. So we got anything we needed to fixed before we handed it to other family members. It'll be a great gift at people's birthday, I hope, and Christmas. My grandfather's just the little essays he'd written and printed off on printer paper and handed to family over the years, when put all in one place, ran to 328 hardcover pages. We had no idea it amounted to that much material. And so I was able recently to surprise my father. I had not told him about this project by giving him a professionally printed hardback of his own father's writings. That looked like a professionally typeset book, even though, as I admitted to him, it was really typeset with Python. Thank you very much.
Thank you very much, Milton. Okay, we have a few minutes for questions now.
Let's see, I'm looking back on the group chat. If you want to disagree with me on typesetting.
I'm delighted to. Thank you very much for this talk.
Brandon, you have the stand. I don't know if there's any questions coming up on the chat yet, but you.
In the chat, I saw several interesting links that I'll follow up on. Thank you to those who sent those. And yes, that talk obviously was intended for programmers. And I'm not sure, I'll make the statement that I'm not sure I made it entirely clear, so I'll reiterate. Something that always annoyed me about TeX as a typesetting engine is that it first breaks a paragraph into lines, then figures out which page that lands on, which means that 2 subsequent pages can't have different column widths, as like some print magazine, like the New Yorker or whatever, might have a wide column on one page and then a pair of columns on the next. And a big motivation was I wanted to see if, rather than TeX approach, split the paragraph into lines. I'm done. I now have some lines. Let's put them on page A or B, well, page 1 or 2. I wanted to see whether those 2 activities of allocating new lines and breaking a paragraph could take place simultaneously. The answer is yes, but of course you can't use TeX if you're doing that. I'm not seeing any questions. Could someone reiterate or go ahead and ask if there were any questions?
Are there any questions from the audience?
Frank, go first.
Oh, Frank goes first. It wouldn't be a question. It was more like, well, you look at the screen, so look at the screen. It isn't a question, it's more of a comment. I think you did exactly the second step compared to what Don was doing. He was trying to minimize the problem and go with the traditional way of typesetting. They those guys were doing exactly the same one, basically making galleys. And it was a question, I would say, on, well, basically what the available computing power was there. I mean, he had in the time tried to do something bigger and said that that's just not right. And so you went exactly in the right direction, but it goes, I think, a huge step further, because you're not just interacting between paragraphing and page breaking, you're interacting within the whole document in some sense. Because your problem with the widow is typically, if you want to solve it, is solving it a couple of pages earlier, not to end up with a widow.
Yes, thank you for that comment. And it's just embarrassing how much memory we have these days. We don't even have to be careful really most of the time, now that Game of Thrones can fit in computers' memories and so forth. I will say, to follow up to your comment, that often you want to just plan ahead a few pages earlier. I was sort of startled after the talk that there at that conference in London, some actual people that do typesetting and were learning programming or fans of the programming language happened to be present. And I didn't know that these days, if you're having a problem with an awkward hyphenation or a widow or orphan, you just expand the font 0.5% in width. No one's eye ever catches it, and suddenly the widow or orphan is gone. And you can do that gradually, pages earlier. Ramp the font size up a little, ramp it down, which is another version of, I believe, Tech will space the lines out a little farther or shrink them to make what looks like a block of text by moving them slightly further apart. But they kind of thought the problem I had adopted of trying to get fixed width text and breaking it, they thought that was so quaint, because actual graphic designers these days, not dealing with fixed physical lead-based type, can do all kinds of minute cheats that eliminate the typographic problems.
Absolutely, but the point is they're doing it manually on their design.
Yes.
So what we are looking for, and I think what you are looking for, is a programmatic solution to the problem, at least 90% of the time, and not going from page to page to decide what is best for that particular page to fix a certain hyphenation or something. This is why I put you the link into the research results that I presented at the ACM 2 years ago, which is basically solving that on a global level with tech, or rather with Lua tech, basically.
Yes, that's true. They are having to do it manually and InDesign or something like that. And the goal here, of course, would be to have an algorithm govern it and, exactly as you say, solve the majority of cases without interventions. To answer two questions that just came in reverse order. At the moment, I haven't sat down and written something to handle paragraphs that have a too short last line, you know, that end in ly or something following a dash. I haven't sat down and written that yet, but the data structures have no limit in the way. It would just need to be authored. I also was asked, do you imagine that you might apply something like this to the breaking of math formulas? And I have, so I guess I've just never dealt with terribly huge math formulas. Typically, if I have even a 3 or 4 line formula, I don't break it across pages. I just will move the whole thing to the subsequent page, rather than try to decide if mid-formula I can make a break. But there would be no obstacle to doing so if you returned the math formula set as lines and set the same algorithm or routine to work. Though for that case, with paragraphs, all paragraphs are kind of semantically the same. You don't want widows, you don't want orphans, and they have that symmetry. With math formulas, there can be good and bad lines to break. Maybe 2 lines really need to be together, but the third one can move without a problem. So to do that, you would probably want to implement something, use penalties, vertical penalties of the same sort that that tech has for saying, this is a pretty bad break. You can do it if you have to. This is a really bad break. Don't split this between 2 pages. And so your formula would need to be annotated like that. Thanks for the questions, everyone.
There's a couple more. If you take a quick shot at it, Patrick is running.
Can I ask a Python question at a tech conference?
I don't know if that's allowed. Moderator, do we have a decision?
I think it's allowed. Well, yeah, but it's allowed. The question is this. Well, it comes back because I've been recently starting to understand coroutines and async in Python. I don't understand them, but I understand them a bit better than I did before. And the question is, would this help manage the logic of what you're doing? And the reason I ask that is that Take the Program has this massive case statement that is the center of the main loop. And it sort of reminded me of the dispatcher you have when you do asynchronous programming. You know, so-and-so gets so far, and then it says, oh, I'm stuck now, so I'll go up to the top, and control will be passed over to somewhere else until they get stuck. And asynchronous programming, I learned, is a way of, an alternative to asynchronous programming is structured programming with go-tos for some problems.
For exactly that reason, I have always found asynchronicity to be something I avoid until everything else has failed, because when actions trigger other actions that then go and run and trigger other actions, I tend to lose control of my program and its performance fairly quickly. So my desire in this case is to see if everything you could want to do could be done through layers. So you have little routines that help the paragraphs not leave widows and orphans. Then the next level up, I guess I need to write a footnote manager that lays out footnotes and moves you to the next page when they fill the bottom of the column. And my hope would be to use sensible layering and structuring and not have to result to the free-for-all of asynchronous event firing, because I find that generally you can then get loops of events that trigger each other. It can go forever if no way of laying out the paragraph. And so I try to use loops and iteration instead.
Can I make a quick comeback on this, which is Don Knuth was really concerned to get acceptable performance from unacceptable hardware, and he made great efforts to optimize everything he could reasonably optimize. So maybe we were both right.
He even optimized things unreasonably, but very successfully in some cases, because he was Donald Knuth, yes. Do we have other questions still unanswered?
Well, one of the questions we have is from the speaker, which is right behind you, I mean, right after you.
Oh, I see what you mean.
So you probably could take and delay him a couple of minutes. And he's asking if you could examine rivers and white spaces in the code.
Oh, I think I saw that flash pass. I'm sorry for forgetting about it. Yes, you could examine them, because the data structure you get back, the linked list of lines, has all of the graphic objects attached through simple subtraction. Subtract their width from their offsets. You could find out where the gaps were and have a routine that looked for successive areas of white space. I am not sure what the intelligence would be like that tries to go in and correct that. What kind of tweaks would you make? Because that's not something I've not done that kind of typesetting before. But the data structures are fully mutable, and you can go back in and bump things to the left and right, or even, I guess you couldn't automatically adjust wording, though that's a famous way for authors to get rid of rivers of text. And whether or not you had an automated way to fix it, you could stop and tell yourself as an author, hey, there's a big river of white space here. you need to go look at the document again and see if this is a problem.
And then the final question is, do you handle paragraphs that have too short last lines?
I don't yet. I haven't yet written logic for that. Just getting the widows and orphans working was as much as I was able to get done before that talk.
Well, thank you very much for a beautiful talk.
And thank you for the invitation to come. And if only this had been an in-person conference and I could have, but very, very happy to see another audience get to hear the talk, though of course it was a little more programming language centric than most of your material. I look forward to enjoying the rest of your conference. Thank you very much.
Thank you. The next talk is Patrick Ion, and he's going to talk about global math. Patrick, are you there with us? Let's see. He was here. Yeah, he's probably in the attendees list. Yes. Patrick, you've been promoted to a panelist now.
All right. Now I can talk.
Thank you.
I assume you can hear me at the moment.
Very well.
All right. Just a moment. Just a moment. Unfortunately, I heard the last talk, which was really very nice indeed and beautifully didactic. I'm afraid that's not what this will be. I'm making some remarks about tech and global mathematics and the like, but I think I'm here partly because I'm one of the old timers. I'll try and justify a few of my opinions. The opinions I have are my own and not to be assumed to be necessarily the opinions of any group with which I claim to be associated, such as the Global Digital Math Library Working Group, or the International Math Knowledge Trust, or the University of Michigan. But anyway, I put up an abstract, which you may have read, but it mentioned mathematics and tech and MathML, another markup for math, GDML, IMKT, and I'll explain a little about what my views on these things are supposed to be, and what I think you might want to do. Okay, so let's start with the point that math is a natural language spoken by a globally distributed tribe rather than by a particular nation, but one that has some significance in culture because science is influential in most countries these days. It's as such a language, it's not as well supported as many of the 180 or others, others that were mentioned by Steve Matteson, not as supported in terms of fonts, for instance. It can be done down as not a language, but a jargon, just the technical terminology of a special activity or group. But I think it's widely agreed to be a fairly important one. It can also be done down as an artificial language, which is intending to discuss the patterns in nature and to make judgments about what patterns are possible and the possible relations of ways of thinking about nature. It can also be thought of as sort of persigraphy, since it has a whole lot of special symbols which are supposed to have special meanings. And the idea of psigraphy is that you set up a language and with a set of symbols which allows for calculation of the argumentation in that language. And back in 1898, at the International Congress of Mathematicians, that was a word of the moment. And the mathematicians at the time were sure that the matter of psigraphy would be discussed at every subsequent Congress. 1898 was the first. This turned out to be completely untrue. But math has been around for a long time, 2,000 to 4,000 years, say, for sorts of mathematics that we're used to. Or, you know, if you want, 30 to 40,000 years. There's the Ishango bone with some marks on it from the Congo, which can be thought of as an early mathematical document if you argue right. Cuneiform math. And apparently Steve Matheson tells us that the Notofu alphabet or Noto alphabet, fonts, includes a cuneiform. So maybe we'll be able to typeset that nicely sometime soon. Okay, so mathematics is involved. Tech was developed for mathematics by Don Knuth with many followers and collaborators for communicating mathematics, i.e. for writing formulas, because back when he wanted to, this of course is, I should say, and it's also obvious, a sort of potted history of things that is supposed to have elements of truth and to suggest things, but obviously in detail is not quite right. Anyway, a little bit of obfuscation saves a lot of explaining sometimes. Anyway, it was developed for communicating mathematics, writing formulas, because he was dissatisfied with the expected results of his revision and correction of volume 2 of the Art of Computer Programming in about 1977, perhaps even 76. And he decided, as the story goes, indeed as he says it, that he should be able to do better with new computer typesetting material, and he did. Tech, which we all know about, became pervasive in scientific publishing. And in multilingual publishing, it turned out too. And that actually, from the look of this year's TUG, would seem to be a much more important thing than the mathematics. Mathematics is merely one language that tech can be used to produce print and other communicating output. Indeed, it seems to me mathematics gets a bit short shrift. This is TUG2020, so presumably we have the view of the benefit of 2020 hindsight. And maybe tech isn't really about mathematics terribly much at all. It's about much wider communication. However, the advent of tech much expanded the community directly writing mathematics to what it is today. And it's now 40 years or so since the start of this era. I'll make some illustrations from my own experience, but I'll go relatively quickly over that, as I will have to over everything. MathML, a math markup language, was not developed by a single person. So as they say, it's the difference between a camel and a racehorse. Some things seem to be developed by committees and have design problems. Well, this one's distinctly developed by a committee within the World Wide Web Consortium. It was concerned with the web from about 1997 on. Became a World Wide Web standard, the W3 standard in 1998, one of the first, essentially, the second XML standard that was out of the gate. It's been part of the official HTML, hypertext markup language standard for the web since 2015, when they HTML for documents in general ceded the math formulas to math and the vector graphics to SVG, scalable vector graphics. A third edition of MathML standard became an ISO standard in 2016. MathML's spreading in its usefulness, or its deployment anyway, in part over accessibility or as a result of concerns for accessibility. And it fits very well with XML publishing, and it's now 20 years on since those early days. And then the other item is the Global Digital Maths Library and International Math Knowledge Trust. The Global Digital Maths Library is a notion that was endorsed by the International Mathematical Union in 2006. And the working group was formed in Seoul in 2014 at the International Congress of Mathematicians. And that working group set up a knowledge trust in Waterloo, that's Waterloo in Canada, in 2016. And it's 5 years on from that. What's happened? Well, not terribly much, but something of importance anyway. My experience with all this is that I was an associate editor of Math Reviews from 1980. And so I've seen a lot of maths papers, probably about 200,000. And I came to that from Heidelberg and Kyoto and Netherlands and Bedford College in London. So I'd been there around a long time. And how did I get into tech? Well, quantum stochastic processes was the subject of my interest at the time, mathematical subject of my interest. And I was working on a paper with co-authors in Nottingham in India, and quantum stochastic process equations use lots of tensor product signs. I mean, there is the resulting paper with tensor product signs all over the place and lots of other stuff. So the point was that when I arrived in the US, again, in 1980, I went on for joint maths meetings in San Francisco, and tech was being presented by Knut and Mike Spivak of Amstec fame, and tech could do special symbols, the O times of the tensor product. The AMS, on which Mathematical Reviews was a division, or it wasn't exactly a division at the time, it is now. But anyway, it was part of the AMS was Math Reviews, and it had tech. And they had a machine, DEC 2020, actually upgraded 2060 later, running TOPS 20 in Providence, Rhode Island, as opposed to Ann Arbor, Michigan, where Math Reviews is, with 300 baud phone access. But you could get proof pages off a local Florida data 24-pin printer. I'm sort of illustrating the details that are implicit in all of this activity, which are complicated. And as a matter of fact, that's probably somewhat unnecessary to point out, in the sense that every talk so far, or almost every talk so far that I've been able to catch, has really shown that there's an enormous amount of detail, say, behind all the PDF considerations as discussed by Ross Moore and Tom Price and others, and behind other considerations. So anyway, back then I was tooling up already in Heidelberg as I was leaving to do some numerical stuff after 15 years of not having done computing. Because a long time ago, I'd actually been interested in computers and been associated, worked over LGP30 and the Datatron and various other things. There's the Royal McBee LGP30 from way back when. Anyway, I found out that TeX was written in Sail, the Stanford Artificial Intelligence language, that the similarly acronymed LAB provided reports to the University of Michigan, amongst which was the language manual. It was an extension of Algol 60, which I'd met before, and I got hooked on getting the stuff working. So AMS was supporting TeX development and encouraging internal use, and really trying to realize what was termed Richard Paley's dream. Now, Richard Paley was the president of the American Mathematical Society, and also one of the reasons that the AMS bought DEC computers, which is another aspect of things. But his dream was that mathematicians at last would be able to directly author their own papers, which would mean that they'd avoid those nasty errors that secretarial help transcribing their ill-written manuscripts produced. And these were, of course, then further compounded by mathematically ignorant editors or copy editors at the publisher's house. So if only the mathematicians could directly author their stuff, things would be so much better. And they would be able to do this using this wonderful new TeX system that a mathematician of the first rank had invented for his own use, and it was clearly a good thing. Paley did not take into account other aspects of changing over the style of producing mathematical documents, or trying to make this into a whole ecosystem. There are some costs. But Math Review's production was moving to be TeX-based. Many were involved. Barbara Beaton, doyenne of TeX here, and many other TeX members, and a lot of work went into it at MR, Math Reviews. We did a header for the MR issue. I was very much involved in that in 1984-85. Now, each issue was several hundred pages and had special formatting rules of some complexity. But there is, in fact, an example given in the TeX book itself of how to deal with one of those formatting rules. And with a fair amount of effort, we had the January 1985 issue of Math Reviews on the newsstands on time. What was amusing to me personally was that the final copy was produced on an alpha-type photo printer in Providence, in Rhode Island, and it was produced with 6-up copies of the oversized Math Reviews pages, which were then sent back to Ann Arbor to the actual physical printer, who magnified the pages that were typeset and then printed them. I was amused by the fact that modulo 6 arithmetic could be used to tell when the pages had to be changed. But anyway, roughly, Knuth wants corrections. There was uptake immediately. In May, he had 10 users with his first prototype, apparently 100 in June, 1,000 in July. But it was 5 years later that there was a public release. However, in the interim, of course, as we know, he had changed from this Algol language to an extension form of Pascal. Well, actually, he'd invented web programming, which was the literate programming form, which can be discussed too, but not at the moment, and developed all sorts of ancillary and needed infrastructure, metaphons and so on. So that, and also written, I think, the tech book by that time, and possibly the first volume of Tech the Program books. Eventually, Don Knuth wrote, I think it is 9 volumes as a result of his detour into this typesetting, in addition to his art of computer programming being continued. Anyway, in 1985, Math Reviews and AMS Publishing were using TeX. That's quite a big change and influences a lot the world of mathematics. How mathematics is being, so to speak, produced. I mean, we're getting towards today, but as we know, computers, personal computers were arranged, PC tech on computers. There were firms such as Arbortext set up. Ginsparg, Paul Ginsparg's archive for preprints had a great deal of tech in it, though much of it was high energy physics. But ever increasing quantities of mathematical preprints were on that. There was discussion of all this in 1995 at MSRI in Berkeley, Electronic Communications and Mathematics, and people were very conscious of the fact that math could be done this way. Tech was becoming a lingua franca for mathematics. Also at 1994, Jim Gosling was announcing this programming language, Oak, which turned out to be Java. All right. So not going into the, they said, let's bring in MathML. MathML, what was that? That's a math markup language developed by a working group within the World Wide Web Consortium. And as I said, it was a standard as of 1998. That's what I said before. I wanted to go back and say that from about 1995, the World Wide Web Consortium, led by Berners-Lee, generally recognized as founder of these things, or was a consortium full of working groups which worked by consensus to produce recommendations as opposed to standards, but in fact they were just standards. There weren't any standards for markup of math formulas, but there was talk about markup of math formulas. In fact, there was a book by Dave Raggett in which MathML was described, but long before it was in fact run together at all. So a math working group was set up in 1997, and those who had ways of mathematical markup already available or were otherwise concerned were represented. For instance, IBM already had Scratchpad, which would have done for markup of mathematics, you know, the type theory and so on. Mathematica had its list-oriented and list and keyword-oriented markup of mathematics, which was obviously working for their computer algebra system. And they had the idea at the time that operator precedence parsing would be the answer for a mathematics markup language. Maple had this. The tech community, which of course was not a single thing, even if the program was by definition the center of it all, also had a way of dealing with any sorts of mathematics. Well, at least of finding a way to typeset it. Elsevier, the giant publisher, was involved, Microsoft, and the American Mathematical Society, who obviously were concerned about such things, and I was from that. I mean, the MathML could attack a couple of things that tech couldn't really do. Pre and subscripts and pre-super and subscripts, or certain national elementary long division styles. The French and German styles are different from, say, the UK style or the American style. And setting such more complicated things up is not so easy. There were problems also with maths in left to right or right to left typesetting or vertically. Apparently, Mongolian and sometimes sets formulas with vertically. And Matheson was remarking that Mongolian alphabets were apparently difficult to arrange fonts for. Then there are lots of things like that. Anyway, the working group continued to work. It had distinguished the presentational aspect of formulas in mathematics from the so-called content aspect. The meaning, the sign, the glyph for a plus sign is a glyph. It's attached or associated with a meaning, and the meaning of something involving addition, an infix operator between two things which should be added, typically. But that's not a unique, even in mathematics, that's not a unique meaning. There are lots of different forms of addition. And that's mutatis mutandis true of all the other signs which are commonly thought of as mathematical symbols. And that's also true of certain strings of letters, like, for instance, the names of the trigonometric functions, which are normally written out as sine and cosine, sin and cos. These are meaning, mathematical meaning holders, and a system of MathML elements was devised to represent the content, the semantic part of things for, well, mathematics up to perhaps the second year of American colleges. This is different from being able to arrange symbols in the more than one-dimensional typesetting style of mathematics, which is just presentation part. Anyway, the working group continued to about 2018. Co-chairs Robert Miner, who's unfortunately died some years ago, and myself and Angel Diaz, who's from IBM, and then in recent years, David Carlisle, whom many here know and respect. Now, there's also something else in there. That obviously there's interaction with Unicode, in the sense that there are thousands of potentially significant mathematical symbols, and they had to get added to Unicode in order that they occur in fonts. And that happened especially due to the agency of Murray Sargent of Microsoft, ultimately in version 6 of Unicode and so on. Barbara Beaton was very helpful in that respect. The names for any of these things, well, that's something that goes back to tech names. And there's a standard for XML character entity names currently administered by David Carlisle. That sort of thing that's all part of math markup. Okay, MathML use is spreading. It's in part driven by accessibility. People want to arrange that things are accessible, and there's semantic markup is very much a byword these days. It fits with XML publishing. It used to be XML based, but that's something that's gone by the wayside. And it was and is being rewritten to harmonize with newer web technologies, which has been developed since the early days when you saw it started. Our spec was one of the earliest out of the gate. And some of these things with which it's supposed to accord just hadn't been invented at the time. They also didn't solve the problems that we also had identified, which is also a pity. Also, browser manufacturer attention was a problem. For instance, in 2014, the Chrome group decided there was potentially a security issue and dropped support for MathML. I think this was a put-up job myself, but anyway. We're now about 20 years on, as opposed to 40 for tech. And we haven't quit. There's a MathML Refresh community group with chair from Neil Cypher, who's comes from particularly the accessibility side, though in fact he was the first author of the Mathematica user interface insofar as mathematical formulas was concerned. And this group is splitting off a core piece of specification, which will be easier for implementers to understand and implement from any revision MathML 4. And it's considering additional markup options to carry semantics. All right, so very quickly, and I'll flash things by, a global digital maths library. Yeah, global, digital, using current technology, math, library, a knowledge repository, worldwide information system for digitally organized mathematics, wisdom, a web service, perhaps, that's a Wikipedia. So people have thought of having universal libraries for things for a long time. Leibniz and his reasoning calculus, which is why he was into binary numbers, Pasigraphy, which I mentioned before in 1897, sorry. A comprehensive bibliography was available. The Mundaneum, which prefigured in some sense the web, would have done for that. That's more about general knowledge, but it was supposed to include mathematics. And Vannevar Bush imagined Memex in 1945. What's amusing to me is that Claude Shannon, the graduate student, apparently worked for Vannevar Bush is how you're supposed to pronounce it. Yeah, I mean, there was a big card index, and there were all the electric telescopes with which people were going to consult this card index from remote things. And that's the post-World War II wreckage. That's a picture of Memex, which looks a bit like the Florida data. But it was supposed to be running with microfilm inside there and so on. All right, so a World Digital Maths Library is a good idea. it's been thought of as a good idea for years. 2000 people have made a call to mathematicians to make publications electronically available. This, of course, is a call to many of them to publish their tech. There are large digitization projects in the 2000s too, some of which actually include optical character recognition and possible reconstruction of formulas from tech, though that into tech encoding, but that turns out to be fairly difficult. In 2006, they're talking about a digital maths library, vision for the future, and the International Mathematical Union resolves that that would be a very good thing. There's a European digital maths library, starts in 2010, and in that sort of time, people are doing various things that work towards this sort of thing. At the Seoul International Congress in 2014, a global digital math library working group is created. At the inception, there's an Austrian, namely Buchberger of Gröbner Analysis, a Canadian, a Frenchman, 2 Germans, and 3 from the US, well, one of whom was me. And it becomes officially a working group of the International Mathematical Union with the mission of constructing as a global public good an open knowledge base encompassing the results of the world's mathematics, etc. That you can read. It's a fine idea. You can break it down into goals, which are fine ideas. And you can start talking about all the things that it might be. I mean, how big is it going to be? It could be math reviews and Centralblatt for Mathematics plus the software math database plus the database of, the hub of mathematical databases. You have a lot of trouble getting through these things. All of these things implicitly involve the tech community and the tech community's concerns. Again and again, I'm flashing things by. I'm trying not to go more than a minute or two further on. The formulas matter is where we have details of tech and MathML, but how you deal with that is partly covered by tech, but partly the fact that tech is there allowed all these questions to be become clear. The ignoring classification and ontology, these big proofs were math papers which actually were authored in tech. The communication of mathematics has changed so much as a result of tech. By 2016, people were talking about math information, digital data science, and of course, what? Okay. And trying to work out extra information about semantic representation. In Rosmer's discussions, he keeps talking about semantics, and the semantics that he has is the semantics of various page or document divisions. But here we're interested in the semantics within a particular scientific field, or in this case, mathematics. And it's not quite the same thing, but it can be treated, much of it, similarly. I will go through this until 2020. Again, we're still talking about it all. And of course, we have the pandemic that causes us to be located where we are these days ourselves. Furthermore, things have changed because one of the not mathematical reviews, but Zentralblatt Mathematics, which is, or ZBMath, which is the German precursor of math reviews and also competitor, though rather smaller these days, is going to become an open resource next year. The transition towards an open information platform for mathematics is discussed in the European Math Society newsletter. Now, Math Reviews and ZBMath both are tech shops. It's the fact that tech could work the way it does that has allowed this to happen. The International Math Knowledge Trust, as I said, was an organization that has been set up to help realize this. There it is. There's a board membership and so on. I'm trying to stop. But the main point is that in order to get as a public good an open knowledge base encompassing the world's mathematics, you're totally dependent upon tech. Tech is these days probably the best input language for mathematics, in spite of its being initially envisaged by Don Knuth to be something for him and his secretary. A lot of us talk tech. A lot of tech is tech encoding is passed around. MathML, a pointy bracket World Wide Web type encoding of everything, document and formulas included, in terms of rooted labeled planar trees, is not an encoding or an input style. Sorry, it's not an input style that humans can use. It's, however, supposed to be and is an underlying markup which will carry a lot of the various semantic types of semantics that are needed in order to produce good documents or to produce communication between, let's say, computer algebra systems and documents, or to relate to proof systems and so on. The result is that though what you want is that the scientific record should be free of financial barriers and such like wonderful things, we aren't there yet. Tech has got us a lot closer to it. And if you want to have a global digital maths library, you have to find some way of getting the resources. You have to find yeah, you have to organize people. But actually, I think that it is the change of tech that tech brought about in the way the mathematical literature is produced, which has made a good number of these things possibilities. There are some relevant aphorisms, but the last one is probably the one that's of importance here. The medium may not be the message, though McLuhan suggested it was, but it certainly does help it, as the philosopher Wolff says. The language, the way you can the language in which you can express notions conditions the notions you can express. Tech has made a big change in that regard. That's about what I should say.
Thanks a lot. Quite fascinating.
Thank you very, very much, Patrick. What a wonderful review.
Well, now if I can put tooltips with Ross's technology on the slides, it might be useful otherwise.
We'll repost it. I mean, if you get, I'll tell you, it's a tall order, but because
tell me how to do, Ross. Tell me how to do the tooltips. I was actually thinking of writing you
yes,
a message about that.
Sure, and I haven't really
3 weeks ago.
Right. I mean, I'm perfectly set up to do that. But PDF Tooltip works very well, and that's what I've used for other things. And I even know how to tag them and that kind of stuff. I haven't put them into Beamer slides, right? That's one of the. I was thinking about how the structure of a Beamer slide and all the different views that you get as you build a page up, like I was doing in my lectures.
Right.
That is essentially the tagging. Each one of those things should be tagged separately, but then to have a tooltip over the top of a picture, well, I don't see why there's any difficulty with that. So I'll give it a try and I'll get back to you.
All right. Walker's law looked fine. I actually did do something with PDF comment, but it didn't work, and it wasn't going to work in every PDF viewer. I established I could get some things, but I couldn't control it.
Yeah.
But that's an example of what tech changes.
Yes. Actually, a couple of years ago for CICM, which happens to be on starting this evening, for me this evening,
right.
So Monday evening and all week, a few years back, I did a means of doing multiple tooltips over the same mathematical expression. So yeah, I mean, that's work I certainly want to get back to.
Well, thank you very, very much. I'd like to announce that there is a group of people gathering at GatherTown TUG 2020. The link and the password is on the top of the schedule, and we adjourn for a few minutes, and we'll be back for Bill Heyman with SGML for technicians, and then later John McFarland with PanDoc for technicians.
Thank you. Thanks for your attention.
This is a sound check. Thank you.
Hi, Bill.
Hi, Paulo.
Can you hear me, Bill?
I can hear you. Can you hear me? Paulo, you didn't answer. Can you hear me?
Yes.
Well, I can.
So
others can.
Hi, Patrick.
Hi, Bill.
So let's get started with the last segment. Would like to bring you right now William Heyman, and to talk about SGML and its importance for the LaTeX community.
Technical question, Paulo. I
Yes.
noticed some of the talks while the screen was shared on Zoom, there was nonetheless a small window with the speaker. Is that the standard setup now, or when I do a screen share, am I going to be invisible?
That is a choice of the viewer.
Of the viewer. Okay. All right, so I'm going to start screen share.
Yeah.
And I'm going to make this bigger. Okay, so it's actually why the LaTeX community. Tech doesn't care about anything, but, and I'm making a distinction between TeX and LaTeX because I perceive TeX is a low-level typesetting engine, and I perceive LaTeX is a semi-structured typesetting engine, or, well, whether it's an engine or a markup, be that as it may. I've got a strange square on my screen.
Are you sharing part? No.
Okay, I think I know what that's about. I'm going to stop the share.
Okay.
I'm going to stop the share and restart it.
Right.
I think I know.
We are seeing
I think the reason that happened is that Zoom was not in full screen mode when I started the share. And then I popped the share to full screen. Zoom is not bulletproof.
Oh, no.
I'm sorry. What happened there? I didn't mean that. Okay. Okay, now I'm going to put Zoom in full screen. And, oh, but now, because Zoom is in full screen, oh yeah, okay, I can still do share. There.
Okay.
No, yes?
Yes, yes.
Yes, yes.
And now?
You can make your slide fill the screen if you want. Yes.
Okay,
Yep.
is this good?
Good.
Yep, and no green rectangle. Well, very well done.
Okay. Okay, so the abstract was available ahead of time. By the way, does anybody have an idea what format they're looking at here?
I won't tell.
Well, I guess STML.
You see the typesetting of LaTeX? That can be done in HTML these days, and yes, this is HTML. You can, the paragraphs are not right justified, and there's no hyphenation. Okay. The idea, of course, is that we spend a lot of time when we write, and we want to protect the investment we make in writing our documents. So we should use the best source possible. We want those documents to be maximally useful, especially when we're in this current environment teaching online. So paper is of relatively little use these days, but even when we're not confined to online teaching, at least in some countries, and we want to traffic both with paper and with online formats. We don't want to wind up doing re-edits for different presentations of our documents. And by documents, I'm including course materials, research articles, various things. So our source document should admit robust translation to whatever outputs we are interested in. Of course, it's our problem to make arrangements for translations to the formats that we want to reach. My point is that we want the source that we write to have enough power to be able to reach whatever we need to reach, or might in the future want to reach, ideally. That might not always be something we can fully anticipate. And so the idea that I've been playing with since 1998 is well, I didn't coin the term LaTeX profile in 1998, but the basic idea is to use a LaTeX profile. I talked about LaTeX profiles at TUG2010, and there's a Tugboat article that I think is available to the world for free now. A LaTeX profile is a dialect of LaTeX with a fixed command vocabulary where all macro expansions must be effective in that vocabulary. It is a language essentially equivalent to an HTML document type with a canonical XML shadow. All of this was discussed in my talk at TUG 2010. And at TUG 2014, TUG 2010 held in San Francisco to celebrate the, well, that's not 100,000, that's 32 written in base 2. The 32nd anniversary of TUG. I think it was the 31st annual meeting of TUG. Probably the 32nd anniversary of TEC, actually. I'm not sure whether it's the anniversary of TEC or of TUG. And XML 2014 was held in Portland. At that meeting, I talked about the fact that the XML guise of a LaTeX profile can be styled with CSS for online presentation. This was added after I heard Ross Moore's first talk, and the remark simply is that the HTML5 coming out of a LaTeX profile, I say should be maximally accessible. That doesn't mean in a particular instance that it is maximally accessible, but it can be fairly easily made to be maximally accessible. Why SGML rather than XML? The simple answer is that SGML provides a better emulation of classical LaTeX. The example I'm going to use for this is this simple table, 2 rows, 3 cells. The alignment argument is right, center, right. No particular reason for that choice. And it's boxed. That is, it has 3 H lines and there are boundaries for each of the cells. And the 2 ways early on when I was developing Gelmo, that's this name here, which is my benchmark for the concept of LaTeX profile. And I wanted to make that table, I would use this style of markup, which is pretty much like an HTML table. Of course, I'm writing it in generalized LaTeX, so I'm using LaTeX-like notation. But this is the idea in generalized LaTeX is that you're actually creating an SGML document, and the SGML document has a canonical XML shadow, but this particular markup resolves pretty quickly to XML without having to observe the distinction between SGML and XML. XML, well, all right. So, but the more traditional way of creating that table is to use a LaTeX tabular environment, and this is literally the same markup. This display, think of display as being LaTeX center. And this is literally what one might use for that tabular environment, for that table as a tabular environment in LaTeX. Notice that there's no explicit introduction for the first row. I mean, the first row just appears. This double backslash can be thought of. I mean, I've always thought of it as a beginning user. I thought of this as the end of row markup, but by the way, there's no markup for the end of the last row. So actually, it's the beginning of a row. It's markup for the beginning of a row. Anyway, the XML, I could show you the SGML that it immediately resolves to, but the XML that you wind up is somewhat more complicated than the simple HTML table type XML. And the reason for this has to do with the looseness that's available with SGML compared to XML. With XML, everything has to be fully tagged. Every element needs a start tag and an end tag. With more general SGML, depending on the document type definition, some elements, and in fact in original HTML, which was brought up as SGML, there were many elements that did not require end tags. I guess all of them. Well, for example, all right, the root element, which had the name HTML. In original HTML, the root element never required either a beginning, a start tag, nor an end tag. Many of the elements in original HTML did not require end tags. Of course, for that to work, it had to be possible to infer the end tag from context. So how is SGML looser than XML? And the fact that it is looser than XML means that we can model LaTeX more closely with, if we can use not all of SGML, but a part of SGML that is looser than XML. Like XML, SGML is a grammar for markup languages. It has stricter rules. XML officially is its own thing, but a mathematician's way of saying it is that an XML document is canonically isomorphic to an SGML document. And you can think of XML as a fully faithful subcategory of SGML. XML requires less infrastructure than full SGML. An SGML document must always include or reference a formal document type definition. XML documents, on the other hand, can stand alone and don't always need to reference a formal document type definition. For example, you can make up your own XML document type and write a style sheet for displaying it in a web browser, and then you can serve the XML document with that style sheet linked to it using an XML link, and that'll render perfectly well in a browser. For other purposes, that might not be so great, but an XML document can stand alone. I view XML as SGML dumbed down for use across the web. What has happened is that SGML is no longer seen in public. You see SGML behind closed doors in shops, whether they're university departments or corporation projects. The OpenSP library, to my knowledge, was the most important processing tool for handling SGML from not the earliest days of SGML, but for certainly for the last 10 years before XML sort of took over what was happening in public. OpenSP is a C++, OpenSP is a C++ library for parsing and transforming SGML documents. You can, by the way, use it with XML because, as I said, XML is a subcategory of XML. So every XML document can, in a canonical way, be viewed as an SGML document. OpenSP was spawned from James Clark's SP And before XML came along, James Clark's SP, in my view, was dominant for doing work with SGML. I said before, OpenSP can be used with XML documents. XML libraries, of which there are a number, can only be used with SGML documents after the SGML documents have been transformed to XML. Most SGML documents, well, yeah, most things that are in a technical sense SGML documents, if they correspond to what we call documents in the real world, then they can be transformed to XML documents in a canonical way. In the old days of SGML, there was something called normalization, where I don't want to say more about that. In the old days, there was something called normalization, and transforming an SGML document to an XML document is pretty much the same thing as normalization in the old days. SGML may be losing users. It's hard to know. SGML was banned for public use with the dawn of XML. So it's not seen very much in public anymore. There's a somewhat steeper learning curve with SGML. For example, typically, well, we all know that XML uses pointy brackets for markup. SGML likewise can use pointy brackets for the markup, but for example, one can also make an SGML document look like a Lisp program. I'm not going to say any more about that. But anyway, there is a sense, I mean, there's not so much publicly available new software coming out. And so there is this sense that SGML may be losing users. We don't know what happens behind closed doors. And then I say, but. The things that I know that I didn't want to put in writing, there is at least some use of SGML going on behind the scenes. I think there are probably between 6 and a dozen people at this meeting that I am pretty sure were involved with SGML at one point in their careers before XML came along, and I have no idea whether they're using it anymore. What really caused me to hatch the idea for this talk, well, I use my LaTeX profiling project on an almost daily basis. And so I'm using SGML on an almost daily basis. And I'm aware of the fact, and I have been aware of this fact for a long time, that OpenSP only supports the basic multilingual plane of Unicode. So those are U values from hexadecimal U values from 0000 to FFFF. As a mathematician, this is certainly a concern for me because there are a number of mathematical characters. For example, the so-called Blackboard bold letters. The Blackboard bold letters live at 15XXX in Unicode. Well, most of them do. That's another story. But adding full Unicode support to OpenSP might be a good master's thesis project. Of course, it's not something you would ask a master's student in mathematics to do. Those were the students that I had because I was in the math department. But anyway, I might hope that someone listening to this talk might think about and might know of a master or in the future. Okay, I want to say also, the talk that's following me is about PanDoc. Occasionally, I receive documents prepared outside of the tech community. I'm sure all of us do. And sometimes we have to deal with them and have a way of dealing with them. And in recent years, PanDoc has become something that I will haul out on such occasions. But I want to point out, PanDoc is supposed to be the Swiss Army knife of format conversions. The idea is you can transform from format A to format B without asking very many questions, just do it. It's not quite that easy, of course, but PanDoc has a central exchange format, as I understand it. I am not really very familiar with PanDoc, but as I understand it, there's a central exchange format. And for that reason, the power of one's original document, if one is using PanDoc, is limited both by one's own source format and by PanDoc's central exchange format. Whereas if one is using source that is HTML or XML and is then going to use HTML or XML transformations, the power of that source is limited only by the document type. And by power, in this context, one should understand the number of potential destination formats that are robustly reachable. That concludes my prepared remarks. What has happened to my Zoom?
You can end the share by just scrolling your mouse down.
Oh, I see.
Yes. And here we are. So there's a question on the Q&A. Open that up.
Q&A. I get no open questions on Q&A.
Oh, no.
On chat?
So Alan's hand is raised. So let me see what if he wants to.
That is a mistake.
The mistake? Okay.
That's what he said in chat.
How do you enter question?
I had an earlier mistake, but I have a question that Ross can answer.
Okay, the talk is for Bill Heyman right now. We'll have some opportunity to chat after.
Yes. The question that Ross can answer later is, are the various versions of PDF representable with an SGML DDT?
Wow, I mean that's for Bill too. You want to interject, Bill?
I don't know. especially when all this stuff, I'm almost totally ignorant about tagging PDFs. However, I can say something about DVI. DVI has the structure of a classical assembly language, and any classical assembly language can be uselessly represented as XML.
I'm going to stick my neck out here and say that no, I don't think you can represent PDF versions in HTML. And the reason is because although it's deprecated, you can stop and start feature assignments in PDF without regard to the boundaries of the text. And that's not allowed in HTML because you can't have overlapping tagging. But I stand to be corrected.
Well, for that matter, the full weight of HTML5 cannot be handled as either XML or HTML because HTML5 introduced this thing called the transparent content model, which I think, Peter, is what you were referring to.
Almost. I mean, HTML5 allows you to define anything anywhere. So it's basically useless as a definition format. And it is impossible to write a DTD for it. So, no, what I'm talking about is the overlap in PDF. You can stop and start anything anywhere, which you can't do in HTML or XML. But if somebody can prove me wrong on that, I'd be very happy to prove wrong. Just a feeling.
Well, isn't it the case that something like this can be modeled by making the tree much more complicated? I mean, you would need to have additional attributes to do this, but technically, I think
yes,
you can.
Yeah, I think you're right. If you pushed it to its extreme,
yeah, it would be a very horrible
would be
result.
Very, very horrible. Yeah. I can reassure William that SGML is very much alive and kicking, although it is slowly fading from the digital humanities, having been replaced by XML. But there are many, many, many documents, thousands, if not tens of thousands, written in TEI2 SGML. And they are not being maintained because they've been finished. That is, they are digital representations of an ancient document, and they have been proofread, and that's the end of it. They're not going to be updated at any point, and so they're staying in SGML. So it's very much around there, and there are still people running systems like OmniMark to convert them to HTML for the purposes of display, but the master copies are still being stored in SGML. For what it's worth.
Any more questions for Bill?
I would have one, I think.
Okay.
Frank here. Bill, I follow your work for a couple of years, I guess. I mean, I don't know when we first met, maybe 2010. But I wonder if in the sense that keeping the work relevant, you said it's not clear how many people are still using SGML. I think it is definitely vanishing in some sense. Whether the work could be or shouldn't be moved towards, maybe even if it's getting more limited, to an XML basis. In the sense that you can actually grow people being interested in what you're doing?
Let me see if I can put something on the screen for you. So I'm going to go back into share screen. Actually, I have to, this is going to take a minute because I need to make Zoom small so I can open the window that I want to show you so that I can then share that window. All right, I think I'm there now. So I'm going to make Zoom large, and I'm going to share screen. And now the screen. So can you see this terminal window that's in
Yes.
front of my screen?
Yes, we can all see it.
All right, so so here we have classical LaTeX tabular, and now the question is, okay, so this is actually the SGML that by use only of syntactic translation flows from this markup. And then I showed you during my prepared talk the XML that followed from that, which is more complicated. So the question is whether you want to suggest that people writing source should abandon this kind of tabular markup, which, by the way, this is a place where LaTeX itself has markdown features. I mean, the use of ampersand and double backslash, this is markdown. So personally, I don't want to give that up. When I write something like that, or I mean, whether it's an equation array or a tabular, I like that markdown and I don't want to give that up. But if I want to model that and have something that's just a syntactic translation from the generalized LaTeX to a formal SGML, it's not going to be XML without some knowledge beyond syntax is required to get the XML.
And do I understand it correctly that you're basically saying one of the big features of, or one of the features of SGML was or is the fact that you can have incomplete tagging and those kind of things that the standard actually supports, and this is why you have this additional step to blow it up.
It's mainly for being able to omit tags. There are lots of other things in SGML that I'm not touching.
Yeah, okay, understood.
Bill, Dave Carlisle has a message on the chat. The
Pardon?
chat, the question and answer.
Oh, on the chat?
No, on the questions and answers. Q&A.
David. But would that be syntax only, David? That's, am I supposed to write an answer to this, or can I answer it this way?
Oh, you can answer it live. You can talk to him. He's hearing.
Is David here? He says he can hear me. So, I mean, my idea with this project is to have everything be as modular as possible and proceed from stage to stage to stage to stage with sort of a well-defined task at each stage. And the very first stage is syntactic translation from generalized LaTeX to SGML. And I can do that. I can't do syntax only in translating from generalized LaTeX to XML unless All right, so in the Gelmu manual, I break out something that I called regular mode and advanced mode. And actually in advanced mode, the translation is still syntactic, but it incorporates some features. For example, hyperref's href. It's a command with 2 arguments. And so a syntactic translator, in the source I would use href, but then the 2 arguments need to have names, but hyperref doesn't give them names. So at some point names have to be supplied, and supplying those names requires some knowledge other than syntax.
Mhm. Well,
So in going from HTML to XML, I introduced some knowledge. And at various stages, I introduced more knowledge.
I'd like to ask a sort of naive question, which is, yes, I'm not sure you're the right person to answer the question, but I think it's the right occasion. How long have we been trying to solve this problem, and why is it important?
What problem?
The problem of conversion of documents from one format to another, or the interchange of documents.
Well, I could point you to a mathematical example. And the mathematical example has to do with the difference between the complex projective plane on the one hand and the Cartesian product of 2 complex projective lines on the other hand. And for both of these, the field of rational functions is the complex field with 2 transcendentals adjoined. They share, that is, these 2 geometric objects share the same field of rational functions. I'm talking about rational functions, so I'm talking about algebraic geometry. But there's no regular map from either to the other. So somehow to deal with both, you need to get above both. And you can construct that using blowups.
Okay.
If you do 2 different blowups on the complex projective, well, you blow up a point on the complex projective plane, that's an algebra geometric construction, and then blow up another point, you get to something that will admit a regular map to the product of 2 projective lines. So think of that. That's a place where you can parameterize everything, so to speak. So for a powerful markup, you need to be able to represent everything that you might in any eventual output want to provide for.
By some strange chance, I understood all of that because I know enough algebraic geometry. But I'm not sure many other people did. Why is
So
it?
what I'm saying, you can't very well translate HTML to LaTeX, and you can't very well translate LaTeX to HTML. Although there have been some very heroic, but it's in the end it's an ill-defined problem to translate from LaTeX to HTML because there's the domain of definition the LaTeX command space, if you take all possible packages, you have contradictions. So you just can't take the union of the names in all possible packages as the LaTeX command space. You have to have some same combination of packages. And there are same combinations of packages, but the community has never settled on a definition of what the universal LaTeX command space should be. So we are where we are.
Well, maybe we could just have 3 or 4 people agreeing to work together. That might be a start.
I don't know. I doubt it.
What is it? 2 people of some nationality, 3 opinions? I'll turn off now.
All right. Thank you very much, Bill.
You're welcome.
We will come back in a short 3 minutes for the closing keynote address of TUG 2020 with John McFarland.
Cool. Well done. Okay.
Before we walk into our last lecture, I'd like to make a couple of announcements. First of all, people are gathering at Gather Town. The link is at the top of the schedule page, the link and the password. I would like also to thank all our sponsors, starting with Dunt, Evie, Overleaf, the Carey Graphic Arts Collection at RRT, STM Document Engineering, all the individual donors that contributed time and money for this conference. We had more than 50 individual donors. Special thanks go to University of Adelaide, Australia, for the use of the Zoom license for the conference. And above all, thanks to all the speakers. The conference is you. Without much ado, let me bring John McFarland. John is the author of Pandoc, which in a very few short years have become the Swiss Army knife of document conversion. If you have two documents which are markup based, one doc can deal with it. And it is almost the sole contribution of this man for many years, and now the lead developer with people all over the world contributing and making this beautiful program that I use every day in my work. John, come over.
All right, thanks. Can you hear me?
Yes.
Good, okay. I'm very happy to be here. I've been a LaTeX user for about 20 years. I'm certainly not an expert in any aspect of LaTeX, but I'll be talking about Pandoc, and I think I am an expert in that. So let me share my desktop here because I'm going to try to show you some demonstrations. And I don't really know what people here already know about Pandoc. Hopefully there'll be a bunch of time at the end of the talk when you can ask whatever questions you have. So what I'm going to try to do today is give you a brief overview of what Pandoc is. I'll talk a bit about the use of Pandoc going between LaTeX and other document formats. And then I'm going to try to give a pitch for why one might want to write in Pandoc's extended version of Markdown instead of using LaTeX, even if you are an expert in LaTeX and very comfortable using it. After giving some advantages of doing that, I'm going to note that there's a whole list of obvious disadvantages. And what I'll do in the rest of the talk is try to talk a bit about how you could overcome some of those disadvantages. So Pandoc, I'll just show you the website here. This is a program that I've been working on for about 15 years. It started out as my little hobby project to try to figure out this computer language that I'd heard of called Haskell, which is pretty neat, pure functional language. And it just kind of snowballed, and now it's turned into a fairly big project with over 54,000 lines of Haskell code and over 200 contributors now, I think. So not just me, although I'm probably responsible still for the majority of the code in it. This explains what it does. It converts from one markup format to another. The bidirectional arrows are cases where you have bidirectional conversion, and the unidirectional arrows are cases where you can only convert one way. But as you can see, it covers lots of lightweight markup formats like Markdown. It covers HTML, EPUB, you know, some of the older things like TechInfo and MS and MAN, the raw formats, LaTeX, various kinds of XML, outliners, also word processors, DocX and ODT. Jupyter Notebooks now does bidirectional conversion, wiki formats, various slideshow formats. And so it tries to be, as mentioned, a Swiss Army knife, which means that it's a jack of all trades and master of none, perhaps. But if you want to get 90% of the way there on your conversion job between anything and anything, it's probably a good tool to reach for. So the architecture is described in this slide here. Here's the input formats. There's components called readers, which will convert one of the input formats to an abstract syntax tree, the AST. That can be transformed to another abstract syntax tree by means of something called a filter. And then there's other modules called writers that transform the AST to an output format. So the AST is essentially Pandoc's own internal representation of the structure of a document. The AST is, in a way, quite a limited sort of format. It is not as expressive even as HTML, certainly not as expressive as a format like LaTeX, where you can do fine details of how pages are laid out. It basically gives the main commonly used structural elements of a document. And because it's not that expressive, the advantage of that is it's easier to write readers and writers, and that's why Pandoc can support so many formats. The disadvantage is in a typical conversion, the conversion may may be lossy because you're going from a more expressive format to a less expressive format and then out again. There are some exceptions where they're not lossy, and the main ones would be, for example, Pandoc's Markdown, which is 100% supported. So we'll talk about that as we go on. So let's do a brief demonstration. Here's a really simple little LaTeX snippet that just is a section header with some math and a label. And we can do Pandoc from LaTeX to native. And that shows you what the internal AST looks like. It says, well, we've got a level 1 header, we've got the identifier Einstein, and then we've got the string on, a space, and then some inline math. Pandoc represents the inline math with tech. We can alternatively, we'll convert that to HTML, and then you get HTML. Note here that the math is represented using a method I call faking it with Unicode. So we're just using regular HTML here. And in the case of E equals MC squared, you don't need to do anything fancy. There's a lot of math that can't be represented adequately that way. For example, fractions. And in that case, with this default method, Pandoc will just fall back to the raw tech. But you can also tell Pandoc to, for example, use mathml to represent the math in your document. And then you'll get mathml. Pandoc will convert the LaTeX to mathml. Or you can say, well, I'm using MathJax to serve my HTML page, and then it'll just give you the tech, which MathJax will then turn into something nice. So you have a lot of options there. Now this is in its default mode, Pandoc will just produce a document fragment. If you add the -s for standalone option, then it will insert that fragment into a template and give you full header and footer. So here's a full HTML page that you could put right on the web with here's the import of the MathJax script and everything else you need. Just to demo it a little more, we could try converting to Graph MS format. There you go. As you can see here, the equation is now converted from tech to the EQN format that ROF uses. There's the equation there. You can convert it to, say, GitHub flavored Markdown, and then you'll get something like that. You can convert it to context if you're a context user. You can convert it to JATS at XML format, like an archival one. You can see here it's using mathml automatically because that's what JATS calls for in its specification. Okay, so that's a brief introduction. Now let's try a little bit more real world of an example. I'm going to use this sample tech document. Let me just make sure I've reset it here. That's on the website of Professor A.J. Roberts at University of Adelaide to demonstrate tech math. So here's the document. It's got a bunch of stuff in it that you might typically use. So let's convert that with Pandoc to Microsoft Word docx and see how that works. Okay, so Pandoc is telling you here that it's giving you two warnings. It said it could not convert it perfectly. One problem has to do with the use of math code here, which is a lower level tech primitive, and Pandoc often has a hard time understanding those things, as you might expect. The other problem comes from the use of pair box, which Pandoc's math conversion doesn't know how to handle that. So we can go in and fix those two things. This is just kind of a practical example of what you might do. So first we'll go to the math code bit. I'm just going to take that out and delete it. And then we'll go to the pair box thing. So what the author here has done is defined a command, pair math, that puts something in a pair box so that it will break more nicely. And so what I'm going to do is just make this a no-op command that just passes through its argument. Now, Pandoc will actually read this new command and interpret it as it tokenizes the document. So what that'll do is it'll mean when Pandoc hits this pair math thing, it will know to just ignore it, which is not as good as doing what it was supposed to do, but at least it will give you a result. And now we have it convert with no errors, and we're going to open it up in Word, and here is the result. So there's a couple of couple nice things about this to note. First is, at least with the most recent version of Pandoc, the AMS theorems get processed correctly. So you got the definition, lemma, you got the numbering, and you've also got the back refs to them coming out correctly. And they're even hyperlinked. Second, the math is all rendered using native Microsoft Word equation objects, which you can edit and which are using appropriate fonts. So they match the main font of the document. So the math comes out pretty nicely. And basically, it's just about a perfect conversion of this document. One thing that is missing is equation numbers at the end. The original document uses an equation environment, which should be giving you equation numbers here. And Pandoc doesn't yet handle that, but everything else is handled. Okay, now if we want to go the other way, we'll convert the docx to a TeX file, new maths. I'll put the -s to get a full document. And then we can process that with LaTeX and see what it looks like. You get something that compiles and it looks basically right. So that's a round trip translation from TeX to docx and back to TeX. And I think it looks pretty good. You know, all these equations are really being round trip. They're getting converted to Word's document, Word's equation format. This is an XML equation format, and then they're getting converted back to TeX. You can convert to HTML as well. So we'll convert it to HTML. We'll tell it to use MathML. We'll tell it to number the sections and provide a table of contents. And then we get this, which you can put on your web page. So again, MathML comes out okay in Safari. It's not quite as nice as using MathJax. Now, I tried comparing Pandoc's results on this with a couple of other converters that are out there. I mean, one you can try is the venerable LaTeX to RTF. And now we'll open in Microsoft Word the results. And okay, so here's what LaTeX to RTF gives us. Oop. And you know, parts of this are okay, but there's some problems. Okay, so up here we got the AMS theorem environments, but we didn't get the references to them. In section 2, there's supposed to be accents, and those didn't come out correct. Those didn't come out on top of the symbols. They came out somewhere else. That's not good. In section 8, the arrays just didn't work at all in the cases environment. The one thing that it did better than Pandoc is it gave you the equation numbers here, but overall it's not a very good result for that one. Oops, didn't mean to do that. So let's now try TeX 4HT. Make 4HT maths will do that. That converts it to HTML. Of course, if you can convert it reliably to HTML, you can read that into docx. Maybe that will look okay. There. So let's see what that looks like in HTML. Again, we didn't get the references. We didn't get the theorem environments. We didn't, again, we don't have any accents at all on these formulas. And there's something very ugly about this because this equation, for example, is a mix of an image used for the fraction and normal text for the rest, which gives a very ugly result because you're not even using the same font. So that's not too good. I often see people say, oh, well, nowadays you don't really need to worry about it. You just produce the PDF with LaTeX and then just open up the PDF in Word and it works. So I thought I would try that too. And it does sort of work. So here's the result. Let me make that a bit smaller. So some things are good here. That doesn't look too bad. But again, in section 2, the accents are messed up. Note also that here, an image is used for this equation. So apparently Word just, maybe Word uses LaTeX or something to produce the image. I'm not quite sure, but whereas regular characters are used for this one, the fonts don't match and it looks terrible. In section 6, you get the where clause here completely in the wrong place, so you can't figure out what's going on. Section 7's missing an integral that's supposed to be there. The arrays are missing the diagonal ellipses, which are supposed to be there. So there's a bunch of problems with this too. So I think Pandoc, at least on this sample, Pandoc does better than those alternatives. And maybe there's other alternatives I don't know about. Now, a couple other things about Pandoc that I think are of note. Pandoc, as I mentioned, can interpret TeX macros. So if we have this little TeX file here, it defines a new command, it defines another new command, it defines a new environment. And if you run Pandoc on that and convert it to HTML, you'll see that even in HTML output, Pandoc has correctly processed those macros. So that gives you a lot of flexibility. And in fact, if you run into something that Pandoc cannot interpret, one of the tricks you can use is to simply insert into your document a macro definition that does something Pandoc can handle with that construction. And then Pandoc will resolve that macro and give you a better result. Pandoc can also resolve BibTeX citations with the help of the Pandoc siteproc filter, which is included in the release binaries. So an example of that, Pandoc siteproc, I tell it to use the Pandoc siteproc filter. I'm going to have it use this TeX file. I'll have it go to plain text, and I'll tell it to use the CSL style IEEE. So CSL is a alternative to BibTeX. It's a different, it's an XML-based way of specifying bibliography styles. So that's what Pandoc is interpreting here. So here you go. If you don't do that, it'll use the default author date format, and you can use footnote formats in any CSL format you can use. Now, at this point, you might be thinking, great, I can write in TeX. I can just use Pandoc at the end to produce whatever I need to produce, and I don't need to change my ways. But unfortunately, Pandoc is really far from being able to convert arbitrary TeX files with high accuracy to other formats in a way that's not too surprising, given the incredible flexibility of TeX. So here's a file I got kind of by random off the archive. So we'll convert that and see how that comes out. Oh, lots and lots of warnings, mostly about bits of math that Pandoc had a hard time understanding. So if we open this up, here's the result. And you can see that lots of it are pretty good, but there are places like this where Pandoc simply didn't know how to convert the math, and it just fell back on using raw text. So you would have to go in and fix those things, or define macros and run Pandoc again. There's a whole bunch of those. There's references that don't really get resolved quite properly, and you have to fix those by hand. And a number of other problems of that sort. So it's, this would be fine. It'd probably take you an hour or so to go through and fix the problems in this. But certainly that's an hour you'd probably not like to be spending doing that, maybe more than an hour actually. So in general, Pandoc's not going to get you all the way there with arbitrary text files. Again, not surprising. And we can improve Pandoc. We keep improving Pandoc, and it'll get better and better. A lot of these particular issues can be fixed, but it's going to approach accuracy. But I think you're never going to get to accuracy without re-implementing tech. And again, as the previous speaker said, I think the problem is kind of ill-defined. So here's an alternative that I want to suggest. If you have needs to produce documents in different formats and not just a PDF, you can write your document in Pandoc's extended version of Markdown. That way Pandoc will be able to convert it with complete accuracy to any of its output formats. And so what I want to explore in the rest of the talk is that option. What is Markdown? Probably most of you have heard of it, but if not, it's a set of conventions for indicating document structure and formatting in plain text. Mostly this is inherited from pre-internet days. So asterisks around something to emphasize it, for example. So this was designed in 2004 by John Gruber with help from Aaron Schwartz. It gets used by programmers a lot. It's used on some internet forums. It's used by data scientists quite a bit. So you may have encountered it. Here's the canonical website for the original version of Markdown. Now, let me just go through some things that I find appealing about writing in Markdown before I get to the caveats. So first, one nice thing about Markdown is the source text is readable as it is. It's the kind of text that you would have put on an old-fashioned bulletin board in a .txt file back in days when people did that. You can just read the text without mentally parsing commands or tags or anything like that. If you're writing in a language other than English, you also it's also sort of nice that you don't have to have English words like section or strong sprinkled through your text. If you're writing in Chinese, your text is just going to be a block of Chinese characters with a few little ASCII symbols in there. There's no boilerplate. Your document can just start out with the text. You don't have a big preamble defining all the packages you're using and so on. There's a real separation of content from formatting. Now, of course, in LaTeX, it is possible to separate content from formatting. You can put everything in a style file, include that at the beginning, and then define macros that precisely match the semantics of what you're doing and have a beautiful content-only kind of document. But you always can stick in anything down to low-level character positioning macros anywhere in the text. So there's no enforced distinction of content from formatting. Here's a quote that I kind of like from Michael Thompson, who's a philosopher who wrote a long time ago on the Pandoc Discuss mailing list. So he says, the paucity of means is the greatest virtue of Markdown and Pandoc Markdown. It's strangely difficult to get people to see the point, but the defects of LaTeX for concentration, writing, and thought are at least as great as those of Word, for the simple reason that it gives the writer too much power. There's always another package to call in the preamble, as there's always another drop-down menu in Word. In Markdown, not to put too fine a point on it, the writer is only ever faced with one question, and it's the right one. what the next sentence should be. You've just got the content in your document, and that's all. If you use Markdown, you can collaborate with other people who don't know LaTeX. They'll probably be able to figure out how to add their additions to the Markdown document. LaTeX, not so much. And Markdown can be converted with complete reliable accuracy into many different formats, because Pandoc will give you a reliable translation from Markdown to any of these things. These days, it's not enough to produce a PDF and stop. Often you need other formats. You might need something like JATS for publication or archiving. You might need an EPUB, so people can conveniently read your article on mobile devices. You might need DocX or ICML because your publisher says they require that format. Then they won't take LaTeX. You might need HTML for a website, or maybe you need an accessible version. Right now, as people have been talking about, LaTeX is not really fully there in terms of producing accessible documents. And so maybe you want a LaTeX version for your blind students to read. You might need a Jupyter notebook or something like that. You might need slideshows. And if you write in Markdown, you can just easily go to any of those from your source text. So this would be using TeX essentially as an assembly language for producing the publication quality PDFs, but not as a language for writing. Okay, now to the caveats. Well, of course, there's a bunch of problems that you will have thought of. The original Markdown syntax doesn't have support for tables, figures, footnotes, definition lists, ordered lists other than decimal numbered ones, super and subscripts, math, metadata, attributes on individual sections like identifiers for sections or labels, cross-references, numbering for running examples or equations. And you might think to yourself, well, there's no way I could do what I need to do in writing without these things. No, I mean, if you're writing fiction or something, you really don't need those things probably, but for most kinds of academic writing, this type of thing is essential. And then, people who are used to using LaTeX couldn't live without BibTeX, BibLaTeX, citation resolution, and definitely couldn't live without macros. I mean, macros, it's the greatest thing about TeX. You define a macro for the particular bit of symbolization you're doing. You can change it later, no big deal. You can craft a language that precisely fits what you're writing about. It's beautiful. So what I want to talk about now is how we might overcome those limitations while writing in Markdown. One way we're going to overcome them is by using Pandoc's extended Markdown syntax. So over the years, we've added a lot of extensions to Markdown syntax that Pandoc can understand. They can be enabled or disabled piecemeal if you like. So tables are supported in various formats. They're still somewhat limited for various reasons. We're trying to remove some of those limitations, but there is some support for tables. There's support for figures, again, slightly limited, but it's there and will expand. Math, display and inline math. Footnotes, definition lists, more flexibility in ordered list numbers, example lists, super and subscripts, strikeout, metadata, attributes, and various kinds of generic containers that you can put around things, like kind of the equivalent to HTML, div, and span, but in Markdown. So you add all that, that avoids a lot of the reservations that we had. In addition, as I've already shown you, Pandoc can understand LaTeX macro definitions, even in Markdown. So, I mean, the trick is when you use them in Markdown, they're only going to affect TeX or math output. So you can't say new command John, and have that come out in HTML, because what Pandoc will do is convert the John into a bit of raw TeX in the AST, which will only come out if you're targeting TeX. But you can define macros that you're going to use in math, and Pandoc will apply those macros when you're targeting other formats. So math macros that you define will work when you're going to say docx. So that's really helpful because macros are pretty essential for math. Labels and cross-references are still a work in progress. I hope we can add better support for that as we go on, but at this point you can support those things with an external filter called Pandoc Crossref by Nikolai Yakimov. So you can check that out if you want. As I've noted, the Pandoc SciProc filter can be used to resolve citations, so that gets around our problem about not having BibTeX. You can use your existing BibTeX or BibLaTeX bibliography files. It will understand those. Or you can use CSL JSON bibliographies like Zotero has. In Pandoc's Markdown, you use this sort of syntax for citations, which I think looks fairly plain texty and natural. Pandoc does a nice job of allowing you to change the style without any modifications in the source, even if you're going, say, to a footnote style from an author date style. Oh, I'm sorry. Now I'm realizing that that thing that keeps popping down might be when people have questions. I'm sorry I hadn't realized that, but why don't I go through what I'm going to say, and then I think we'll have adequate time for questions at the end. So what about the last thing, being able to flexibly create macros that fit what we're writing about? How can we cover that flexibility? And the basic trick that I want, here, hold on, let me click on this Q&A thing. Okay, yeah, save the questions for the end. There's a lot of good questions coming in, but okay. So one thing you can do is you could just include raw tech in your Markdown. Pandoc will pass that through to tech output. There's a special syntax for marking things out as raw tech. Pandoc will also tend to recognize obvious bits of raw tech. And those will just be omitted if you're targeting a non-tech output format. Okay, so that kind of works. So here's an example of that. Whoops. So here's something where I've just included some raw tech. So latrine environment and a tick picture and rotate box, and we can process that with Pandoc. And Pandoc will, behind the scenes, run tech on it and see all that stuff works just fine. But the problem is, if instead you go to HTML, you're going to get this. All the raw tech is omitted. So that's not good. So, that's okay if you're only targeting PDF, but if you're doing that, maybe you should just write in tech, right? And you also have like an ugly mix of Markdown and tech in your source. So the approach I want to sketch for you now is the following. So you adopt a convention that a certain thing that's representable in Pandoc's Markdown should be interpreted a certain way, say as a drop capital letter. And then you write a filter that transforms the Pandoc AST in a way that makes sense for the output format to interpret it that way. So here's an example. In LaTeX, we might write this for the drop caps. In Markdown, let's adopt this convention that a span, this is a bracketed span syntax, with the class drop cap turns into a drop cap thing. So how do we make this happen? We got to write a filter. Again, a filter transforms the AST. So we're going to find span elements which have class drop cap in the AST and replace them with something appropriate to the output format. We have to walk the AST, but we've got libraries that make it very convenient to do that. So there's two kinds of filters you can write in Pandoc. One kind, the older kind, is called JSON filters, which operate on a serialized JSON representation of the AST. You can write them in any language. There's libraries for doing that conveniently. But recently, we've been kind of promoting this new kind of filter called Lua filters. So Pandoc actually embeds a Lua interpreter and provides a special Lua environment that makes it very convenient to do these AST transformations. because the Lua interpreter is built into Pandoc, you don't need any external software. And also this is much more efficient than using the JSON filters. So there's documentation on the website and a kind of tutorial if you want to learn how to do it. But I'll give you a couple examples. So what we do in the Lua filter is we just provide functions that match the different kinds of AST elements. And they're going to return a value which will replace that AST element wherever it occurs in the AST. So in this case, we want to modify span elements. So we're going to write function span. L will be a variable that represents the element. And we're going to do something with that and then return the transformed element or a new element. So we want to check to see if the span has the class drop cap and its contents begin with a string element. So we can check for drop cap that way. Here, and then if it does, we want to create the drop cap somehow and return the result. So now we'll write the make drop cap function. And this gives you an example of how you do it. So this looks at, this first checks to see if the first element is a string. Then it separates out the first letter of that from the rest. And now we check the format. If it's LaTeX, then we produce a raw LaTeX inline with the latrine command, the first letter and then the rest. If the format is HTML or HTML4, HTML5, then we produce some spans with classes, and then we can use CSS to format that. So let's try it. Copy paste here. So first we'll make a PDF. Yeah, I forgot to specify the file name there. Oh, wow. Sorry, that didn't work. Here, I'll just convert it right to tech so you can see what it looks like. Oh. There. So there's the latrine thing. I mean, you'd need to provide a template that includes that, that package for it to work for PDF. But now you can see that if you instead convert it to HTML, you get a span with the drop cap first on the first letter and drop cap rest on the rest. And so that looks like that. And, you know, so you have to do a bit of manual work for the formats that you want to support with the filter. But once you've got the filter, you're set. Another example would be TIC-Z diagrams. That's something that a lot of people like to use, and be nice to be able to use them in Markdown. It'd be nice to be able to use them in Markdown and have the results appear no matter what output format we're using. So there's already actually a very nice diagram filter that other people have written that you can get at this repository, which contains some Pandoc Lua filters called the diagram generator. So here's a diagram. Here's a Markdown file with a diagram. So you see what we're doing here is we're using a Markdown fenced code block, which would normally just represent source code, with a class GraphViz. And that's going to tell diagram generator to run this through GraphViz and include an image. Okay, so we're going to write Pandoc diagram MD. We're going to tell it to use the Lua filter diagram generator. We're going to produce a standalone document. We're going to tell it to extract any media, that is the picture that's generated, into the media subdirectory. And then the output will be diagram.html. And let's see if it worked. Yes. So there's your HTML with your diagram. You can do the same thing to docx. If you do to docx, you don't need to extract media, obviously, because in docx, the media is part of the docx container. So let's see if it worked in docx. There's your docx with the finite state machine. So this is nice. Now we can use TUG no matter what format we're targeting. Final example is about reproducing a LaTeX theorem environment. Now, you kind of have to choose some markdown thing which you want to become a theorem. So one idea would be to use this thing, which is what's called a fenced div in Pandox Markdown. There's the opening, there's the closing, here's the attributes. And you could say, well, when you got a fenced div with class theorem, that's the identifier, it turns into a theorem. And you could adopt the convention that if it begins with a heading, section heading, then that's the optional title for the theorem. Okay, so here's a Lua filter that that does that job. It does it for LaTeX. What it does is it just puts it in a theorem environment. For other formats, it will fall back to a generic thing with the title in boldface and so on and so forth. So let's see how that looks. So we'll first go to LaTeX, and there's our theorem environment. There's our optional title. There's our label. That all worked. We can go to plain text, and there it numbers our theorem, gives our title, and so on. You can go to any format. So that's a bit of a demonstration of what I wanted to show you about how you could actually write serious things in Pandox Markdown. If you got questions about Pandoc, come on over to Pandoc Discuss on Google Groups. That's the mailing list. Bug reports, go to the GitHub tracker. We can always use new contributors if you want to improve Pandoc's handling of LaTeX. And one way to contribute is simply to give really detailed bug reports. If you know what the LaTeX should look like and it doesn't, just let us know. Okay, thank you. Open for questions. Now let's see. Maybe I should.
You have a few on the Q&A, John.
Okay. So I'll start with those. So is there an overview of the basic set of tech commands and environments that will properly be converted by Pandoc? I think somebody did produce one at one point, but it's probably way out of date. So there isn't really. You can look at the source code for the LaTeX reader, and that will give you a pretty good idea, even if you don't understand Haskell. Second question is, Tristan Miller, a very common use case when converting between document formats is converting the semantic markup, but disregarding the formatting markup, right? That is, when I convert a document, I generally want to convert markup for things like section headings, enumerated lists, quotations, footnotes, but not fonts, margins, indentation. I want the target document to look like it was originally composed in the target format. Does Pandoc support that use case? Absolutely. That's precisely what Pandoc does. And in fact, a lot of people use Pandoc to clean up HTML produced by Microsoft Word and stuff like that and make it look like more normal HTML. So yes, Pandoc will ignore all the stuff that just has to do with formatting. It pays attention to things that have to do with the structure of the document. Okay. So Edgaras Sakuras, sorry in advance for the stupid question, but if you, for some reason, decide to write yet another tech engine, would you still choose Haskell, and why? Well, I don't know. Probably yes. I think my ability to maintain this quite large and complicated program in bits of spare time, I think relies quite a lot on the fact that it's in Haskell, which gives you lots of guarantees from the type system that things are right. And I find it quite alarming to come back to a program that I've written in C or JavaScript and modify it later, because I've lost in my memory all the little bits of things that I needed to have in there to make sure I didn't break it. With Haskell, the type system usually makes sure you don't break it. And you can refactor things by just changing something and letting the compiler tell you where you need to look next and what you need to change next, which is really, really nice. So I really like Haskell, and I would use it again, yes. It's my favorite language. Okay, there's a question from Kartip. What's the story behind the name Pandoc? And is Pandoc Markdown being considered as an extension to the Common Mark standard? Okay, so Pandoc is just a name that I invented based on the word pan, which is, you know, Greek word for all, and doc, which has something to do with document. So I just put those together and it sounded like a cool name. So it has to do with the universal document converter thing. Is it being considered as an extension to the Common Mark standard? Well, Common Mark, so Common Mark is a kind of specification of the original Markdown document that John Gruber put out was very, very loose and left tons and tons of corner cases unspecified. So Common Mark attempts to precisely specify some version of the Markdown language. And Common Mark came after Pandoc's Markdown reader was pretty entrenched. So currently Pandoc Markdown isn't a superset of Markdown at all, although Pandoc can be used with the Common Mark format. My eventual goal is to add enough syntax extensions in Pandoc that work with Common Mark to be able to switch over to Common Mark for the default basic Markdown. Now, as for extensions that are being officially recognized as Common Mark extensions, right now, Common Mark still isn't fully settled as far as the basic elements go. So only when that's done will it turn to officially blessing extensions. But that said, Pandoc is supporting already a number of the Pandoc extensions, which can be applied on top of the Common Mark reader. So if you want to write an extended version of Common Mark, you can do that. All right. Okay, I think that's all the questions that I see in the Q&A. So
there are a few on the chat, John. I mean, I don't
okay. Hold on. Chat.
Especially if you make your slides available.
Yeah.
Okay. Another one is I wonder if Pandoc ever going to move towards being able to execute code blocks like org mode.
Right. Yeah. So that that's actually like a perfect job for a filter. So you can write a very, very simple Lua filter, which will intercept code blocks that have certain attributes, take the contents, run it, put the output in. It's not built into Pandoc. I'm not sure I'd want to build it into Pandoc, but it's so easy to add it with a filter that I don't really think it's needed.
With that, I want to thank you very, very much for such a nice talk.
Yeah, sorry, I want to throw in something first of all. I mean, thanks for the great talk. I'm very happy to see the Lua filters. I started using Pandoc for documenting the programming language we are developing, and so writing a reference document and online manual, as an online manual. So I used a mixture of Markdown and creating PDF and HTML, all this kind of stuff. I remember that 10 years ago when I started this, I think there weren't any Lua filters in this kind, and I used the GPP, a general purpose preprocessor, to get separate output for HTML and LaTeX and text and this. So I'm very happy to see these Lua filters now, because this makes for me many things much easier. And thanks again for the extremely useful and great program.
I'd like to ask a question. Okay, it's slightly theoretical. Suppose I want to work with write in LaTeX and collaborate with somebody who's writing in Word, and I want the round tripping to be perfect, or at least I want to be told when it's not. And I want your comments on the following. We can go from LaTeX to AST and back again, and we can view that as a normalization. And we could say that something in an AST is LaTeX good if when we take it to LaTeX and back again, we are round tripping.
Yeah.
And we can do the same for Word. We can say an AST is Word good if when we go to Word and back again, everything works fine.
Yeah.
So every time I make a change to my document, I could send it, I could check that it's both AST good, both LaTeX good, and Word good.
Right.
And then I get my bad news early.
Yeah.
I expect that might be a bit expensive, but do we have any sense as to where the sweet spots are for the AST regarding, say, LaTeX and Word, and where are the rough areas regarding the AST, regarding LaTeX and Word? In other words, if I give you an AST, can you look at it and say, oh, well, that's going to be good for LaTeX, but it won't be good for Word?
Right.
Do you understand the question or the approach?
No, I do. I do. We do a little bit of round trip testing like that, automated round trip testing on randomized ASTs and stuff like that, but not too much yet because honestly, we're not really quite there yet. So for that to work, the readers and writers have to match up in a very particular way, and you can't introduce any small differences. Sometimes you get that property in a limited area at least, and sometimes you don't. It'd be great if every reader and writer matched up perfectly in that way, and that could be we have maybe the ambition to get there, but we're not really there yet.
What I'm interested in is knowing where it's good and knowing where it's bad. So I can say.
Well, it's easy enough to do
I guess what it is that if I'm collaborating if I'm LaTeX and collaborating with somebody in Word, we're in a particular domain with particular habits. We inhabit particular areas in these two things, and it sort of becomes our responsibility to make sure that we're not drifting away, and that I don't work for a week creating LaTeX that won't convert to Word.
Right. Well, it'd be easy enough to create a makefile target or something that just does the bidirectional transformation and gives you a warning if it's not the same. And then you could tell on your own end when you diverge from.
So does that sound like a reasonable approach?
Sure.
Okay, I've learned something. Thank you very much.
John?
Yeah.
There is still one more in the Q&A.
Oh, okay. Hold on. Q&A. So how on earth did you come to write this incredible program? Well, I mentioned it at the beginning. It's so weird. I just honestly started writing it like the day I was first learning anything about Haskell, because the way you learn a computer programming language is to try to write something in it. And I'd seen about this markdown thing, which was just at that point, just some Perl regular expressions. And I knew that Haskell was good for writing parsers. And so I said, well, maybe I could try to write a parser for markdown. And so I did this just to learn Haskell. And then I thought, well, but the problem is at the time I was using restructured text for all my notes and stuff. So then I thought, well, could I get the restructured text into the markdown? So I wrote a reader for restructured text and a writer for markdown. And, it kind of just snowballed. And then eventually I put it on my website and somebody picked it up, a Debian developer, and it became an open source project. And I mean, it really is kind of a lot like having a child, because now it just takes a ton of my time, but I can't just abandon it. So, it started off as, it was just a one-night stand with Haskell, actually, but but now here is where it's led.
If there are no more questions, I'd like
I actually had a bit of a follow-up question.
Oh, go ahead.
Yeah. So I was thinking that like, so a pandoc filter, it goes through the entire document once, right? And then it cannot interact with other filters running on the same document concurrently, right? So if I execute code, so if I write a filter which say executes bash code, then, and I have another filter which say executes Python code, then they can't actually communicate with each other. Is that right?
Well, if you have two filters, they'll be run sequentially. They won't be run in parallel. They'll be run one and then the other one, whatever order you put them on the command line.
So then,
and each one will go through. Each one will walk the AST. That's right. You could try to, if you want to be more efficient, you could try to write one filter that did both conversions at the same time. But Pandoc doesn't automatically know how to combine filters that are compatible in that way.
Okay, because I was thinking about how to pass the results of different programming blocks to each other, really. And okay, but that could be done.
You want the first filter to read something, produce something, and the second filter takes what that produces and does something else. Yeah, totally, you can do that. Absolutely. Yeah, so you can chain filters together, and with the Lua filters, you can even within one filter tell it to use, within one filter program, you can define several filters and tell it to apply them in a certain order. You can also do something in Lua filters where I mean, there's a special command that's provided, which will allow you to walk a particular part of the AST with a filter and only affect that part. So you can do things like, find specially marked divs and then apply a certain filter to that div, but not to anything else.
Okay, yeah, that makes sense. Thank you.
Yeah, sure.
Any more questions out there? Well, with that, I'd like to thank John very much for accepting and being a keynote speaker at TUG 2020. And I would like to call Boris to the floor, the president of TUG, for closing the conference.
Thank you. Thank you, Paolo. Okay. Several months ago, when we understood that we cannot have TUG 2020 in Rochester, we thought about online conference. We understood that it would be huge risk and we might not be able to do it. And we really would not be able to do it without all of you. I'm really grateful to a lot of people who made it possible. To everybody who presented, to everybody who listened, to our absolutely great chair people, to the organization, to the conference committee, which worked just around the clock to make it possible. I'm absolutely grateful to our sponsors. You can find them on our webpage. It was Dante, it was Overleaf, Reed Gary Graphics Art Collection, Techfolia, and the University of Adelaide, which gave us a lot of computing resources. I also would like to have my special thanks to a person without which it would not be possible at all. Okay, when we decided to cancel Rochester meeting and we didn't know what to do, I remember that I said this: we have basically two options. We could either cancel everything and not have anything, or we can ask Paul and Nate de Souza to organize a virtual meeting. And we decided to go to the second route, and we did it. And I'm so glad that I understand that it was absolutely huge, tremendous task, and I don't think anybody else would be able to do it but him. We have several traditions. One of the tradition is that people usually get some souvenir, something from Tech Users Group's meeting, T-shirts, mugs, and so on. Unfortunately, we don't have possibility to do it this, but if some of you, if you want, and by the way, if some of you need certificates of attendance, we know that some people need it for their employers. We will try to typeset NAS certificate and just contact us, and we will send it. It would be the only souvenir we can do for you for this conference. Another tradition is, and people who have been to Tech Users Group conference know that we always send some gift to the organizer, without whom it would not be possible to do. And I'm glad that we decided to keep this tradition. So we talked to Gary we got to read press and Gary collection, and we found a very limited edition of Manualia Sapficum by Richard Kelly. I think it's just 100 copies were ever printed, and it looks like this. I don't know whether you can see this, but it's one of the most beautiful books I ever have seen, and I'm glad to say that we are going to send it to Paula, and please wait, it will be yours. It's the least we can do for you, because you're absolutely great. And the last thing I want to say here, there is a very old tradition. For a couple of thousand years, diaspora Jews, when they had Passover celebration, the last thing they said in the Passover celebration in diaspora was next time in Jerusalem. So after this very strange and wildly successful conference, I would like to tell everybody, okay, next time in person, and see you again in person in 2021. Thank you.
Thank you to all. Thank you to all. Ross, would you stick around?
Yeah, sure. It's morning. I've got to take my dog for a walk.
You take dog for a walk in the, oh, it's in the morning. It's morning.
It's in the morning, yeah. It's 8 o'clock in the morning, 20 past 8. He'll be wanting to go. My wife will be back soon, and if I haven't taken him for a walk before then, I'm in trouble. I'm in the doghouse.
Now, I was going to ask if Will is, because I haven't seen him in the roster.
Yeah.
Well, he's expecting another family member, so I have no idea how much time he has.
Yeah.
What I would like to find out is if we have if there is a backup of the chat and the Q&A in the Zoom server or not.
Yeah, sure. Okay, look, later today I'll see if I can get into the pages at Adelaide, but maybe we'll have spoken Will by then.
Huh?
I mean, so the control pages for the webinar at Adelaide under MacEng should have a list of all of the URLs for the Zoom sessions, and there should also be something there for the chats, right? All the stuff that Zoom normally sends to me should be there on his site. Yeah, when I do it myself, I get all of these links coming back, and I can go check them out. So he should have the same thing.
All right, I'm gonna just to be on the safe side, I'm gonna copy all the. I'm gonna try to copy and paste all the chat and all the Q&A, and then later we'll try to get something more structured than a copy and paste out of everything here.
Yeah, well, you can grab what's there now, which probably is only today, isn't it?
Yeah, it's only today because it self-started after 24 hours again.
Yeah. Yep. Okay, well, that's something that we really just have to be aware of in the future.
It was a very nice conference. I loved it.
Yeah. No, I think it's been great. I think it's been really good. I mean, I haven't watched everything.
Really good experience. I mean, dangerous in many respects and adventurous in others, I would say. But I think you pulled it off really, really great. I mean, absolutely the applause.
I mean, I think
yeah.
the greatest part of the success was the speakers. You know, we were able to set up a roster of talks that was really very broad. You know, bringing people that were from the outside, and it was very, very nice.
I'd like to thank you, Paolo, for what you've done and for the encouragement you've given me. I'm going to beat my own drum. I made an effort to try and get speakers in from outside, and it turned out more successfully than I thought. And I've heard Bandon's talk twice now because I was there in the audience, and I thought it was really impressive. And the first part of that talk is actually a nice introduction to LaTeX, or tech, what tech is about. I mean, normally we go in and we give all the technical stuff. We start talking about category codes and so forth, and we don't have to. So I think we learn a lot from holding this conference and from opening our doors a bit, particularly to the people who can't travel or don't want to travel. So I think this has been a tremendous event, and we've made the best of an unpleasant situation in the outside world. So thank you, Paolo, for stepping in and taking advantage, making this happen.
Oh, don't thank me at all. This was an effort which was a lot of people, and
Well, I thank the others as well. I thank the people in Adelaide and the people in TUG who've contributed. But sometimes it takes one person to say, well, I'm going to make an effort to have something happen. And then the ball starts rolling. I'm going to be quiet now.
okay.
What?
And probably one thing that occurred to me as a result of this, you know, this whole infrastructure that we built, and is that we should have a component online for all TUG meetings in the future. Huh? We should have a presence online so that we give the chance of people from outside to join in. I mean, there were a lot of people.
We did some experiments in the conference you organized in Rio. Yeah, you had online part, which was, I think, was very successful. We had translation. We probably need to have more of this, and probably need some people who would monitor the online part and give questions and so on in the live conferences. I think it would be a very useful thing to do.
Yeah.
There's some prior art in this area. I'm a member of the London Mathematical Society, and they published an article about a dual location conference. The article was published last year. So it took place, I think, at the Perimeter Institute in Canada and something like the Max Planck Institute in Bonn. And you travel to your nearest location, and then video and similar methods were allowed the lectures to take place at whichever location. And they were going to hold another conference of the same nature earlier this year in June or something. And of course, it was a completely virtual conference. But I think they've got a lot of interest in that sort of thing. They certainly wrote an article about it, and I think they'd be willing to share experience. I tried to get one of the people involved in that conference, involved in the organisation of that conference, to talk to this one, but they're all too busy. However, I think that we could have another shot, particularly if there's, what's the word? There's only so much strength I can give in the invitations I give, because I'm an ordinary member of TUG. But if there's a push from the board to say, we're going to go down this direction. It's going to be easier to get an involvement with other organizations. And I think the problems of mathematical communication are very, very different now in this area, in this period of COVID. One of the big benefits was that now all the math seminars are on a list online, and you can go to whichever ones you want pretty much. So that was quite extraordinary. I went to a seminar in MIT last month because somebody I knew was giving a talk there. And that never happened before. So there's sort of leveling going on and fantastic opportunities if we're willing to go outside of our shells and our comfort zones and go to the places where we think people might be interested here. I think that TUG has been inward for much too long and seeing itself as the center of the world. I'm sorry, you're not. But this conference has been very good, and our ability to get speakers surprised me immensely. So I'm very, very pleased with the speakers we got. That's a very encouraging thing. I'll be quiet again.
Yeah, the richness of the speaker body and the ability to bring people from outside was really, really a point. And we should try to preserve that. The infrastructure that we built for this particular specific conference is also being very important, and we should preserve all of it for because we may be still in the middle of this next year. You know,
Yeah,
there's a chance of that. Then we should be prepared way ahead of time, rather than starting in March or April. You know, we should start way back in December this year and be way more prepared. The workshop was a total success. It was the first time I seen being attended by that many people. You know, they also, Cheryl and Sue, never seen anything close to the number of people that came into the workshop, and it was a Herculean effort. You know, they taped many more hours than what we have shown. For each hour that was shown, they taped about 3 times as much because they didn't like their own taping, they didn't like their own stuff, and so forth, and redid and redid and redid. And it's now something that we can just grow up on top of it. And lots of people that attended the workshop communicated back with us saying that it was really great, including the people that did automatic translation on YouTube in some other language to just attend the workshop. Good.
Okay.
Okay, Paulo. Famous last words. It's about getting close to midnight for myself. No, it's actually past.
No, my last words is thank you for all. Thank you for all the help. You know, I was very worried in the beginning about you know, the program. We had to build a program very quickly, and I had the help from a lot of people in building the program, including you and Ross and Norbert, and at the end, I thought the program was so strong that I wanted to withdraw, and I wasn't allowed to withdraw, and I should have, you know, because some of the talks I have seen here are absolutely incredible stuff. I mean, if we do deliver on the kind of work that we've seen here, I mean, tech has a great future.
Yes.
Thank you all.
Thank you.
See you so long.
And relax a couple of days if you can.
Yes. Waking up at 5 o'clock in the morning to start is not easy.
I don't know. My day starts much too early tomorrow. Yeah. Okay, guys, have a good day, and thanks again.
See you all.
Thank you, everyone.
Bye.
Have a safe journey home, everyone.
Thank you.
Oh yeah, we will try. 5.5 meters, I think. Something like this. I'm still outside.
Most accidents happen at home. Bye, everyone.
Yeah, bye, Jonathan.
Bye.
Yeah. Sorry, guys, I was just away briefly. Was there anything that was directed at me?
Did you take care of the dog?
Not yet. I'm about to do that. I did the birds. I fed the birds first. We've had must about 3 or 4 inches of rain in the last day or so. Their feeding bowls were just absolutely full of water.
Oh, yeah. Well, I'm gonna do this if you see Will before I do, because I'm gonna take off. My wife is longing for a walk.
Well,
and before that, I'm gonna sort of back up all the stuff that we did to chat and Q&A. Because if you could just tell Will not to throw anything away, and
yeah, sure. And we'll have to find a way. Well, with any luck, all it is knowing what the URLs are, and then we should be able to download them directly from Zoom.
Super.
Because normally there's a private URL, and there's also a public URL.
Yeah, there's a lot
of all the videos.
Yeah, there's a lot of people asking for backups of the Q&A and backups of
yeah, sure.
Cool. I'll do this and I'll take off.
Mm-hmm.
Thanks very much for the present, Boris. One day I'll get it.
Okay. Okay, that's better. So now. Yeah. Okay. Well, thanks, Paolo. I'm gonna head off now. And we'll take the dog for a walk now.
Okay.
I'll send. Yeah. So later today, I'll send you my. Well, I can do it now. If you can, my private Zoom room. It's a very easy one. I've got a shorthand for it. So okay. I just put it in the chat. So to everyone who's still around, you start off with the normal Zoom stuff, and you just have to do my Osros.
Mm-hmm.
And in fact, you probably don't need the final slash, and so you put all the Zoom stuff in front of that, and then my Osros, and then you don't have to try and remember numbers. So that's the nice nickname feature that Zoom has.
Ooh.
And I should get, if you try to log in, I should get an email saying that you're trying to access my private room if I'm not already there using it.
Cool. Cool. So I backed up everything from Q&A and the chat. So I'll take a rest from the computer screen right now.
Yeah.
All right, man. Thanks a lot.
Yeah. Cheers, mate. I think you did a great job.
Yeah, I love to have worked with you. Thank you. Norbert, thanks a lot for your support as well. I mean, it was really great.